Good morning, everyone. We hope you had a restful night after yesterday's inspiring sessions. As we begin day 2 of our international workshop, we extend a warm welcome back to all our esteemed participants. Before we dive into the presentations, here are a few housekeeping notes. Please ensure your phones are on silent mode. If you have any questions or need assistance throughout the day, our event staff will be happy to help. As we have a tight schedule today, I kindly request all our speakers to keep their presentations within the allotted time so that we can accommodate every session as planned. We encourage you to network, engage with the speakers, delegates, and make the most of this opportunity to connect with fellow attendees. Without further delay, let's get started with an introductory note by Dr. Anup P. Balan, Scientist in Charge, HMBGRI, Cheruthuruthi. Sir, please share your opening thoughts.
Very good morning to all of you. So today we are here for the second day of our international workshop on the research potential of Hortus Malabaricus. Before starting our technical sessions, I would like to share some points. Since most of them present here are students, you may not know much about Hortus Malabaricus and its significance in modern botany. So we are sitting here at Hortus Malabaricus Botanic Garden and Research Institute. So Hortus Malabaricus Botanic Garden is a plant conservation project started in 2015 by the Genome Research Foundation established by Mr. Sam. And our primary focus of the garden is to conserve the 742 plants mentioned in the classic botanical work, Hortus Malabaricus, compiled by the Dutch governor Hendrik van Dien during the period 1678 to 1693. So this is our garden spread over 27 acres. We have butterfly garden, aquatic plant conservatories are there, cycads, bamboos, orchids, orchard for plants, fruit plants, then conservatory of ferns, xerophytes. This much conservatories we have presently, and we are planning to establish a few more in the coming years. Main conservatories coming this year are Retd Plant Conservatory, Rare, Endangered and Threatened Plant Conservatory of Western Ghats, then a conservatory exclusive for the endemic Strobilanthes of Western Ghats, then balsams of Western Ghats, and an exclusive conservatory for palms. So these are our future plans for the coming 1 or 2 years. Coming to the garden, we are blessed with different types of habitats. Naturally, we have in our garden, we have paddy fields, wetland areas are there, and hilltop areas are there, and a deciduous forest area. Adjacent to our garden is a Vadakanjeri Reserve Forest. That's a deciduous type forest. So naturally, we have a forest ecosystem here. Coming to Hortus Malabaricus, many of you may think that it's a very old, unscientific, outdated botanical work, right? What is its significance? So Hortus Malabaricus is the oldest comprehensive printed book on the plant wealth of Asia, particularly on Indian subcontinent. It is the oldest printed comprehensive botanical work on the flora of Asia. It is the result of about 30 years of compiling and editing work by a large team of European physicians, scientists, technicians, illustrators, and engravers. So, Van Dien was not a botanist, he was a military person. He wisely used different eminent personalities from India and from Netherlands to make it done. So, he was a compiler, he was a good coordinator, he wisely coordinated and made this done. Over 200 people worked with Van Dien in this project for many years. do you believe? Over 200 people at a time worked for many years to make it done. And the book contains the description and illustrations of 742 plants, their medicinal properties and their usage. It is not only a botanical work. The book also contains information about the cultural, social, political, historical and linguistic importance in relation to Kerala. So, our Malayalam was get it printed in first time in Hortus Malabaricus. Different languages, Tamil, Konkani scripts are there. So many linguistic connections are there. Tomorrow I am going to attend another program, COSMA, a collaborative project between Kerala Council of Historic Research, Leiden University, National Archives of Netherlands. The Kerala government and Netherlands government, it's a collaborative project. They are conducting a summer school from tomorrow onwards, 11th to 14th of August. So I have to present the connection, botanical connection between Dutch and Malabar in that program. So many programs are going on parallel to this. So coming to its botanical importance, Hortus Malabaricus consists of 12 volumes with a total of 1,534 printed pages, 793 illustrations, describing about 691 species. Please note that. There are 742 plants, but coming to the species level, only 691 species. So some plants are repeating there. Under different Malayalam names, same species are described in Hortus Malabaricus. Angiosperms are the majority, 671 species. Then 2 gymnosperms are there. What are there? Cycas and Needham. Then 13 pteridophytes are there. A single bryophyte, Bryum, is there. So what is this outdated, unscientific Hortus Malabaricus? What is the significance of that work in modern botany? Here comes Linnaeus. As you know, Linnaeus is the father of modern taxonomy, and Linnaeus accepted Hortus Malabaricus as an authentic reference work on the flora of Asia, and he used the descriptions and illustrations in HM to construct types of many of the species and genera of Asian plants. That's important. Probably Linnaeus may never had seen a coconut tree. But Cocos nucifera was described by Linnaeus. Cocos nucifera L dot, right? Okay. So there was no type specimen for Cocos nucifera, and no voucher specimens are there for these Hortus Malabaricus plants also. So if there is no voucher specimen, as per the nomenclature rules, what is the other option? We can use a original illustration as its types, right? So Linnaeus used the original illustrations of Cocos nucifera in the Hortus Malabaricus as its types. That's the most important significance of this Hortus Malabaricus in modern taxonomy. Not only Cocos nucifera, the first species in Hortus Malabaricus is Cocos nucifera, HM1. The next plant is Areca catechu L dot. Same thing happened. This illustration usually Linnaeus as its type to mention, to describe Areca catechu. The third species also, Borassus flavolifer, Carimbana. Okay. So again, this beautiful illustration now served as the type of that species. So like this, so many illustrations used, Linnaeus used as type to describe different species of Asian plants. So that's the most important thing related to our Hortus Malabaricus. And he included 254 of Van Riet's names in the protologue of his species, and he adopted some of the Van Riet's Malayalam names for genera like Pavatta, Basala. So many Malayalam names he directly took to describe different genera. 15 Malayalam names were used as species epithets by Linnaeus, like Avaria Bilimbi, Papaya, Tirkalli, Betila, Piper Betil. So many local names he directly took to describe different species. And to honor Van Riet, Linnaeus erected a genus, Redia, in the Clusiaceae family to honor Van Riet. Now it's a synonym of Garcinia. Not only Linnaeus, many other eminent botanists like Adanson, Arnold Bloom, Dickendall, Hamilton, White and others erected many taxa based on Hortus Malabaricus. So many established taxonomists depended Hortus Malabaricus as a authentic reference work. But there were some problems. As this is a pre-Linnaean work, there was no clear-cut nomenclature rules there at that time. It's pre-Linnaean. And with no known type specimen, the exact scientific identity of most of the medicinal plants described in HM was not correctly known and has been a subject of debate for centuries. Since there was no voucher specimens, we cannot connect these plant names with certain plants. There may be some confusions. So there comes Dr. Manilal and his team, his student C.R. Suresh, he was here yesterday. He may be come to, today also. C.R. Suresh undertook a doctoral thesis on the topic, a reinvestigation of the medicinal plants described in Hortus Malabaricus, and awarded PhD in 1987 under Professor Manilal. And the same team, along with Dr. Dan Nicholson from Smithsonian Institute, they have published an interpretation of Van Riet's Hortus Malabaricus book. So when that book came, many of the taxonomic problems get resolved, but still problems are there. There are 742 plants mentioned in Hortus Malabaricus, and this team were able to resolve 99.9% of the plants except this plant, Chemthani. They couldn't able to identify what was the plant exactly. So it's still remain a mystery in Hortus Malabaricus. So we are conducting this workshop not only to share the historic legacy of Hortus Malabaricus, but what's next? What are the future scope of Hortus Malabaricus? We have to think about it. So our technical sessions today aim to focus on the future prosperity of Hortus Malabaricus. So here comes, there are taxonomy scope is still there. Dr. Prabhu may be presenting some genus like impatiens. So there is already an interpretation of Van Riet's Hortus Malabaricus. We need to reinterpret again. Okay, certain groups are we need to investigate again taxonomically itself to solve. There are many problems when we work on that when a particular genus, we may be able to know. So, and a reinterpretation is there is a scope for a reinterpretation. So there is a taxonomy scope is there. We can use molecular techniques for that. Then conservation needs are there. When Manilal sir and his students tried to recollect Van Riet's plants from this Malabar area, they failed to relocate many plants from the Malabar area. Many of the plants were wiped out from the area. That Malabar area means the central Cochin area. You know that it's a big urban area now. So many of the plants were wiped out from that area. So there is a conservation need is there. So CSIR may be presenting the present conservation status of this Hortus Malabaricus plants in different protected areas in Kerala. So conservation need is there. Then ethnobotanical scope is also there. Then the most important thing, bioprospecting of HM plants. These plants are huge resources of so many important biomolecules. So we have to exploit our natural resources. Then therapeutic potentials are, we have to develop, we can develop so many drugs based on our Hortus Malabaricus plants. Of course, there is a scope of microbiome research in HM plants. So keep in mind, our major objectives of this workshops are to create scientific awareness on the multifarious significance of Van Riet's Hortus Malabaricus among researchers, academicians and other policymakers, and to develop concept for bioprospecting with special reference to the medicinal plants mentioned in Hortus Malabaricus as per the modern scientific methods. With these few words, I am concluding. So this is the time for our technical sessions. I humbly request all of the eminent speakers, please stick on timing. Yesterday we were running out of time. So today we have a tight schedule, so we have to keep our time, please. Okay, thank you.
Thank you, sir, for that insightful introduction. We now begin technical session 1 focused on botanical and historical dimensions of Hortus Malabaricus. This session will be chaired by Dr. Maya C. Nair, Principal, Government Arts and Science College, Tholanur, Palakkad. Ma'am, we are honored to have you with us. We now invite Dr. N. Shashidharan, former Chief Scientist at the Kerala Forest Research Institute and one of the leading taxonomists. With over 36 years of research in systematic botany, forest ecology, and medicinal plant conservation, he has described 26 new species, authored over 100 scientific papers, and published landmark works including Forest Trees of Kerala. He is the visionary behind the newly launched E-Flora of Kerala and has received multiple honors, including the Dr. V.V. Shivarajan Gold Medal, Dr. B.P. Pal Fellowship, and served as President of the Indian Association of Angiosperm Taxonomists from 2020 to 2022. With that, I would now like to request the Chair to kindly take over and continue the proceedings.
A very warm good morning to all of you. First of all, let me thank the organizers for inviting me for this workshop. Actually, I wish to participate as a delegate in this international workshop, but the organizers entrusted me to chair over the session. And I am still a student of taxonomy, and three eminent speakers are there in this session. Dr. Cheruthuruthi sir is my guru. Even though he didn't teach me taxonomy, he said the stalwart in taxonomy in Kerala. So I am so privileged to chair this session where sir is presenting. Then we have a second presentation by Dr. Kumar. He's also a good friend of mine, and we have collaborative research going on. Then the third one is by Ramesh Muchikil. He's also a good friend of mine. So I am so happy to chair over this session. And I request Dr. Shashiran sir to take over the function.
And distinguished delegates and dear friends and students. So you mentioned, my talk is on the conservation status of Hortus Malabaricus plants in the protected areas. As part of conservation, as part of ex situ conservation, several institutions have established a Garden of Hortus Malabaricus plants, Calicut University, Malabar Botanical Garden, TBGRI, and even some colleges and universities also have at least Garden of this Hortus Malabaricus to small to great extent. Recently, there was a report in the media that Kerala Agriculture University established a Garden of Hortus Malabaricus. Due to some infight, it is not open to the public for the last 5 years. And among the in situ conservation centers, and this Hortus Malabaricus at the center is the best and the excellent. I appreciate Dr. Sam Santosh for establishing this excellent collection of this Hortus Malabaricus plant. And also, yesterday I attended that section where this Sam Santosh, the effort taken by him behind establishing this garden is marvelous. His talk throws light on the principal events in the life of Hortus Malabaricus, which was very interesting to me. But as a botanist, we always give emphasis on the botanical conference. But the life history and principle was very informative, and he presented it in a very appreciable manner. Thank you, Dr. Sam Santosh, once again. And also, for the first time, I am visiting this center. When Dr. Anupalan told me to come speak, somehow I took this opportunity to visit this garden also. So let me go to my presentation. And this Dr. Anup has presented a brief about the details. Then coming to the conservation, especially in the forest areas or nature, we have this much conservation there, covering nearly more than 10,000 square kilometers. By the establishment, we have 5 national parks, 2 tiger reserve, 2 bird sanctuaries, 1 community reserve, that is Kadalundi. And that is most interesting thing is that is one of the mangrove areas. Probably that's the only conservation area in the mangrove zone. Then Nayar Wildlife Sanctuary, Pichi Vadani, Pepara, Sendurani, Aralam, Sinnar. Well, And floristic studies of most of these protected areas were carried out. I was involved in at least 5 or 6 studies in the 5 or 6 protected areas, particularly Pichi Vadani, Shendurini, Aralam, Chinnar, Chimini, then Malabar, of course not, Irevikulam, then Madhigatan Sora, Parambikulam, Periyar. These sanctuaries I have conducted floristic studies funded by the Kerala Forest Department. So I have the database, and moreover I am keeping a database on the flowering plants of Kerala. It is almost an updated one. Then I thought that as far as the conservation is concerned, the different ways of conservation from molecular level to macro species level, of which the best way of conserving plant is to conserve in their natural habitat. So I thought that why not make an attempt to see how many of the Hortus Malabaricus plants are conserved in the protected areas. Protected area in Kerala of 2 types, owned by the government or the forest department, and the rest is the private sector. Private sector, it includes trust bodies, individuals, and there are sacred groups. These are the only 2 places where plants are conserved in their natural habitat. Then comes to the Chinnar. Chinnar has a unique vegetation, being the rain shadow regions of the Western Ghats. And the extent area, in my studies, shows that there are 952 plants have been recorded from there, out of which 237 plants are plants mentioned in the Hortus Malabaricus. Some of the unique plants, I say that Alanchium salvifolia. Only in 2 protected areas, this is occurring in the natural condition. This is Parambikulam as well as in Chinnar Wildlife Sanctuary. Then Vasalla alba. The wild Vasalla alba is occurring in there. We have the cultivated varieties with the broad leaves and more fleshy things with a red leaf as well as green leaf. But this and the other are treated as one and the same. Then comes to the Euphorbia antiquorum. There is also restricted to the dry deciduous forest. Then Euphorbia thyricalli. Then aloe vera. Aloe vera mostly occur in cultivation, but natural population is occurring. Then another is Cleome gynandra. I still remember that this plant was so common in and around our campus. When I was doing my MSc, I collected it from Koilon. Now there is no trace of that plant, but fortunately it is occurring there. Another is Leptidania reticulata, is again a dry deciduous plant. And Caproboinia spatulata or Vanda, this is the only protected area this plant is occurring in Kerala. This is cultivated. Then Datura metal, this dagger. Then Cicer quadrangularis, it's widely grown in homestead and other things, being a medicinal plants, but natural is there. Acastacia gantia, wild form is there, Soliana. Then Bengara malabarica. That's a name derived from Hortus name, but only in that Chinnar that is there. But it is very common in the sacred groves. But I don't know how it happened to occur in there, even though I have studied in the other protected areas, didn't come across. Then Abutulon and Aglaya is another plant. Then Parambiculam. Parambiculam is a fairly large area with the second largest protected area with more than 700 and 500 square kilometers area. This much plant. Then Andrographis equioides, there also, it is common in the plain, but Oclandra scriptoria, Pedalium murex, these are all plants occurring in the plains, but some or other it is occurring there, but not occurring in other area. Then Anthocephalus cadamba, then Cordia dichotoma, then Euphorbia nivulia. Nivulia is also grown as a medicinal plant, but in a protected area, this is occurring there. And another is Putratniva roseberry. This plant is occurring again in the dry patches in Parambiculam because they have the dry deciduous patches. Then there. Then I have noticed it in the few sacred groves in Thrissur as well as in Palakkad district. It is growing, but not occurring in other protected area. One is Placotia indica and Trichosanthus nervifolia and Atlantia monophylla. Atlantia monophylla again occurring in Chinnar as well as in there. And another is that Karanchi or Bondak. that was common, growing that even people have a tendency to grow along the live fence. Because of the thorny stem and the leaf and fruit, it's very difficult to protect them. Catches won't penetrate through that protected area, but our traditional live fence is being replaced by either slab wall or concrete wall and other things, or brick walls. So this is plant is, that's why this plant is gradually getting out of there. Then Sendurani plant, which I got, all the 4 plants which is shown in the first row, they are unique to that area. This is not occurring in other areas. Then come to Ailanthus, widely cultivated, then Calamus travancoricus, then Scleropyrum, and Capparis redia. Capparis redia is also noted in sacred groves, but here also, but it is a fairly wide distribution in several sanctuaries it is occurring. The number of species is 2001 Hortus Malabaricus. Then Peachy Valani wildlife sanctuaries. These are some of the that Endeda redia, which we have seen it. Then Anguina, Pambumbulli. Some people will split the stem and it will have the appearance of a snake and Keptase curios. Then what is interesting here, if you look at the plants mentioned in the Hortus Malabaricus, it is on the coast of Malabar coast, the coast of Malabar coast. That means it in the plains as well as the lowland or the midland. And that is why in my analysis I have excluded Iravikulam National Park, Pampadu Shola, Silent Valley. Because the plants occurring in the sea coast, we cannot expect it in Iravikulam National Park or Madhikattan Shola. So in my analysis, I restricted the analysis with respect to the protected areas occurring in the midland and lowlands. And among the midland, we can say that Peachy Vanadi possesses the more number of plants. The highest number of 248 Hortus Malabaricus are occurring in the Peachy Vanadi, which has 105 square kilometer area only, but support this much plant. And I don't say any plant which is unique that area. It is fairly random, but here it's important is that it has a maximum number of Hortus Malabaricus plants among all the protected areas in Kerala. Then comes a Periyar tiger. Periyar tiger reserve is the largest protected area, having reported 1,880. But when coming to the Hortus Malabaricus plants, it's only 243. And one of the important features of the flora of the Periyar tiger is it has a very highest number of grasses and sedges recorded. As many as 156 grasses are reported from Periyar tiger reserve, which includes nearly 75% of the grasses recorded in Hortus Malabaricus. So also sedges, Cyperaceae, which has 85 species of Cyperaceae. Except for the Cyperaceae found in the coastal area, all the other Cyperaceae members are occurring in Periyar tiger reserve. So that is an important one. These are then Croton tigilium, that is called the Nirvalam, that is a powerful purgative. It is even given to elephant. But this plant, I feel that as per geographical distribution, it's an introduction. But some or other, we could collect that plant from that tiger. There is Kirikadangora, Agenesia, Pycnospora, and other things. The unique importance of the Periyar tiger reserve as far as the conservation of sedges and grasses has the highest number of sedges and grasses in a protected area in Periyar tiger reserve. Then comes Aralam Wildlife Sanctuary, that is in the northernmost protected area, northern side. Here it's only some 54 square kilometers area, but as far as biodiversity is concerned, plant diversity is concerned, it is 1,004 and 198, out of which the Solana Lesiocarpum would be found only in that protected area, not occurring in it, but of course Silent Valley it is reported. Then comes Syzygium caryophyllatum, very common in the plains, especially in the laterite hillock, this plant is occurring, but not in the protected area. It is the only protected area where this plant is occurring. Then comes Psychotria dalcelliae. Here it is mostly restricted to the Konkan region, and here it is one plant is named here. I have my own doubt whether it is dalcelliae or this is a typical dalcelliae. Then Calophylla. The another is Blephariostemma membranifolia, that is an endemic and red-listed species. It is fairly wide distribution from the plains. The Peachy Sanctuary, it is there, Parambicula is there, but it is the northern side of Kerala in a protected area. Then Conscora, Caparis munii, Cissus latibulea, some of the plants which are occurring. Here, as we plain, this RLF sanctuary is slightly elevated area. So the number of plants, horticultural plants also have a proportionately low representation. Then, as far as the orchid is concerned, all the 13 orchids mentioned in Hortus Malabaricus are occurring in the protected area. Among these, Bulbophylla redii and the Stapropania spatulata, they have restricted distribution. And Bulbophylla redii is occurring in certain, in Wayanad as well as in some Alappuzha, in the mostly grown on Calophylla, Unophylla. Sacred grove, this plant is occurring. Then these are the plants which are fairly represented in almost all, even the Dendrobium ovatum. Even in the homestead it may be grown, sometimes grown even in our either jack or other trees. Then Acambi primosa, Mav is the host, Mav Maravada, that's how it is called. So fairly wide distribution, geophile and densiflorum and other Ringosia. Now the rainy season it is in the flower. So many people have posted its photos in the social media that they have come. Then another important, as I mentioned, is the protected area is the sacred groves. These are the sacred groves. I am giving a very reliable data on the number of sacred groves in Kerala because Kerala Forest Department's retired forest staff, Institution of Foresters, there is an organization. They have a mega project for enumerating the sacred groves of Kerala. I was associated with studying the plant diversity. I can say that it's a very useful work. Unfortunately, it is not in the public domain. Because this methodology was, it is very accurate in the sense, the retired foresters, they will explore the sacred groves in their area. Because some forest staff retired in Alathur area, he will explore he had the local resources, he will go and encounter their area, he will contact the person, and they noted the GPS reading, and the Tandapir, Adharathinte details under, who is the ownership, what is the deity, extended area, what is the important festival, who is the contact person, and even the route map. See, very authentic. And in almost 10% of the sacred groves, to the extent of either bigger, I have enumerated. So we could get it. That every details have with me, so I am not. So it is. We can say this is the most authentic number of, as far as sacred grove is concerned. Very important details. Since my presentation is not on sacred grove, I am not going to the technical details and other things. Anyway, these are some of the plants. You can see that as many as 448 species are occurring in the sacred groves. So, out of the 741, more than 50% of the, it is, the reason is simple, because it is on the plants of the midland and lowland where more number of sacred groves are occurring. As it is, I have given the name, Cariota and Pothos candens, the most widely distributed, then Echinocarpus, Chassalia, Gloriosa, Cissus latifolia, Cissus indica, and Ceracia, Helicteris azura, Benga. So many are there, but for want of time I am not going to the details. Anyway, then another interesting thing is we find it, even though 442, 52 plants are found, these plants are found only in the sacred groves, not occurring in the forest area or other things. Why? For example, Uvarian arum, Samadira, it is in the plains only, sea coast, and Hugonia mystax, not come across in any forest area, so also Morinda umbellata. Morinda umbellata is a very important medicinal plant used in traditional medicines, but its distribution is now restricted to sacred groves only. Then Sanonia indica, the fruit is very interesting, but only in few sacred fruit groves it is occurring. Syzygium ceylanicum, edible plant. This is Stacca liendopetaloides. This plant, we come with Olavarakav in Trikkaripur. This is the only now living population of this plant in Kerala. Yesterday I showed this picture to Dr. Suresh, and he mentioned he collected it from Nenmara. And he could collect 5 plants and rhizomes were planted in Calicut University. And funny thing is that neither flora of Palakkad by Vajravelu or Dr. Maya's students, did you come across any of the students? It's not occurring. That means that plant has vanished from there. And Dr. Ansari in his flora Kasaragod did not mention about this plant. This plant remains elusive, but we could, that what I am saying, that the importance of this sacred wood. Now there's the only location in Kerala, this plant, Hortus Malabaricus plant mentioned in survey, because of the sacred wood, which are being protected due to religious taboos and other belief and other. That is Flagellaria indica, that is occurring in the coastal areas, in good population occurring in that Thiruvananthapuram, Commetia caryophyllaceae, Barringtonia racemosa, again a mangrove, Vitex pinnata. More distribution of this plant is towards the northern, southern Kerala. In North Kerala it is very sparsely distributed. Another is Salacia chinensis and Calamus road. Salacia chinensis did not occurring in the protected areas. Very sparse distribution in forest area. Whereas Salacia fruticosa is very common both in the sacred groves as well as the forest area. This plant which I took photograph from Alappuzha, Vandanam, which was a fairly big one. Then later I went, this plant disappeared because it's being collected, but I don't say it is collected, easily stolen. Either by researchers or by medicinal plant collectors. So plants which are of economic importance, some more there are tendencies. Recently there is a report that one man has stolen coconut bottles from a shop in Alappuzha. whatever it is called, costly things, Calamus rotang, again restricted to there. Then, the major threat to this sacred groves is the invasion of exotics. And another interesting thing I noticed that due to religious belief or taboos, no plant material should be removed from the sacred groves. If at all it is an invasive one, don't cut it. It is against the belief that do not disturb. And another thing is that in certain areas, particularly in Alappuzha and Pathanamthitta district, there is a belief that only Ulladan tribes can enter into the sacred groves, either do collection or even planting. Because there is a project funded by NMPB on the giving financial assistance to the sacred groves of Kerala, and I was involved in monitoring and evaluation. Then we were told that why you are not removing it, now we are not getting Ulladans. So we cannot remove it. And I told whatever it may be. And another thing is that you see the Costus pictus. Some 10 or 15 years back, this was introduced as a remedy for diabetes. And many people bought it. And several agencies used to fund it. Forest Department has a project on enriching the medicinal plants, National Medicinal Plant Board, State Medicinal Plant Board, with the condition that you should improve the diversity, enrichment planting, providing fencing, and irrigation facility. These are the 3 areas for which they should utilize. They will go to the, once they receive the fund, they will go to the local nursery. They say, this is medicinal plant, buy it to something. Without knowing that now it is an invasive weed. Now the problem is that they cannot remove it because that from sacred no plant should be removed. At what cost? The indigenous flora. Then I told Dr. Varma as well as Dr. Avi, whenever you are introducing an exotic plant, it should be registered with the State Biodiversity Board. only studying the plant, can it become an invasive in future or not, then it should be permitted. Now it is a business trend. Several fruit trees, you know, these people, by mistaken identity, they will get, out of curiosity, some people are crazy about, oh, I have a baraba fruit. It was a one plant which was introduced. I tasted it. It is not tasty. It's not. Several homestead I have seen it. Sacred goose that I have seen. Nobody is touching it. So they want it. Another is Pereschia bello. It's an attractive flower. The funny thing is that you cannot destroy it. If I tell you burn it, it will survive. And again, that is creating trouble for spoiling the India. These are some of the things which we have to look into it. Sacred goose, of course, it is to be sacred, that is why it is. But this type of invasion, another is the management of climbers. Some areas is Compreton latifolium, whatever liver, it's a very extensive climber. I have seen when to see in a big sacred grove at Kovilon, very rare endemic plants trees being smothered by this overgrowth. I told that some or other, unless you cut it, some trees are already done, so we cannot cut it. It is against their belief, no cutting. Ultimately, we have to manage it, but some or other, these are some problems that is also affecting the survival of this place. Then comes the water bodies. And here is the critical area because none of the water bodies are coming under the protected areas. Mostly small, shallow ponds, riverbeds owned by private ownership. This may disappear at any time because there is no legal. As a landowner, my vision or objective is which is the best land utilization, which is the best land use so that I can get maximum remuneration. Either convert it into some other crop or other. Here least priority will be given to the plants there. As a owner of the house, which I have to generate some income, I have to use an alternate land use where the conservation has low priority. Ponds. And some ponds, I have noted that once in a while these panchayat people have the problem of cleaning the ponds, at least 3 or 4. It is the aquatic plants that we are removing. But anyway, we cannot blame it. It has to be kept clean and neat. It has to be removed. But that process it is being noted. Then this and Neptunia prostrata. It was very, now it is mostly confined to the northern Kerala, some paddy fields. And the photo which I have taken in 2007, I don't know whether it will still there after say 18 years. It may be there. So also, and some Nelumbo Nusura, so many varieties are there. Some are there is a coastal Spinoclea. They are in the marshy or mangrove associate. Then which are out of this 742 species, there are so many exotics in there which need no conservation. Because several horticulturally improved varieties are being developed over the years. And these are some of the which is good. Take the case of guava. How many varieties are there? Now, Thailand pink, very big, even some weigh 1 kg. That are big. Then at what cost? Whenever we have the fascination for gain for these new varieties, at the cost, we have replacing our traditional varieties. I have planted one Thailand variety in my home. It flowered, no fruits, lost 350 rupees for me. It is not growing. So, always it is there. Then this Manilkara Kaukia, I don't know how it came, but I have noted this plant growing and producing fruits in the John Mathai Center in Thrissur. Later, one of the retired forest officers sent me a photo from somewhere in that Thiruvananthapuram university area. There he could find bush growth. That actually that plant photo is from there. So such plants are also occurring here, but they are exotic, but find mentioned in the Hortus Malabaricus. So also exotic garden plants. These are all part of Hortus Malabaricus one. So hibiscus rosa sinensis, how many varieties? Devi Priya Vijay done work on that. She has 64 varieties of hibiscus alone. There are some of these Salpinia pulcherrima, even 3 or 4 colored varieties are in the campus itself. Then Clitoria ternatia, double petal one, pink, white, several. And this Pentaphytus phoenicia also find mentioned in the Hortus Malabaricus, but only at a Kayangulam one place I could see this plant. But the illustration is very much matching with the photo image which I have given. There is no problem of mistaken identity, but it is now almost disappeared. Maybe that was grown as a home garden plants in there. Then vegetables. These are all mentioned. Cucumis, how many varieties? Karivepu, several. Then Dioscorea. And this is mentioned, I mentioned about the Basal by the cultivated varieties and the wild varieties. This is a much improved one with the Ipomia betatus, Kumbulanya, red gout. These are all points mentioned in the which need no conservation at all because it is being horticultural importance. Plant disease even otherwise. Then another plants which are also in cultivation. Some are exotic. Our small millet elite in Corocona, jasminum, Seiba, coconut, several varieties. So, Sapangam, Aracanut, this is Bendangia, Kundapana, beetle, Sesbania grandiflora with even the red flowers are also there. Capsicum, these are Musa paradisiaca, so many varieties we have. Some are hybrid, you remember. So, these are the plants. I should also keep time, it's exceeding. So then as far as IUCN red listed plant, these are the plants mentioned in Saraka, Shoga, Blephariostoma. Some images I have already shown. And another plant is this one interpretation I am doubtful about is that Simplacos perium. Anyway, this Simplacos manantha, it is interpreted as one perium something that I forgot it. It is occurring only in Periyar Tiger Reserve at an altitude of around 1,900 to 2,000. This is the only location, and in fact we are the people to first relocate it. It's after the type collection from Periyar at an altitude of 900. In no way this possible that it can be a Hortus Malabaricus plant. This may be some other than and 1 or 2 species which are yet to be identified, which is and Hortus Malabaricus, as Dr. Anup said, it has certain limitations. But with that, it was a tedious task for Dr. Suresh and Professor Manilal to elucidate the plant. And whatever they have done, we must appreciate it with very scanty information for many of the individuals to interpret it. Even Dr. Suresh has come to me and show what is this plant, and then I have my own restrictions. Any other mangroves, as I mentioned, so fast disappearing. I am fortunate that Kadalundi Reserve Forest established in the mangrove area, but I don't have much details on the flora available, but these are the plants which are usually seen in the other thing. Then these are the things, best utilization. And thank you all. So thank you all of you to giving me an opportunity to make an awareness through picture and other thing. And sorry whether I exceeded the time allotted to me. Thank you once again, all of you.
Thank you, Dr. Shasiran sir. Now the topic is open for discussion. And as we have to stick on time, please restrict the questions to 231. Then after a discussion, you can personally interact with Dr. Shasiran regarding any doubt as shown in the photographs. He had
question is, by declaring as wildlife sanctuary, whether it helped to conserve these plants, or and over the years, what change you could see, because you have for the last 50, 60 years you have been conducting these explorations all over the wildlife sanctuaries. And from your observation, what you found, whether these plants are able to we conserve in these wildlife areas rather than, not declaring as a wildlife? What is your...
This is very idea behind establishing this wildlife sanctuary protected areas. If you examine it, quite often it is associated with a hydroelectric project. Periyar, Neyyar, Peechi, Parambikulam. Once you establish construct a hydroelectric dam, Peechi Vadani Dam, there is a least consideration for flora. That time the concept was Anamailotaka. Bigger mammals, whether elephant is there, tiger is there, or gaur is there. Nobody bothered about the plants. Even creating a reservoir of 40 square kilometer, how much biodiversity would want for conservation. Anyway, we need that. As it changes, it is definitely happening. For example, in Peechi, when I studied flora, which was published in 1984 or 83, there is no presence of Hyptis capitata. So also several few other plants, it was not there. Then after in 2007, I had an opportunity to visit there. This plant is spreading like wherever there is moist locality, this is presenting. It is not a palatable grass. That means once it established, it is very difficult to eradicate. Then this year, I had to visit a part of that sanctuary in Olagara Peechi sanctuary. I could see that Polygonum plebeium is fast, not Salvia plebea. It's a plant with a sticky fruit. It is fast spreading all over the undergrowth of forest area and even the neighboring tribal settlement or Unnadi. It's a no plants, it is so far spreading because it is easy to people have their own cattle and other, it will get attached to the fur of the animals, or if we walk, even our cloth will also get it is fast spreading. Like that invasive species also fast, it is intruding there at the cost of native biodiversity. The funny thing is that it is non-palatable species, so that the fodder availability is also getting decreased. It is really happening. You are right.
Thank you.
Hello, sir. Ritesh from ARI here. So, first thing before going through queries, one thing I would like to do that, having worked on the flora of Siam and Vietnam, I have huge respect for this biodiversity documentation work. So we don't have anything to offer. Rather, I would like to give a standing ovation to your work, and I request everyone to do that for the wonderful work. Please give a standing ovation to this wonderful work which he has been carrying out.
Thank you.
So thank you so much, sir. And yeah, you are the best person to suggest something how the research potential of Hortus Malabaricus, please take a seat, potential of Hortus Malabaricus can be further explored. And yeah, we'll have more discussion on this session. Thank you so much, sir, for showing wonderful plants and talking about all these rare and endangered plants. Thank you so much.
Thank you, sir, for the interesting presentation. May I now invite Dr. Anu P. Balan to kindly present a memento as a token of our appreciation.
So now we will move on to the next presentation. So let me invite Dr. K.M. Prabhukumar, Senior Scientist, CSIR National Botanical Research Institute, Lucknow. And he will be talking on explication of the taxonomic identities of impatient species mentioned in Hortus Malabaricus. Welcome, Dr. Prabhukumar.
Dr. K.M. Prabhukumar, Senior Scientist at CSIR National Botanical Research Institute, Lucknow, and curator of the LWJ Herbarium, the third largest in India. With over 18 years of expertise in plant taxonomy, nomenclature, and conservation of threatened and medicinal plants, Dr. Prabhu Kumar is a fellow of the Linnean Society of London and has described more than 60 new plant species to science. He has been honored with several prestigious awards, including the Professor K.S. Manilal Award, and is actively involved with multiple IUCN specialist groups for species conservation. Over to you, sir.
Thank you, Shabas. And it's a very happy moment to me, especially I hope I met with Shamsa in 2013 or something. And the way what you are seeing in today in Hortus Malabaricus and what is in 2013, we will ask what I can do. I am alone what I can do. This is the best example. A single person can, how a person can make history, just like S. Manilal. How in Shamsa, one person Sham, he is making outstanding conservation of the traditional plants mentioned in history. A tribute, a gratitude, a big applause to Shyam sir. I am coming to, see, special thanks to Shai sir, because the audience face is awesome. Everyone is interested. All faces are very happy due to your outstanding presentation. How to present the spirit. You can see how a person can love the plants, the way he presented. There is no need of any legend. There is no need of any names. He can see with the plants, which is these plants. So thank you, sir. Here I am just going to take a small topic. Out of 742, only 6 or 7 plants what Van Reed is noted as Onapu. Because why this is mentioned as Onapu? Because these plants are start flowering in the Onam timing, that is July, August, September, very maximum 60 to 90 days this flower will be there. So I am appreciating Suresh Babu sir, Mandlal sir, and also Nicole's son. They did the outstanding contribution how to interpret the plants available in mentioned in Hortus Malabaricus with very limited knowledge. What Shai sir is mentioned, there is a lot of limitations when we are coming to the Hortus Malabaricus. It's an outstanding work. I'm trying to just to authenticate what is the balsams mentioned in Hortus Malabaricus. So before going to Hortus Malabaricus, I hope I need to mention few workers. We are believing Hortus Malabaricus may be the first, but before that more than almost 5 records is already available about Indian history. That is starting from Garcia da Horta. He is a physician. It's a very good naturalist. And when he is joined as his official things, especially in the Goa regions in 1534 to 1564 duration, he just documented very limited, around 57 species, what is traditionally used in that period. And that is recorded the first document about Indian history, Indian soil, about the plants. And coming to later 1578, Acosta Christobi, he is first illustration based upon Indian plant, that is by Acosta Christobi. He has done jackfruit, cocoa, or even Piper nigrum. What is the first illustration that is by Acosta Christobi? And again in 1597, John Grad Herbal, he is the first English herbalist. He just provided some images, seeds of plants, what is mainly in Asia and America, how it is reached that time in the European countries. Okay, again 1598, John Huygen van Lincolnstein. He is the Dutch merchant. He maybe first realized the importance of the spices, how it can change the world. And finally, there is a Charles Carolus Clusius. He may be the first person changing his name before Carolus Linnaeus to Latin. His name is Charles du Ilcios. He changed his name to Carolus Clusius. And in his book, he is mainly disseminating how is the work in 15 by Horta and Acostas. Finally, coming to the picture, Hortus Malabaricus. Hendrik Adrian van Riet Tagastein. There is no need to introduction about anything because today is, or yesterday is day what we are celebrating. If someone is yesterday came there, visited, there is a signboard is there, Kamalin. Because even still there is a small mystery is there. How many people is assisted Van Reed is starting from 25 to hundreds. And especially very outstanding European collaborators, Jacques Kamelin, Janssen, Amlo Van, Johann Series, Johann Munix, Abraham Poot, William Tengreen. These all are the outstanding fellows that I helped Hortus Van Riet for doing this masterpiece. Apart from these, the illustrations by Anthony Jacob Jadkin, you can see the signature in the left, and Marcellus Splinter. These are the two major illustrators that did the contributions on it. Again, there is no need iti Achyutan Ved, because that time without a traditional hero or traditional Vedian, we can't to touch the Indian history, Indian culture. And there is, with the association of three Konkani trios, Apu Bhatt, Rangabhatta and Vinayaga Pandit, they documented the outstanding, the traditional knowledge of that time. This is the agreement, what you can see, MOU signed between these peoples. Again, coming to the taxonomy part, this is the Nicholson, Suresh Babu, K.S. Mandlal trio, another trio after Konkani. They did the history behind the Hortus Malabaricus. And every person have a moment to realize what is my duty in this earth, why I born. So, K.S. Mandlal is also recognized his vision about why God is given an opportunity to born in this earth. That opportunity he realized when he is in the FRI for some references. One day he's found that there is a lot of Hortus Malabaricus, especially it is in Latin. That time he is not that much aware about Latin. And once he's read one line, if applied on the left toe improves the clarity of the vision in the right eye. He's totally amazing how plants can do in this earth. So that is the moment he realized, I need to hold Hortus Malabaricus. So history begins in FRI. So for me, when I am working on especially to delineate how to explicate the Hortus Malabaricus plant, what the major characters, what I identified, that is the most, out of 742, nearly some hundreds are repetition, still hundreds are, we are not realized the therapeutic value. More than 522 to 600, they have selected only based upon the medicinal properties. Second, surely there should be local availability of the plants in that time. And I can't tell exactly 800, still what SAR is telling, similar course. It is that identity we need to recheck, because the maximum 99% of the plants what they had selected, the altitude is maximum 300, 400, that indicates they are selected only from the local areas. Many plants in Hortus Malabaricus, they are single maybe, that is generic representation 1, 2, many are with 3 species, many are with 4, 5, and you can see more than 5 is Ipomea or ficus species, figs. They are holding 14 fig species. Here they are mentioned in the Hortus Malabaricus. And in here, I'm just taking only impatient. They are holding 7 species. Okay, this is the 7 tabs. 7 tabs now we can talk as figures. And in that, in Latin, they are used as tabula. Just before going to the 7, just I am showing a few small introduction about balsams. Balsams are herbs, either shrubs, perennial or mainly in annual for varying a wide range of habitats and with a very peculiar zygomorphic flower. And it is known as impatiens only due to the impatient nature of the fruit. And when Linnaeus started to validate or propose a system of classifications, he put impatiens in the family Geraniaceae. And in later in 1822, Elian Richard, he proposed the family Balsaminaceae. And presently, the family Balsaminaceae holding 2 genus, the monotypic Hydrosera with the monotypic Hydrosera triflora, and the largest balsam genus impatiens with 1,167. At presently, this is 5 hotspots are there, starting from in India, it is in the Western Ghats, Sri Lanka, Africa, Madagascar, and in India, then in the Himalayan zone and East Asian countries. And in India, this is holding the largest with 349 species of balsams presently in India. Again, in 69, even though Hortus Malabaricus Van Riet is mentioned, in later, Augustine Rivino, he proposed the first name impatiens before Linnaeus, and Linnaeus just validated the name impatiens, and this is the first illustration available for impatiens, and it is later named as impatient noli tangre. And then balsamnus is coming. Just coming to the historical concept. In 1859, the Hooker and Thompson, they are first proposed infrageneric classifications and 7 sections, and in later, again Hooker in 1874, he proposed 12 sections based upon the different morphological characters. And later in 2012, Dr. Veerlinga Bhaskar, he did a complete study on Western Ghats with 7 sections. Now again, we are coming to our tabs. So how to, the major characters to authenticate the balsams, it is based upon the altitude range, nature of stem, either terete or angular. And this is we can see, this is known as the standard petal. And this is the lateral united petals in the pairs. That is the basal lobe, and it is the distal lobe. And there is a lower sepal, and there should be a spur. This is the major character to delineate the balsams. And there is a very peculiar character. There is a projection behind the side of the petal, and it is known as dorsal auricle. So this is the tab 47, what Vandre is mentioned. And there is a tab 47. You can see the languages in different Arabic, in Malayalam, and in Nagaric, Tulu, and 5 languages it is written, including Sanskrit. And this is the Latin, what they are written in the Hortus. And after that, this is the interpretations of that one. And finally, they are identified. This is impatient chinensis. Okay? And you can, so now we are coming. What is the major characters? They are written leaves are subsessile with opposite view flowers, exactly matching. And they are writing wing petal is a single lobed with a stipe and dorsal auricle. Here the first our doubts start. Because what the species they are mentioned as impatiens fasciculata, it don't have a dorsal auricle. Okay. So you can see this is impatient fasciculata. You can read in Malabar tab 47. It is very clearly written. So this is the species what we are presently calling as impatient fasciculata. Okay, very long spur and without a dorsal auricle, and it have a basal lobe. They are very clearly lobed. It is a wing petal is single lobe, but it is bilobed condition. So that means the fasciculata interpretation is little bit confusing. So we are behind this one. So then we found, this is the drawings. Then we found that a species distributed in Cochin, especially in Ernakulam ranges, it have a single lobe concept with a very specific dorsal auricle. You can see the dorsal auricle in the basal lobe, very prominent. Body is drawn in the picture, and then 47 we are finally confirmed as this is impatient regulator against impatience fasciculata. Then again the question will come, what is the so far called impatient fasciculata? So again the taxonomic literature, it is found that there is a species published by Jolsna and Janardhanam during the northern impatiens. They are identified as species impatient vivekanandani, presently confirmed as considered as a synonym. Now we are reinstating as a species for the name impatiens fasciculata. Vivekanandani should be a what is present accepted name for this one. Going for the tab 48. Again, language, we can see everything. So when we are going to the interpretation, this is interpreted as impatiens latifolia. That is impatient latifolia by Linnaeus. You can see Velia Onapu, Reed Malabar, 9P 91, tab 48. Habitat in India. So angular stems, flowers are bilobed, perfectly matching, but seeds are covered with hairs. What the species what we are seeing in latifolia, there is no hairs. So again, we have found a very common species started in from the 10-meter altitude available in throughout Kerala. So flowers are bilobed, seeds are covered with perfect hairs. So this is nothing but impatiens dasyosperma, very common species distributed in the southern regions. Then even we can go to the some to confirm it, the seed characters, we can see not only the hairs, the pollens are impatiens latifolia is tetracolpate, and it is tricolpate in the Dasyspema. So again, what is the identity of the plants now placed as latifolia? This, I got an privilege, I got an opportunity to honor our legends, living legend, the hidden legend of behind the Hortus Malabaricus. So we are named it as Impatient Sureshi for a honor to C.R. Suresh for his outstanding contributions to the Hortus Malabaricus. Again, tab 49, impatience. In interpretations, they are named as impatience tilo, because in the previously it is known as impatience balsamina tilo by D. Consul, but later White and Arnott in 1834 they are named it as impatient reedy, because they are telling tilo is a generic name. But that is against the ICN rules. So C.R. Suresh Babu, they had changed, make a combination. They have rejected the impatient reedy and he make a combination as impatient tilo. And he's used as a type impatient Cheria Onapu, read for tab 49. Okay, this is the impatient tilo, and later studies by all the White, Arnold, Hooker, including Virlinga Bhaskar, they are synonymized. This is a variety, this is a synonym of impatience minor. But this is the reedy what White and Arnold done. But we found that it is a very peculiar species because it have a bilobed condition. You can see in the base there is a bilobe and it is very clearly written in the Hortus. So what the authentication done by the Nicholson or Suresh, it need to be reinstated, and the name, it need to be reinstated as impatience tilo. And one more thing, even though we are all our search in all over India, we never found any sheet of impatience tilo. There should be two reasons. After Hortus Malabaricus, tilo may be no one collected. There is very less chance what we are interpreting from Hortus, from the impatience. Once it is dried, it is very difficult to understand whether it is single-lobed or bilobed. Maybe in many herbaria it is there. But again, we are authenticating the tilo after Hortus Malabaricus in here. And again, tab 50 and tab 51. Okay, this is, they are authenticated very clearly, Onapu. Identity is impatience minor. We verified all the prologues from the Hortus, and we are just reconfirmed that the nature of this flower, you can see, very small flower with a long spur. This is, all the wing petals have a single lobed condition. We are confirmed that is impatience minor. Then the tab 52. Tab 52 is only written as Onapu, and in the interpretation they are confirmed as impatient balsamina. It is tilo Onapu notanga. In tab 52 they are used as impatience balsaminas. Again, you can see the opposite leaf condition in impatience. What Van Reed is shown in the Hortus Malabaricus, phyllotaxy is opposite. Again, coming to the balsamina, that is only as alternate leaf concepts. In all the balsamina, impatient balsamina, even though it have multiple varieties, it have in a microcephalous section, that means leaves are alternate in the section microcephaly. But in drone, it is very clear that even though spur, the lower spur, everything is matching, this is simply we need to reject it because a sectional concept is larger than the spur concepts. So we are just rejecting this one. And then we found there is a one species, it is very common in the Ernakulam and common regions. It has the same spur with an opposite leaves condition. This is the most common impatience rubicola, what is available in the southern part of Kerala. Okay, so at the final tab 31, they are used as Kondampulla, impatience pedunculans. The major confusion is starting from impatience oppositifolia. In Linnaeus, he is given a question mark. I think after that study, many of the pupils are missing that question mark. Even he used for the proposal of the name impatience oppositifolia, he used the type from habitat in Ceylon. He is not used, it is in Hortus Malabaricus. For Hortus Malabaricus, he is given a question mark only. But maybe further the subsequent researchers, they are missed that question mark. And later onwards, it may considered as the type of impatience balsamina. but you can see the flower structure, everything. This is not at all matching with any non-species of balsams or any balsaminaceae. So this is the second puzzle now for the Hortus Malabaricus. Still we don't know which is this plant. Even what the reason, the last puzzles, it is still we can use as some forms of ramphia, but now this is a big puzzle for us. We don't know what is this plant. So this is the oppositifolia what is available in Sri Lanka. This we are taken from the flora Sri Lanka. It is not our picture. So the puzzle is starting. This is not impatiens. Oppositifolia are not even in impatiens. So at the final, tab 49, apart of fasciculata, we are authenticated as ligulata, and we are reinstating Vivekanandani and considered ligulata as a synonym of impatient fasciculata. Again lactifolia, authenticated as Dasyasperma, and the present Dasyasperma we are giving a new name honoring to C.R. Suresh Babu's impatient Sureshi. Tab 49, Tilo, we are reinstating with perfect authenticity. And 50 and 51, minor, it is already resolved. We are reconfirmed the authenticity. Balsamina is changed into rubicola. And tab 31, a new puzzle, we are excluded from impatiens. I hope I keep the time. Thank you.
Thank you, Dr. Prabhukumar, for the excellent presentation. So after hearing the presentation, I am sure that the students might have got an idea that there is a lot many things to resolve from Hortus Malabaricus. So there is ample scope of research in Hortus Malabaricus, and excellently presented all species that is being disseminated here kindles the research mind in all the students. And the final one, the impatiens oppositifolia, from the picture itself, doubts whether it is impatiens or not. So I hope there may be some doubts from the young minds. If there are any doubts, please.
Sir.
One young mind is turning up.
Youngest. Excellent presentation. I think no need to, tell about any, And I was wondering, Dr. C.R. Suresh could not do the validation of all the species which is mentioned in the Hortus Malabaricus, or you are doing it for the first time?
Who's?
No, all these species of impatiens. Validation of the species, you are doing it for first time. C.R. Suresh and Dr. Manlal could not do it properly.
Sir, it is already done it. It is a collaborative effort. What is the material available in Q also that time by Nicholson, because Nicholson is a collaborative worker. So we can't to tell, it's a collaborative work with S.MONI, Suresh Babu and Nicholson's.
No, what is
what is the availability available in now with
what is the new contribution which your group is making in this? So that's what as a layman I am asking. I am not asking as a taxonomist. Yeah. As a layman I am asking. So.
Sir, for example, impatiens balsamina. Impatient balsamina, we are include with so many medicinal importance. When an impatiens balsamina, what the first criteria for the selection of plants for Hortus Malabaricus, that is the therapeutic value. Okay, when a plant of impatient rubicola is identified as balsamina, that means the therapeutic value of balsamina is unknown. Now we need to start from the zero. Because rubicola, there is single effort has been taken to understand what is the medicinal importance. When a plant name is changing, the overall history will change.
Yeah.
Thank you, Dr. Prabhu, for presenting your work on impatiens. This is an example how this taxonomist has been doing a research. Am I audible? Here, in research, we have two types of research. One is called positive result-oriented research, especially in biotechnology, agriculture. For example, I am not blaming anybody. If you design an experiment, applied a pesticide or an insecticide or anything, evaluate the crop, whether it is prosperous, how much increase it, it's a positive result. When you do a taxonomic research like this, many research students of mine, how to stop it? because the problems are immense. With the limited resources in a balsam, how the tiny variations can delimit it into or segregate the taxa? This is a very vital question. Here comes the taxonomist. He should have a concept of the taxa and his taxonomic judgment. These two things are always in the mind. If you would accept and include it, your work will never stop. When new information comes, whether I am thinking what I did was correct. And unfortunately, taxonomy is a branch. It accepts data from from mathematics. We have numerical taxonomy. We have chemotaxonomy. We have phytotaxonomy. Even embryological taxonomy. Even now, molecular taxonomy. Any branch of taxonomy will accept this much data because it all started with the chance theory of evolution. Before that, it was natural system. Thereafter, it is the orientation is to come to a phylogenetic. With that, we have several systems, cladistic theory, then what you call that modern system. Even I forgot it. APG system, up to 4 versions. There is taxa is changing it based on the molecular type. It may be a family there, it may be a genera, or even merged. If you come to classic taxonomy, species put in a family is entirely different, or merging or segregating it. So taxonomist problem will never end it. It will go on. Everywhere. One thing is, it will be keep you engaged like me. Thank you.
Thank you so much, sir. Thank you, Dr. Prabhukumar, for the excellent presentation. Thank you.
Thank you, sir.
Thank you, sir, for delivering such an informative and well-structured session. As a token of our sincere thanks, may I invite Dr. Anup to present a memento to Dr. Prabhukumar.
In fact, I invited Dr. Prabhukumar to resolve the taxonomy problems in Hortus Malabaricus, but actually he make it more complicated. So there is a scope of a reinvestigation of the taxonomy of plants in Hortus Malabaricus. Students, please note.
So now let us move on to the third presentation of the session by Dr. Ramesh Muchikal. He will be talking on ethnobotanical perspectives of Malabar coast during 17th century as evidence from Van Riet's Hortus Malabaricus and future research potentials. And he is an assistant professor and herbarium curator of Department of Biology, Jason University, Saudi Arabia, a native of Palakkad itself, a friend of mine. I am so happy to invite Dr. Ramesh Muchikal.
With over 27 years of experience in plant systematics and ethnobotany, Dr. Ramesh has led floristic explorations across India, Sri Lanka, East Africa, and the Arabian Peninsula. He has authored over 75 research papers, described new bamboo species and genera, and currently contributes to Saudi Arabia's National Vegetation Mapping Project. He is also a fellow of the Indian Association for Angiosperm Taxonomy and a recipient of prestigious fellowships, including the DST Fast Track Young Scientist Award, the CSIR Senior Research Fellowship, and the UGC Dr. D.S. Kothari Postdoctoral Fellowship. So, we are honored to welcome you back.
A very good morning to everyone. I'm very privileged and happy and blessed to be here. On the most favorite topic, I fell in love with doing my PhD term because of Professor Manilal. And almost I'm connected with the Hortus Malabaricus almost, this is the 25th year, because when I was a student of PhD registered under Manilal in 1999, after that, in a casual talk, he was engaging with the final edition and translation of English version of Hortus Malabaricus, and he explained a lot of effort and stories, the translation and all. And I immediately fascinated his dedication and work, and I voluntarily announced him, I will help you for the final edition. And so this relation started from 2000. Now we are in 25, almost 25 years. I'm connected with Hortus Malabaricus directly or indirectly. So this presentation I'm dedicating to my beloved professor, because he introduced me in the field of ethnobotany, at the same time the Hortus Malabaricus. And my presentation, some of the part, because there are a lot of young mind, and I want to explain something regarding the historical aspects of Hortus Malabaricus. So I reserve some slide for that. In fact, Dr. Anup and Dr. Shashidharan and Dr. Prabhukumar explained many. So I'll skip whatever that I prepared, but I will explain in between some of the slides they didn't. Anyway, it was very excellent session by Dr. Shashidharan, because we shown many of in tabula or pictures, and he shown all the plants in reality directly. He touched with his hand and experienced that. It was a wonderful session. And Dr. Prabhukumar is, as an example, illustrating Hortus Malabaricus plants not solved, but we have to appreciate the effort of Dr. Manilal, Suresh, and after that a great expert, Danich Nicholson, regarding, he was the best expert in nomenclature, and he was the editor of Taxon for a long time, especially the nomenclature session. And connected with him, they resolved maximum problem, and what they did was, for the time being, as much available literature to solve the problem for them. But it never end. What Dr. Shastran said, taxonomy is a conceptual knowledge, and one person or any taxonomist are close contact and doing a lot of things by his hand, and many other multi-taxonomic techniques, he may develop lot of new concepts. So if you have a very good concepts, will be a very good taxonomist, and he can resolve many problems. And Dr. Prabhukumar is an example. I appreciate. He is a young botanist and promising botanist for India. I will go to my presentation. So there are a lot of attempt for the Europeans for depicting the Indian tradition knowledge by Garcia, Dota, Christopher Beck, and after Hortus Malabaricus, Fleming, Einstein, and what like that, because Europeans' interest was the plant wealth of India, because at that time major traders were, because we have a trade from Arabian traders came to different part of India, and they taken many spices and medicinal plants from India, and they sold to the Europeans, especially our spices. An amazing experience with the spices. Europeans was also always thinking about where it came from that. And that was the story begins the colonization. Arabians never even disclosed the idea of their plant source like this. Finally, they find a trade route, and even a colonization started, and that is the story continues. So we have so many publications like that, but Hortus Malabaricus, that is a different one. It's a unique one, because it is it is a model of the flora and scientific documentation of the traditional knowledge for the first time in authentic way, with the pictures and with the certificates of the original knowledge informants. So we have many now we are in the scenario of the protecting, safeguarding intellectual property rights and all. But Van Reed, we have to appreciate his concepts, and because he directly with the proven knowledge of the informants. Who were the informants? That was a Irava Kollat family, Vaidyan Hitti Achudan. and 3 Konkani Brahmins and many others, and even Hortus Malabaricus. These are the people, they came in front, but behind so many workers, plant collectors, and it took many years. They collected plants from different parts of the Malabar coast, and they were camping in some location with the supervision of Van Reed, and they documented in between like that. So Hortus Malabaricus still remain an evidence for scientific documentation, and even with the authentic certificate. We can see many certificates of it, like the Konkani Brahmins, like our PhD thesis, we will make a declaration and certification. So this is certified, so all the knowledge, best of my experience and truth like that. So that is a truthful, I mean, even we can, these all are even tested by many reviewers during that time, even headed by J. Komalin et al. So it is an authentic and scientific information. We never even expect during even almost 300 years of such kind of a documentation happen like that. So that is about Hortus Malabaricus significance. And already I explained, I'm not even Europeans even since even until development of the modern medicine in the early beginning of the 19th century, all the world solely depend upon the plant-based medicine. There is no other source for even for the remedy for their various ailments for animal or plants, whatever. So the botanist was have a very prominent role during that time until 19th century. So for example, the father of our taxonomy, Carl Linnaeus, was the same time a professor of botany and professor of medicine, because the source of medicine was plants. Even nobody knows plants, or so his treatment until will be a failure. So an expert botanist will turn to be a physician or the doctor like that. So we can see most of J. Komalin also like that. So all are at the same time practicing medicine and like that. So that I already told you, the Europeans was eagerly waiting for many of the raw drugs plants sold by Arabian people. They came to India even 5,000 years ago, and they collected plants and stayed somewhere, and that is a history of exchanging. So we have a long connection with even Saudi Arabian and Arabian region, Arabian Peninsula. And so also they came by some country old ship like that, and they stayed here. They collected a lot of products, and they constructed, there are records that they constructed ship with annually and take by employing lot of our local artisans. And after they make a big ship, and with this full of load with medicinal and raw drugs, they traveled directly to Europe and sold it, and like that come back again. That was the exchange. So Europeans want, we want such kind of collection. And so once colonized Dutch, they faced a lot of problem for medicine for their soldiers, and also Van Reed was employed to make some collection. Also they need authenticated information of the plant. So that was the history of the mission for starting a Hortus Malabaricus, to make an authentic information along with all the guided illustration, everything. So many people can practice like that. So he want to make a manual or model of such of a publication like that. So that was history. So Henrik Anton, no need of explaining. Yesterday, the creator of this garden, Mr. Sam Sandosh, explained a detailed history of the even the journey of the Henrik Anton Van Reed taught Latin. He was born in 1663 as a soldier like that. His area was connected to Sri Lanka and India. So many plants, some of the plants mentioned in Hortus Malabaricus, I think they also got collected from Sri Lanka also. Sometimes there will be. So Dr. Prabhu was discussing some last one. There was, so maybe that much Sri Lankan, many plants you can see from the Sri Lankan region, because even some of the soldiers collected while they were in Sri Lanka, they collected some plants and brought to the camp and like that. That may be a mismatch. So like that. So no need of further explanation about the history and all already mentioned. and who should, behind this Hortus Malabaricus, that was these are the leaders, but there are many other traditional physicians also worked behind it, but led by Itty Achyutan, and most of, because Itty Achyutan belonged to Collard family of Cherthala, and they have a palm leaf manuscript of traditional medicines they followed. You know this because during that time there is even the history of India told. So many of the Ayurvedic traditions start from the Atharva Veda. So that is for not for some, but even many of the Brahmins not that much interested to study Atharva Veda because they are in Rig Veda, Samaveda and Yajur Veda, they are well versed, and Atharva Veda, they have some kind of some magic or some beliefs that Atharva Veda should not study by some higher caste people like that. So at that time, even Irava and other untouchable people, they start like, so it was example for, he was a Irava and there was an untouchability. Definitely the community was in that grade at that time. And so it is major knowledge of Malayalam plants, Malayalam names all contributed by Itty Achyutan, the Irava physician. And also the story told that after completing Hortus Malabaricus, the 12 volumes, and even Van Reed want to take all the plants to Leiden University Botanical Garden. The miniature of the garden also they created and maintained in Kochi. And but many of our tropical plants may not survive, so they tried and attempts 2 or 3, several times they attempted to take some plants mentioned in Hortus Malabaricus to Leiden University Botanical Garden and all. So, but they couldn't succeed because of the their climatic problem, because many of our tropical plants may not succeed, and it was a failure. And also it is the storytelling that Van Reed also take Itty Achyutan help and Itty Achyutan travel to Netherlands like that, so I know what are the historical other aspects. And somewhat the Konkani Brahmins, at that time Konkani Brahmins, there are 3 major Konkani names like that is Appu Bhatt, Vinayak Bhatt and Ranga Bhatt. So Vinayaka Pandit Bhatt, that is a single name. So these are the 3 Konkani Brahmins because they are the practitioners of medicine at that time. But and many of the Konkani names or Devanagari names they contributed by them. And Veera Kerala Burma, because his interest was even the helping Van Reed. So he helped Van Reed for travel and collecting the information of various ways because he needs some administrative support from the Dutch. And regarding the illustration, we have many, many wonderful illustrations, and Hortus Malabaricus is the best example for even the taxonomy, history of taxonomy. So now we have any taxonomic publication, we need a detailed illustration. So even long back, it started by the giving illustration of Van Reed, and the botanical illustrators not from India. So they are all from Dutch, like the artists are Anthony Jacob Dutkind and Marcelia Spinster, and Bastian. The illustrations were transferred to copper plates. So they separated illustrations engraved in copper plates, and that was done by Bastian and Gonzalez. And the portrait of Van Reed, you can see, so there was a portrait shown by Dr. Prabhu also, that was done by Peter Stevens. So otherwise we couldn't have. And also the lot of botanists and other learned people behind this, that is major one is the J. Camelin. Later Linnaeus dedicated the family Camelinaceae to the J. Camelin, and even Mr. Sam also dedicated one street for J. Camelin. You can find if you have a look after this session. And others are Theo, the Theodopus Jansonius, Johannes Caesarius, and Johannes Municus, Abraham, corresponding volumes are mentioned, and William Tenrigi. So he made some correction of some information of the plants. And this was the front piece of the first volume, that is, you can see Pars Prima means volume 1, like that. And regarding the contributions of the translators helped during the, because there was at the time colonial Portuguese and other languages also there. So there was Emmanuel Carneiro, so he was a translator for Dutch East India Company, and Van Reed used him to interpreter for translating Malayalam to Portuguese. and Christian Hernas D. Donop, and Casarius, a Dutch clergyman, translated from Portuguese to Latin, like that. So after the death of Casarius, the task of Latin translation was taken by Christian Hermans D. Donop, like that. And the publishers, so who published the Hortus Malabaricus? So the initial publication was Jan van Someren and Jan van Dijk. So evidently Jan van Someren died, and so Hortus Malabaricus, Manlal sir told me that Hortus Malabaricus is always a book of story of the unfortunate life. Even Van Reed couldn't succeed after the third volume, he passed away, and his widow has taken the chance, like that. So Hortus Malabaricus, someone working Hortus, it was some kind of belief that Hortus Malabaricus even sign of bad. Anyway, scientists, we should not believe this kind of superstition and all. But even somehow we should also even come across this kind of, encounter this kind of problem, and somehow we will realize that. And evidently Jan van Someren died. Second volume, 1679, was published by his widow, Jan van Dijk. The publishing firm recognized, and rest of the volumes were published by widow of Jan van Someren and Jan van Dijk, Hendrik Boom, and widow of Theodore, like that. So many people connected with us, even they couldn't continue anyway, they succeeded by their followers. And many editions came. Major edition is, of course, Latin edition. Latin was very, very tough language, and that was a scholarly language during the beginning of 15th, 16th, and that centuries. So first volume was published in 1768, and second edition of this volume again appeared in 16. Two editions has come out. And the 12th volume was published in 1693, and then came a Dutch edition that was in 1689. An English edition couldn't succeed. So in 1774, John Hill published an English translation of Horti Malabarisi Parsima and identified one reed plate with linen plates. The plates were redrawn Hill, and after Hill's passed away. After Hill's death in 1774, probably the reason that no more London edition appeared. So that was the end of the English edition. So after that, it took even almost 300 years to come with an English edition. Of course, it was by Professor Manilal. So English edition appeared in 2003, not simply appeared, it was his lifetime work. So since from his MSc, Master of Science as a student, during 1958, and it's ended with reality in 2003. So it is almost a 4 decades work. After that, followed by a Malayalam edition, like that. And regarding the content of Hortus Malabaricus, it was mentioned, I will just move through. So the text of Hortus Malabaricus is Latin, and description of each plant title with the different languages you can see. So it is a ever history of the first printing of Malayalam language and even many other language scripts, like that. And the entire text of book has a double folio size in Latin, covering 1,595 pages of text. Mention its are medicinal properties of the plants, the respective disease for which they were used for treatment, and mode of treatment as known to the ancient renowned physicians of the Malabar. Along with, besides this, also explain many situations during the 17th century and many other known medicinal plants, the plant related to their culture. I will explain after this session, so that is my topic. So there was an introduction, there was a foreword, dedication, similar detail given. The various volumes also contain much information about the cultural, social, political, historical and linguistic condition in India, and as well known. So the information given in Hortus Malabaricus is based on the folk medical knowledge of V.T. Achyutan, and even Konkani Brahmins, mainly they taken from the Madanapala Nigandu or Maha Nigandam. So like our Charaka Shustra Samhita, they have some documents like that. And V.T. also they has a lot of palm leaf manuscripts collection, but that was lost. And Hortus Malabaricus almost a cross section of the, not complete our diversity, but to some extent. So it explains many climbers, 107 herbs and shrubs, trees, and epiphytes. Also we have Bryum bicolor, one bryophyte, pteridophyte, and 2 gymnosperms, like that. Many mangroves are like that. So more than 660 species, they belong to the flowering plants, and non-flowering plants as gymnosperms, bryophytes and pteridophytes also explained. And regarding the medicinal properties, so it is Hortus Malabaricus was one of the first attempt, especially for the bryophyte like Bryum bicolor and many pteridophytes for the first time. So many of the other common medicinal plants are angiosperms, but Hortus Malabaricus also an evidence for people also possess good knowledge for the lower plants like that. And regarding the volumes arrangement also, we can see some of the organized arrangement. So volume 1 was on various kinds of trees with the potted fruit, and volume 2 on the seeds and shrubs, and volume 3 on trees, and volume 4 on fruits bearing trees, and volume 5 on trees and berry bearing shrubs, and volume 6 on various kinds of trees bearing fruit, particularly pods, volume 7 on various kinds of climbing shrubs, and volume 8 on various genera of fruits bearing and leguminous herbs, and volume 9 on herbs and their diverse species, and volume 10 herbs and their diverse species, and volume 11 on herbs and their diverse species, and volume 12 finally herbs and their diverse species. And this volume is lengthy volume, represent maximum number of plants, and also this plant is exclusively dedicated for epiphytes and lower plants like non-flowering plants, pteridophytes, mostly you can see in the volume 12. And so it is a wonderful compilation of because they are medicinally very little known, like epiphytes and lower plants. So you can see a lot of traditional use of such kinds of plants in the volume 3. So language written, I will not explain, but so these are the way of the Latin, Malayalam, Arabic, Nagari and Roman, and see how beautifully portrayed the illustrations in Hortus Malabaricus. Even any layman can identify other than some of the complicated things. So normally, and Hortus Malabaricus already told a story of the, even we have many plants introduced and cultivated later. And most of the plants brought by after, even some plants brought by Arabians while they started trade to India, and followed by the Portuguese came. So the Portuguese people were very, was interestingly bringing lot of plants. So like our many cash crops like cashew nut and many other ornamental plants and like that. So I think most of the, from the different Europeans, Portuguese contribute mostly for our, many plants become our friends, and we are growing in our homesteads. So Hortus Malabaricus is a story and evidentially showing the introduction of many plants like Anacardium occidentale, that is our cashew nut plant, Ananas commerce. So you can see many of these plants brought by, or it is exotic plants. Many of the Hortus Malabaricus start with the kappa, because kappa or kappal means it came through ships. So that is, this is Ananas commerce, that is the pineapple, kappa chakka, because this is Ukuleke jackfruit came through ship, that is kappa chakka. Like that, many kappa malagu, that is the capsicum annum, that is came from Mexico a long time, and like so brought by the Portuguese people and like that. So already well explained the exotic plants, and even shown very beautiful photograph. I'm not explaining, but I want to tell that Hortus Malabaricus is the first floristic evidence of the even introduction of the many exotic plants. We cannot see any other documents, and we can trace the history. So if you trace when onwards the cultivation, now many are cash crops. So we can trace by it's before anyway, before 1678, even it has been in the part of our homesteads, like the different kinds of Erhova, Vilimbi, Karampola. So now is our soulmate in our homesteads. Every house we have these trees. But it started even years ago like that. So Hortus Malabaricus is the best example for illustrating such kind of things. And even the sexuality of plant was very confusion for the European botanists that same. So it was the Jacob Camerarius, he was interestingly doing a lot of research on whether plant exhibits sexuality like that. And Hortus Malabaricus publication, he found many plants in Hortus Malabaricus, for example, Pana, Ampana, like that, and papaya. So like that, many of the traditional knowledge from the Malabar coast, we have traditional knowledge, and so our people, so they make an pen, that is a female-male plant, like that, unisexuality. So I hope, strongly believe, and that the Jacob Camerarius later confirmed that even plants possess a sexuality, and that even lead to the sexual and other orientation class, and it help for the classification later. And always a question, does Hortus Malabaricus was a book of medicinal plants? So it's not to say here, it was just depicting the history and people's culture and people's knowledge, people's even every connection with their life to the environment like that. So it was once believed that Hortus Malabaricus was a solely collection of medicinal plants. However, detailed studies were revealed that among 679 plants mentioned as medicinal use, only 555 are known to the physician, and while there are many plants described in Hortus Malabaricus, around 121 species, it has mentioned, especially no use among physicians. So it has no medicinal use. Maybe some elsewhere may be there, but they clearly mentioned that there is no use among physicians. And this indicates that Hortus Malabaricus was a comprehensive compendium of the flora of the Malabar coast, reflecting their integration into the daily life, culture, and local people. So Van Reed aimed to depict a genuine relationship between people of the Malabar coast and the flora. So you can see this is a, we can see the palm leaf. They are this picture of the palm leaf, because this is Corypha umbraculifera. Even you can see soldiers. There is a Dutch soldier and even a local person like that. So there, and also another picture that is the CSIR-Central species. So you can see a person standing behind that one. So also you can see a lot of other thing. Actually, yesterday Mr. Samson was explaining. It is depicting many things. For example, this is a picture of Corypha umbraculifera. So this is from picture from volume 3 showing local people's appearance in 17th century. How they, for example, is some of the raining time. Many people under because it is a plan for making umbrella. Even still, we have a lot of artisans engaging in umbrella making and making some palm leaves and so many other uses. So also you might have noticed that there is a person, for example, a third one has the filariasis in his leg. So it is indicate that it was a prevalent, many prevalent disease. So many of the disease mentioned Hortus Malabaricus, that is evidence that it is like our exotic plants. So you can see at that time also many such kinds of the health problem exist. That is the best example depicted in that. So already I'm strongly telling Hortus Malabaricus was merely a documentation of medicinal plants. Reed tried to, I mean our artisans, we have to just even thank for the artisan like that. So this is a, and also even this is the diagram showing an attire of a traditional woman, because also it is in the cardamom like that. So a long time, even in the history of Kerala, we are females also not covered their body properly at that time. So this is a picture depicting that even female workers also worked in for the cardamom was also they maintained a plantation at that time also. There are workers of females like that, so they are attire everything. So we can see many historical and cultural aspects like that. This is from 11th volume of Hortus Malabaricus. So Hortus Malabaricus, a compendium of people knowledge on plants of Malabar coast like that. So as per the even many of the traditional knowledge other than the medical, we always fit for the subject of ethnobotany, which I specialize. So as an ethnobotanist, I can say, so as per the modern definition, ethnobotany is a study of the relationship between plants and people, and Hortus Malabaricus was exactly depicting the many of such use. And it was Hirschberger in 1895 was coined the term ethnobotany to study the diverse use of plants by people. And interestingly, nearly 200 years earlier, it was between 1678 and 1693, Van Reed had already documented various utilization aspects of plants in his monumental work, Hortus Malabaricus. And a comprehensive ethnobotanical study. So it's many people may not cover all the aspects of ethnobotany. Mainly they study medicinal plants and they finish this is ethnobotany. So ethnobotany is a comprehensive study. So it should cover 4 major areas. It should cover different types of traditional food and fodder and medicines and hundreds of miscellaneous aspects. So this is the nature of the standard or comprehensive ethnobotanical study. So ethnobotanical study, so knowledge of Hortus Malabaricus, I gone through and I found that it was in 3 sections. I didn't find any plants that is mentioned for fodder and like that, but I found there are 555 species. They are explained with a detailed medicinal use and 84 plants having the miscellaneous use. So I will explain what are the miscellaneous use found in Hortus Malabaricus. And there are 46 plants also mentioned with the food plant also. So it was not merely done. So I gone through all the 12 volumes of Hortus Malabaricus because during the English edition, Professor K.S. Manilal shared me all the soft copies of the Hortus Malabaricus English. And I was helping for the edition. And I was interestingly, I was wondered for every volume, there are, other than medicines, there are many methods. So I just started for all things make into Excel format. So I made it 12 volumes, Excel format. It took almost around a year, I can say. So I have all the Excel format of the every plant use of Hortus Malabaricus. From that, I sort out and like that. So I will go through one by one. This is a food plant. So there are 46 plants of food plants. So I couldn't explain the limited time it is, but I will make some of the food plants rare, very rare, and you have many plants not in use now. So there is a remark I made, not in use now means it was mentioned in Hortus Malabaricus, but currently I make a even inquiry like that. So it was using and nobody knows. It was for lost forever. So if there is Hortus Malabaricus is not there, so that use also we are not going to know. So for example, it's Barringtonia racemosa and the Barringtonia acutella, both are used. So tender leaves are cooked in during that 17th century. So for make their various dishes. And Begonia malabarica, that is explained as Cheria narimpuli. So that is also, and the fruits of the Kandal brugira, that is a mangrove plant. They tender fruits cooked during that time. And Kadaranthus pusillus, that is Kuppavela. So that was also, and the flowers of the Erythraina, also like that. So many of the, and another one, Otilia alsmoides, that is Ottal ambal. So like that, many plants like this. So this also, this is Kadaranthus pusillus, Otilia. So these are all, they eaten as a leafy vegetables, not raw, as a cooked leafy vegetables. But I didn't know this, right now, no one using these plants as edible and very, even it is not that much common in the diet of the present community. Also the Soneria cassiolaris and an orchid leaf, that is Saprobia spath, this also edible as a cooked. So like, and even Terminalia catapa. So we know it is the seeds are edible, but at that time it is known as adamaram. Why is adamaram? So we need the fold and make like ada. That is a traditional Kerala preparation we normally make in banana leaf. But the leaf of Terminalia also, that was clearly mentioned, and because the name itself given in Hortus Malabaricus as Adamaram, and like that, even Santhosarum, Redsa, Mullilova, so the fruits are pickled. And
Ramesh, sorry to interrupt. We're running out of time, so if you could finish.
Okay, please. Okay, like that. So you can see this is the picture of Begonia and Otilia, like that, And regarding the medicinal plants in Hortus Malabaricus, so detailed studies of medicinal plants. So this was done even during 2010 by me and Manimal and published paper. So it is showing that medicinal plants mentioned Hortus Malabaricus represented by 554 genera and 123 families. And among the family represented, the Fabaceae is represented by the more genera with 57, followed by Forbiaceae, Rubiaceae, and Moraceae. And among the 12 volumes, Hortus Malabaricus, volume 10 represented by maximum number of medicinal plants with the 9 and 12 volumes like that. So this is the number of medicinal plants mentioned in Hortus Malabaricus, and so volume 10 you can see it was describing about 76 plants. And most of the plants, of course, Hortus Malabaricus describe about the human ailments, and they are a very limited animal medicine. But of course, we have rearing cattle at that time, also livestock. But only 3 plants like Hydnocarpus pendandra, so that was oil extract from the seeds of wounds for cows, like this as explained, and Bacopa monera for as a galactagome for inducing milk production. So Iris domestic, it was actually Balankanda, is a recent name I opted like that. So it's a antidote for the poisonous effects of animal, and also antidote for snake bite and all. This all indicates also the growth forms of medicinal plants. It includes herbs, climber, parasitic herbs, trees, epiphytic herbs, and like that. And the significance of medicinal plants mentioned, it has, so Hortus Malabaricus is a source of more than 2,789 prescription. So we have seen the medical application for more than 210 diseases which are prevalent in 16th and 17th century, and some medicinal use of plants are not reported in any other system. So some of the medicinal plants you cannot find any other medicinal scripts like our Charaka Samhita, Sustra Samhita, or other traditional medicinal books like that. And there are 21 medicinal plants endemic to Western Ghats of Kerala. And these are the most prevalent 30 diseases like fever, all kinds of pain, ulcers, wounds, arthritis like that. So these are the major, so you can see the medicine number of the medicine application also. So 136 prescriptions you can find for fever, like of course, always we suffer from like that. And regarding the miscellaneous use, so miscellaneous use represents diverse use. It includes dye, decoration, carpentry, as a green manure, and fish stupefaction, religious rituals, adulterant artifacts, adhering agent, and for dyes, explosive, for making gunpowder, narcotic, and supporting plants for climbers, ornaments, washing, plants for use for bathing, beverages, and filling materials like stuffing, pillows, and all like the cotton plants, fuel plants, commercial crops, and cleaning agent, fiber yielding plants, mastigators, and magical religious beliefs. Also, an array of a variety of multifarious use of plants has been explained. And you can see the miscellaneous use of plants. So dye yielding plants, there is around 12 plants, and carpentry. So there are clearly mentioned about some of the suitable plants for trees for carpentry like that. And so you can see the detailed list. And I am very much interestingly that for the dye, many plants at that time used for the dyeing linen and all, because we have no synthetic color available. So many plants, I just make the remark, I have not explained because of the scarce of time. But you can see many informations are not in use now, also, but it was the Hortus Malabaricus as the only evidence, and I will go through some of the other use mentioned in Hortus Malabar. For example, Corypha umbraculifera, that was widely known use other than the seeds at that time. People of Malabar used for as an ornament, adorning, they are making bracelets and necklace. And even you can see in other contemporary literature also. So, and also Coex, it's an interesting one, everyone knows the Coex lacryma jovis. So it was clearly mentioned in Hortus Malabaricus. It was common at that time, people are using bracelets and other ornaments. And also regarding the fish stupefaction, plants for catching fish. So the rotinoids, so like Menispermaceae, many of the Diplosclesia glucosins belong to Menispermaceae. Many of the Menispermaceae plants are rich in rotinoid compounds that make some kind of dizziness while make the crushing or the seeds or the leaves or like part. So the fruits of Diplosclesia for fishing, and interestingly Melastum malabatrum, that malabatricum that was used for the flowers used in temple for rituals. Nowadays no one is using like that. Also it is from the prepared fruits, color of linen, also the charcoal of the wood that is used for preparation of the gunpowder like this. So like that you can see, I cannot explain all because of the time limits, but even the Psychotria dacinus is a species, the fruit, the seeds are used for a alternative for the areca nut plant. So these fruits are frequently eaten with bitter leaf instead of areca cones, like that. So nowadays no one using that. And the rind of the Caraya arborea, they used for the catching wild boars while hunting, like that. And so many plants with magico-religious beliefs like that, Salapinia mimosoids and Barringtonia aquitangula. At that time, the saints, they decorated, they make garlands and decorate. So nowadays we are not using this kind of the rituals like that. So it was mentioned that they decorate their body and lot of rituals has been performed. And the leaves are also edible. And many plants at that time we have, because the coastal area, there are a lot of water bodies and like that. So lot of plants has been mentioned with the huge trees, like making canoes. That is the manchos, for example, Holygarna and Terminalia, like plants and like that. And also Hortus Malabaricus has a major role for the traditional classification. So taxonomy indicates the publication of Hortus Malabaricus in 17th century deputed and preserved many local names. For example, Chemtani. So we have no Chemtani, otherwise we can directly ask people which is Chemtani, somebody will show. But many, it is Chemtani is the example for a plant, local name, lost forever. Diagram was mix up of 2 or 3 parts of the twig, maybe fruit, maybe with another plant, and even other flowering plant, another plant, like that. So, Linnaeus cited 258 Malayalam names of Malabar plants from Hortus Malabaricus in his species plantarum, naming for 255 species. Somehow, some of the species was synonymized, but many species and general names existing. So, it is a best. Many, already Dr. Prabhu exemplified with the Onapu, different kind of Tilo, Onapu, like that. That was the concept of people. So here we can see Ithial, Athial, Cherumarayal and Athimarayal. These all indicate different types of ficus, Peral, Hendra, so like that. So if you have a traditional taxonomist, we can, even local people, they identify somehow with the local names, like that is some of the example how people also have possessed knowledge of the ethnotaxonomy. Also we can see different kind of the Parithi-like plant that is indicated with Thali. If you are used for Thali as a shampoo, that is Thali Parithi, and Thali Parithi was a genus erected from Hortus, later merged with the Hibiscus stiliaceus, like that. And Kuru Parithi, like that. So then the photograph, it is Kuru Parithi, Thali Parithi and Pu Parithi, and representing the 4 species of the hibiscus, like that. So the Neela Ummatu and Mudala Neela Ummatu, that was, so some varieties having some 3 layers of flower. And also we can see the classification of Crotalaria, that is Nalla Tandalakutti, Valiya Tandalakutti, and P Tandalakutti. This is all. We can, so like that, the different kinds of Kara, Katugara, Kandan Kara, Ben Kara, Chiru Kara. This is all unlike, so Trittau. Nowadays we are not using the Osimamas Trittau, because my grandmother was frequently using the name Trittau. I remember she always asked, collect Trittau. Trittau was not at all used as a local name for Tulasi. Now we are all using Tulasi. So Hortus Malabaricus evidence, and I remember immediately reading this, my grandmother always says, collect some Trittau, because she used for Tulasi for Trittau. So Nalla Trittau, Katu Trittau, Soladi Trittau, and the species of Tinospora expandicitum or the pure, like this is some of the examples, like Panel of the Polyalthia, Uvaria classified, but it is not supposed to be in the same genus and like that, but anyway somehow like that. So I am just going to conclude. So already Mr. Suman team successfully in the first venture. It was a great dream of Professor Manilal, and always I believe his soul is with us with this garden, because it was a dream of, and they succeed with almost only few plants should be remaining. I think less than 21 or like that. Rest of the plants are there conserving here. Is a very nice way we can see after this session. And that was one of the major. Next one, I suggest developing an exclusive collection of herbariums. Already they are started here. And I suggest, I request Mr. Sam Santosh and team make a museum for the 17th century for people plant knowledge of the based on we should have a Hortus Malabaricus museum, of course. And there should be, because we should have a single volume, we have 12 volumes, so a single photographic volume of the Hortus Malabaricus, explain some minimal description and all, and also a digital database of the Hortus Malabaricus should be prepared, and detailed documentary of the historical and botanical aspects of the Hortus Malabaricus for the public domain, and future more studies of the evolution of the history of language, because Hortus Malabaricus depicting many scripts. And also we need a reinvestigation of the conservation status of plants mentioned in Hortus Malabaricus, and detailed studies of folk taxonomy and nomenclature of Malabar plants mentioned in Hortus Malabaricus also inevitable, and phytochemical characterization of medicinal plants mentioned in Hortus Malabaricus based on folk medicinal information of the Eti Achyutan using modern techniques. And of course, we are in the scenario of intellectual property rights. So we need English edition of Van Reed's Hortus Malabaricus by Professor S.MONI in 2003, open to the ocean of thousands of traditional knowledge on Indian medicine. They are now in public domain. Nobody can take a patent of the similar medical applications. They have to search for another. So it is safeguarded from biopiracy. So still we are waiting a team. So after this, a team of experts will explain for the bioprospecting of the plants, their experience share like that. I'm so sorry for extending, because I cannot if I leave without explaining this, my one work will be incomplete. I'm sorry. Thank you for patient hearing, and I'm thankful for Mr. Sam and team for the opportunity. And I'm very much really blessed and very happy today.
Thank you, Dr. Ramesh, for your excellent presentation. And we all feel the passion that you are having for the content of Hortus Malabaricus, even the translation by Dr. S.MONI. But actually, you could have focused on the second part. So we are all waiting for the second part of your presentation, and that part went very fast, and you could have reduced the first part, and that is my humble suggestion. Because we were all waiting for exactly the ethno-botanical content of Hortus Malabaricus. I hope all the participants will be having the same opinion. I think Ramesh will be given a second time chance in some other international workshop and all. I think a lot more to say about the diseases, the medicinal uses that has been mentioned, and here you mentioned some local names that even disappeared from our use in Malayalam. So the students will be eagerly waiting for that part.
Of course.
Even though it exceeded some time, you have presented it very well, and from your the way of presentation, we could realize the passion that you are holding in your mind with your great professor, Dr. S.MONI, as well as the Hortus Malabaricus. Thank you.
Thank you.
Thank you so much. And due to paucity of time, we are skipping this question answer session. And I was getting a little impatient because next talk is mine only. So we'll break for tea. Right, and then we'll gather here as soon as possible. So maybe it was a 15-minute break, but if you come before that, it'll be nice to me as well. So please do consider that.
Okay, I request anyone have any discussions so we can have during the tea times, please.
Yeah, you can utilize the tea time for discussion with the Dr. Ramesh.
Yeah, one more thing, sorry. Yeah, for felicitation. I once, yeah, please you can announce. Yeah. So to felicitate Dr. Ramesh Muchikal, please.
I would like to request Dr. Anupalan to present a memento as a token of our gesture.
Yes.
To Dr. Ramesh. That concludes the session. We sincerely thank Dr. Maya C. Nair and Dr. Ritesh Kumar Chaudhary for graciously chairing the session, and extend a heartfelt thanks to all our distinguished speakers who shared their valuable insights. Let us now take a break, very short break for tea and snacks, which has been arranged downstairs, and kindly be back by 11:35 as we have more engaging presentations lined up for you. Thank you.
Thank you. Thank you all. I thank the co-chair, Dr. Ritesh Kumar Chowdhury, also for coordinating the session. Thank you.
Thank you.
Welcome back, everyone. We now begin Technical Session 2, focused on the future prospects of research related to Hortus Malabaricus. The session will be chaired by Professor Dr. Edathil Vijayan, former Dean, School of Life Sciences, Pondicherry Central University, and Dr. P.E. Rajashekharan, retired Principal Scientist, Indian Institute of Horticultural Research, Bengaluru. Sir, we warmly welcome you once again to lead this session.
Welcome everyone to the post-tea session. We are already running, late, and it is going to be an exciting session because past 350 years of history and story we have been hearing, and now we are going to build up what in future. And the 4 presentations which are in this session is going to highlight what are the future potentials and in what way we are able to utilize what knowledge we derived from Hortus Malabaricus and the plant flora. So without losing much time, I hope everybody comes and we move on to the first lecture of the session. Yeah. By Dr. Ritesh Kumar Chowdhury from Agarkar Research Institute, Pune. And he will be talking on taxonomy in transition. Exactly this is what I meant. Bridging classical botany and genomic insights. So we begin with the molecular aspects and molecular genomics and proteomics and all the modern latest technology-based future studies in this area. And I'm sure we are going to have a very exciting session. Welcome you all. Welcome, Dr.
A distinguished plant taxonomist with over 2 decades of research across all 4 biodiversity hotspots of India, Dr. Chowdhury has described 15 new species, reported 21 new records from India and Vietnam, and contributed over 100 research publications. He is also one of the India's early contributors in the field of molecular systematics and has authored several landmark taxonomic books, including Smilaseke of the Indian subcontinent. His accolades include the Professor Y.S. Murthy Memorial Gold Medal, Professor V.V. Shivarajan Gold Medal, and the title of Best International Researcher from KRIBB, South Korea. Today, we are privileged to have him share his expertise with us. Over to you, sir.
Thank you so much. So today I'll be touching a little different aspect from the first session, and I'll try to finish on time. How much time I have, Dr. Anu? Till 12:30 I can, 12:30 I can go, right? So, okay. So we already know, and most of us are botanists, we know that we have a lot of interest in discovering new species, but there is a fact that we are discovering new species at a much faster rate. And there's a fact, I think already, that around 2,000 new species of plants and fungi are found each year. And we are discovering new species at a greater rate at any time during taxonomy's 250 years of history. And thanks to all the new tools and techniques we have that are helping us to describe new species and to understand the plants in a much better way. First few slides are a little very old. I think I always use in my slides just to inspire new generation taxonomists. So as a botanist, we already know that we contribute a lot to biodiversity studies, right? How many students are there? Can you raise your hand? All the researchers. So yeah, so being a botanist, do you feel like you are contributing a lot to biodiversity knowledge, right? Yes or no? Could you raise your hand? You feel like you are contributing to the knowledge on biodiversity, yes or no? Yes, of course. But if before you say yes, you go through this paper by Hortus et al., which talks about 7 different shortfalls. And what are these shortfalls? First is lenient shortfall, which says unless you describe each and every species on earth, there is a shortfall. Then second one is called Wallacean shortfall, which says unless you know about the geographical distribution of the species, all the species, there is a shortfall. Third was a Prestonian shortfall, which says you must know about the populations of those plants, otherwise there is a shortfall. And Darwinian shortfall, you must know about their evolution, otherwise there is a shortfall. And if you don't know about the functional traits and ecological function, there is a shortfall called Roncarian shortfall. If you don't know about the abiotic tolerances, there is a shortfall called Hutchinsonian shortfall. And you must know about the ecological interactions as well. If you don't do that, there is a lack in your biodiversity study. So this is called Eltolian shortfall. Right. So these are the shortfalls. So how to overcome all these shortfalls? And as I know, most of the botanists are sitting, I have a question here. What is this a plant? Which one is this plant? Little loud? Hibiscus rosa sinensis. Okay. Sure? Sure. Okay. And what is this plant? Taxonomists, please help me. Why we are not able to tell the name? There is a loud, please. No flowers and fruits. But if I give you leaf, cannot you identify a mango leaf? Yes, but can you tell that with certainty? This is mango leaf only? Yes or no? You will say, no, I have to check the flowers and fruits, then I will tell it's a Mangifera indica. Right? So there is a limitation in morphology based taxonomy. And things become more difficult when people come to me with this. What is this plant? What is this? Papaya or piper? Piper shot? Have you tasted it? No, right? And it becomes more difficult when somebody comes to me, what is this plant? Could you help me identifying this? Can you do that? Thanks to new tools and techniques we have. DNA barcoding. If you do, at least you can definitely reach up to family level, I'm sure, because our database is very strong nowadays. Maybe you cannot go up to species level, but in many cases, definitely you can, at least Mangifera indica, you can definitely identify. We know DNA barcodes are available, and with 100% certainty, you can do that. Agree or disagree? Okay, I have no intention to hurt your feelings, but this is the fact. This is the way science is going ahead. And there is also a problem of convergent evolution. You know, these cactuses, right? Both of them. She's saying yes, no. One is a euphorbia, another one is a cactus. Why it becomes? Because it's we know that convergent evolution, because of some ecological adaptation, that fellow also thought, I have to survive, I have to look like a cactus. But molecular data helps you, and there are so many cases where due to ecological adaptation, people also, that different plant also, they look like, okay, very similar families. So here, we get help of molecular data. And also there is a problem of cryptic species. You might have read this paper by Liu et al., which was published in 2022. And before this particular species, Pedicularis siphonantha, very complex group, earlier it was known by only one species, one name. But these people, they now found out there's a lot of genetic diversity inside, so they have described 11 new species of Pedicularis. Of course, based on both morphological and molecular data. So this I'm going to talk about today, molecular systematics, where what we are going to use, we are going to make use of the DNA, RNA, and proteins. And we know that in plant we have 3 different genomes, in nucleus, chloroplast, and mitochondria. Agree? And they are going to help us in telling the identity, proper identity of the species, and their evolution, and so many other aspects. I'll be dealing today. So we are going to take help of several markers. Just some of them I have highlighted here. So we have several kind of markers, morphology-based markers, biochemical markers, molecular markers, and we have a number of markers. Just some of them I have highlighted here. And in nuclear DNA, this is the superhero of nuclear markers called ITS, internal transcribed region. So they're very much conserved for a species. Okay, I should not use the term species here. This is very much conserved for one operational taxonomic unit, OTUs. You are, I guess you are aware of this thing. So in molecular taxonomy, we don't use the species, variety, and then that everything is treated as a distinct operational taxonomic unit. And they are very short stretch of sequences or DNA, we are very much conserved. And they are found in nucleus. Same thing in plastome. If you see chloroplast genome, you have several other regions like RBCL, MATK. They are very much conserved for a particular OTU. Same in mitochondria as well. You have several other conserved regions, which helps you in helping with the identification. And morning we are talking about this APG system of classification, right? So how this particular molecular data help us in classifying, reclassifying the whole angiosperm in a very different way. Okay, so now we know how they have evolved, how they're related to each other. So now we know the phylogeny of 2,95,781 angiosperms. And also what is remaining now is just 183 species, plant species, which we call as the ANA group. Okay. So anyway, APG was based on data, not only molecular data, but so many other, some other data gathered throughout the world. Several different kind of data was gathered, and this was finally produced. Then they also help us in DNA barcoding, which helps you like improve identification and proper classification, also to check adulteration in herbal medicine, and also in conservation. How in conservation? Right? Can anyone answer? How they can help us in conservation? Yes, endangered species, of course. I am aware of a project sanctioned by DBT, almost 60 lakhs rupees, and they identified a plant group for working on bioprospecting. They published so many papers, result was out, but when we checked in person, that's a true story, they worked on a wrong plant. All money wasted. And still those publications are there. So if you are not able to confirm the identity by particularly in the taxonomic complex group, your whole result, so all the money would be wasted. And with the help of molecular markers, we can find out, we can tell that which particular plants are prone to extinction based on their genetic diversity studies. That's how they help us in conservation. Right? Agree? I'm going to tell you a story of this plant group. Many of you must be aware, being from Kerala. Thanks to Dr. Prabhu, who helped me in conducting this study. This is a plant group called Eriocalan. And if you have visited Maharashtra, you must go to this place called Khas Plateau. It's a UNESCO World Heritage Site, spread around just 10 square kilometer area, but the number of species 150 here. And you will find kind of white bed of flowers like this. Of course, in Kerala also you have a lot of Eriocalan. But if you see there, go there, you will find 4 different species of Eriocalan. The last one called Eriocalan E. pedunculatum is just restricted to that particular place. Nowhere else in the world you will find except that Khas Plateau. But if you see the taxonomy of this group, it is very complicated. If you want to identify them on the specimen, herbarium specimen, they look like that. These are 3 different species. And if I tell you one of them is having anti-cancer potential, okay, and they have many of the species, they're known for having neuroprotective agents. And then they are also known for several medicinal properties. But if you really wish to identify them perfectly, what you'll have to do, you have to dissect those tiny flowers and find the structure of involucral bracts. That's not enough. Then floral bracts, then the male flowers, female flowers, which are very minute, 1 mm size. And this is also not enough. You have to look at the structure of the seeds. You see, like elephants, right? Yes? Somebody said yes. Not elephant, they're very minute. Huh? Even light microscopy cannot help. you'll have to do SCM, and this is also not enough. You'll have to look at the structure of the appendages, and then only you can confirm this is the species. So it was very challenging for us. We thought, of course, with the help of Prabhu, we have conducted this study, and we did a lot of collection. And of course, and in the species also you have a lot of variation. And within the species, you don't have much like intraspecific and intraspecific variability is there, which is combined with limited interspecific differences. That's why they are also called as taxonomist nightmare. Okay. So Hooker, when he was writing Flora of British India, he has written, they are the most difficult of classification, presenting no good sectional characters. We thought of taking up this challenge. We conducted a lot of through the sampling across not only in Western Ghat, but also in Northeast India. And we have published this paper in a good journal where we have synonymized several species which were thought to be distinct. But we found no, they are not. So we have synonymized several other species. And these molecular data not only help us in synonymizing species, but to understand their evolution and also how they are different from traditional classification system. Then another group is there called Capparis. Morning, Shasidharan sir was showing these pictures. So this was again a complex group where you had several other complexes, taxonomic complexes. And along with that, we thought of working on molecular phylogeny, of course, with the help of SCRB New Delhi, which funded us. Then we also established DNA barcodes, and also it helped us in understanding the phytogeography of the species. And the book is published, the genus Capparis in India by us, which is available freely online. If you wish to see the diversity of these species, you can freely download from our institute website. And this helped us. We made use of a lot of molecular tools and then help us in reclassifying that group. And not only this, there are several other species complexes which we again resolved using that data. And you might be knowing this particular medicine called LIV52, very popular. So you'll be surprised to know that Capparis spinosa is one of the major ingredients of that particular plant. But unless you identify this, suppose I give you this much of leaf and ask you to identify whether it's Capparis spinosa or not. And this has got several other varieties, more than 7 varieties are reported. So can you do that? It's very difficult. And if I give you a dry sample, then again it becomes more difficult, right? So we have established DNA barcodes. Even if you're given a small amount of leaf, with certainty you can say this is Capparis spinosa variety spinosa. You can tell now. So thanks to all the new tools and techniques. And then there are several species complexes. So we have resolved that, also published those stories. You can find those papers on my ResearchGate profile. And then the whole story of this, how phylogeographically they have been distributed and how the phylogeny is, everything was published in a good journal, which you can find there. And there is another problem with this medicinal group, very important medicinal group called Bala. I think most of you are aware of this Sida genus. And it is not only Sida when you talk about Bala. So it is a group of plants belonging to other genera as well, like Sida abutilon. Recently we have published this paper using molecular tools, how we are now being able to resolve these taxonomic issues, or particularly with the adulteration, or we have developed certain regions already, what repeats are there, based on which you can identify all those species with certainty. Then we already have, thanks to SciGenome like companies, where you have the potential power of next generation sequencing. So using that, earlier it was very expensive. Maybe if you want to do sequencing of one chloroplast genome, it used to cost maybe 2 lakhs rupees before. But now it has come down to 10,000–15,000 rupees only. So that has helped us a lot in understanding the phylogeny in a much better way. And also they have the potential to deal with the difficulties posed by polyploidy and hybridization. And also we have new options to study species boundaries and their relationship with other recent, in comparison with the recent radiations. This is how a plastome look like. And using this plastome data also, in one of the Eriocolici plastome we have worked on, this helped us not only understanding the DNA barcodes, but also to understand evolution in poels. If you are interested in reading the story, you can just download this paper, it's freely available. Then, as I said, the NGS tools and techniques are available, so it has become much cheaper. So we have now some papers like where they have used huge data set. So this paper they have used 250 plastomes together to understand evolution of poaceae. Not only this, you will find one particular paper. When APJ was published, it was heavily criticized, saying, no, molecular data is like that. If you do like it is just based on small stretches of DNA. So once you come up with the genome sequence data, that will be completely changed. So recently this paper was published in 2021 by Lee et al., where they have made use of 4,792 plastomes. Huge data sets, including 80 genes, 80, including 4,660 species in 2022. And the structure of APG remains same. The tree which we got, it remains same. So still criticism was there because this study is based on whole plastome data, chloroplast genome data. It will completely change if you just do it with the help of whole nuclear data, because sequencing that is very different. So you must see this paper published by these two fellows, Zhang and Ma, recently published in a good journal, where they made use of whole nuclear genome data. And using that, they reproduced this APG, structure remains same. Okay, so you must go through. So then you will say, okay, I understood this helps in classification, identification, what else? What are the practical applications, right? There must be a question. Unless you people spending so much of money and you are not contributing a lot to the application part of science. So yes, there is application. One thing I've already discussed about conservation, but you see there's a very interesting story on coffee. You'll be surprised to know that coffee, what we drink, is actually known by 124 species throughout the world. It's not only one coffee species which we drink. And most of them, they are found in Madagascar. And half of the coffee, they don't have caffeine. 50% of coffee species, they don't have caffeine. You see this interesting photo there. You can see the blue color. It means there is absence of caffeine. But you see the red mark, it means caffeine, and this is how the caffeine has evolved throughout coffee genus. So they have done quantification of caffeine throughout all the taxa, coffee major taxa which are present, and you can understand how this caffeine is evolving in different plant genera, plant species. And red color you can see, if you know this phylogeny, you can simply target that particular species and the allied species. Why to go for the species 1? Because we already know it is very distantly related phylogenetically, so why to study that one? If you want to explore caffeine, I will target those particular species only. Getting my point? Interesting? Happy? Yeah. Okay. So now, another cry is there for taxonomists. There's a false portrayal. I'm studying taxonomy, I'm not able to publish good impact factor paper. I'm not able to publish in SCI publication. No, that is also possible nowadays. It's simply a false portrayal that with plant taxonomy you cannot publish. Definitely see all these papers. With a simple taxonomy and inclusion of some molecular tools, they are published in high impact journals. You can do that as well. Now, there is another problem. Many people, they are unhappy that you people are going to change the species concept with the inclusion of molecular data. Of course, APG was criticized, answer has also been given, but still that is there. But you see, all the species species concepts. The first one we know, typological species concept based on morphology. But am I not right that one variety, it is for Prabhu, it is a variety. For me, it is a species. For another person, it is a forma. We always fight. So there is some problem with typological species concept. It has a lot of subjectivity, right? I don't know whether you agree or disagree, but this is my point to make. In biological species concept also, it is limited to sexually reproducing organism, right? But there are several species, when you keep them in natural environment, they don't interbreed. And there are some other 2 different species, they're in the wild, but still they interbreed. Would you call them the same species? No. Third one is called phylogenetic species concept. I am criticizing myself. Phylogenetic species complex. You must be aware of this king cobra classification recently published in a paper. It was known by only one species. Recently, based on molecular data, they have identified several species or maybe genetic groups based on molecular data. So that is another criticism of phylogenetic studies. It's not like I'm just praising myself, praising my molecular data. That also has some faults, and that needs to be resolved. So this phylogenetic species complex also has some problem because we are inflating the number of species, unnecessary creating where like a lot of cryptic species, there are a lot of issues are there, which I get next time, more time the next lecture, I will discuss more about them. But also there is ecological species complex, based on only if it has a particular niche and then only you can call them a species. But that is also not correct. And finally, this evolutionary species concept, which is again vague and very hard to test. So what to do then? It's a paper, wonderful paper published by DCREMERS in long back, I think 2007, yeah. So it talks about multiple species coalescent model. What is that? And here they have stated what is a species. It is an independently evolving metapopulation lineage. So how a species is formed, they have discussed. How to overcome the problem related to delimiting a species and the properties which are getting acquired during this lineage or during the divergence, it has been discussed. And of course they have talked about when it is in gray zone, it is not necessary that you are going to get morphological differences. You may be getting molecular differences because they're still evolving. So to overcome this, there is a particular, and also they have written that species in different stages of evolutionary divergence would exhibit different levels of allelic sorting in the nuclear and plastome trees. If you know that a lot of allelic variations is there within the species. If you collect a species from here, Kerala, and the same species from Andaman, you might get allelic variations. Right? Alleles are genes, a copy of the genes. You get variations. So should we call them a different species? That is the problem. Still we need to resolve that. And geographical information. Nowadays, with the help of availability of more and more data, we must collect geological or geographical distribution data. Otherwise, your particular species delimitation has some issues. So it says it becomes very, very crucial nowadays. So if you need to prove really that, and so you have to follow this particular approach called the coalescent approach. What is this coalescence approach? We know how species diverge and we go forward, but in coalescence approach, we check the recently evolved and the particular species where it has been the recently evolved species will go back to their ancestry with the help of allelic data and then combine that with geography, and this is called multiple species coalescent data. So nowadays the recent trend is like that. If you simply wish to describe a new species based on simple variation, if you are describing, there will be a lot of conflicts. So now, if you really wish to publish high impact papers, if you really wish to prove your science, you have to follow all these approaches. Okay. So this is how the species evolve. In the same DCREMERS paper I have taken it. So first, like if you see when it is a single line, it's not diverging, you can diagnose the differences. But as you go further, you must be finding some molecular data when they're in a gray zone. Some molecular data will start appearing, and where what happens, there is a complete cessation of interbreeding. They will not stop interbreeding, and then monophyly comes. Like one particular divergence is there. Okay. So what to do finally? What should be ideally done? If you wish to describe a new species, it says an integrated approach has to be followed. First thing, the sampling. If you are describing a new species, not like simply take it from one population and say this is a new species. You have to do thorough geographical analysis, distribution range you will have to cover, and then you have to do multi-gene phylogeny. It should not only be based on single gene from nucleus or chloroplast, it should be kind of multigenic, and then you have to follow that multiple species coalescent model, distribution, how they're coalescing, so allelic information also you are providing. then you're doing real phylogeny, then you're really doing molecular system, real molecular systematics. Otherwise, definitely that shortfall is going to be there. And then you decide whether my new species is really new species, okay, and then you can confirm that. So, and to that, particularly for those living in countries like India, Cambodia, Vietnam, biodiversity rich countries, still that alpha stage has not passed. We are doing the omega taxonomy. So alpha taxonomy still you can do because we are so rich in biodiversity. So that thing has not still been passed. Still, as you have seen Dr. Prabhu's observation today morning, how nicely he illustrated that using that old literature, you can still prove that there's certain differences, and I really appreciate the way he has observed. You can also follow that approach. Of course, that's again very, very plausible, and you see what I've written, a careful, thorough, competent descriptive taxonomy can reveal fascinating details of evolutionary history as well as you have seen Dr. Prabhu's presentation. But update is indispensable. We always want to go for the updated mobile phones, updated softwares. Why not update this taxonomy also with the help of new tools and techniques? I'm not telling only molecular data. Why not include cytological data to your study? Why not study embryology also? Why not study different kind of characters by prospecting what chemicals are there? Then you come to conclusion. So you need to update yourself. And molecular data, always being criticized saying that you people are molecular taxonomists. You are not going to understand taxonomy. So my point, we are still taxonomists. We are using an additional tool. We are using just molecular tool to prove our point. So it is a tool. It's not a distinct branch of taxonomy. We are still doing taxonomy. But if you go through, there's a paper by Dr. R.R. Rao where he has asked, is it the time to be a crypto, chemo, cyto, histo, ecomorpho, molecular taxonomist? I say yes. If you are in this era, you have to do all this. So see, two frogs are talking here. Looks are not everything. It is what inside you that really matters. A biology teacher told me that. With this, I'm concluding with a thanks to all the organizers, Dr. Bala and Dr. Gopal. Thank you so much. Thanks to my team members as well. I'm open for questions, yeah.
Thank you for keeping the time. We have time for one question so that we can, I'm sure the students will have questions. No questions?
Yes.
Okay.
So, yeah. Either you understood or did not understand anything. Do for two possibilities. So I'll be, anyway, if you are hesitant.
Dr. Hitesh, I have a question.
Yes, sir.
I really appreciate the effort you have taken to unravel the mystery of taxonomy and how the modern taxonomy can be used for the problem which we are facing. So in your view, the molecular taxonomy is the solution for all the problem which we are facing in the taxonomy, or
again,
or only it can be used as a tool?
As a tool. Today we are talking about molecular. Maybe after 10 years, nobody will talk about molecules, they'll talk about something else. I also don't know. It's an evolution process. Maybe 10 years back we were talking about numerical taxonomy. Now it is being criticized. Maybe after 20 years, I will be also criticized. So use it as a tool to prove your point. Okay? It's not a molecular taxonomy, a distinct branch. It's a tool only in taxonomy. Yeah. So he has little written in his paper on a negative note. So we should, but I am taking it positively.
That is what I was wondering, because in all his presentation, he was totally against all the molecular taxonomies. And in fact, you have quoted as a positive response from
So we have to do like that. Yes. Otherwise, if you really compete with all the updated taxonomy, the way it has been done in other developed countries, we have to do that. That's my point. Yes, please. Yeah.
We have to do thorough experiments. So if the number of taxa is higher, it is practically very difficult to reach to a point.
Yeah.
So What's your opinion about that for those groups which have more number of tags?
Yeah, I understand. I understood your friend. Thank you so much. It's a very valid question, good question. You have seen Dr. Prabhu's presentation in the morning, right? So at that point also, I was so agreeing to his points, right? So you have the chance to convince the reviewers as well. It's not like there are several journals like Taxon who really appreciate the taxonomy done based on morphological data. So that scope is still there. But if you have choice, if you have the chance, if you have the infrastructure, why not do that also to prove your point? So I'm nowhere like sidelining morphology based taxonomy. Okay, so that is also possible, of course. Yeah.
Well, thanking Ritesh, we'll invite the next speaker,
yeah,
Dr. Renila, for presenting her paper on analytical approaches in natural product chemistry, extraction and structural elucidation of compounds from Ans jelly, Artocarpus hirsutus, a tree mentioned in the 3rd volume of Hortus Malabaricus.
So thank you so much. Yeah.
Thank you, sir. But before that, as a gesture of our heartfelt thanks, we would like to present a memento to Dr. Chowdhury, and I request Dr. Anup to do the honors. Dr. Renila Padmanabhan, Head of the Department of Chemistry at Yuvakshetra Institute of Management Studies, Kerala. With over 15 years of teaching and research experience, including international academic roles in Saudi Arabia and Ethiopia, she brings deep expertise in natural product chemistry and the bioprospecting of medicinal plants. A PhD holder from Avinash Lingam University, her work focuses on isolating and characterizing bioactive compounds with therapeutic potential, backed by numerous research publications and postgraduate mentorship. Ma'am, we look forward to your talk.
Yeah, good afternoon, everyone. From morning, we have been hearing very interesting lectures from botanists, and we could see many beautiful pictures of the plants over here. But as a chemist, I'm particularly interested in the wide variety of chemical compounds these plants are offering to us. Especially as an organic chemist, the structural diversity of the compounds that the flora is offering to us. So let me go into my today's presentation. So here I'll be giving you a brief outlook on the various tools that we use to find out the structure of the compounds we extract from the plants. So as an introduction, let me give what exactly natural products means. So plants are producing these compounds not just for their living, like the carbohydrates and the proteins, but they make this essential for their crucial ecological interactions. For example, plants produce the alkaloids and terpenoids not just to grow but to defend themselves against herbivores, attract pollinators, and to outcompete neighboring plants. So these compounds are incredibly diverse, and because they are biosynthesized in response to specific ecological pressures, they are often have unique structures and potent biological activities. And a lot of compounds serve as good anti-cancer drugs. The very famous Taxol and analgesics like morphine. And apart from medicine, a lot of compounds are being used in agrochemicals, biopesticides like azadirachtin, and in food and cosmetics, menthol, linalool, etc. has been used. So despite the interesting use of these compounds, actually as a natural products chemist, we are facing a lot of challenges. because when we take a plant and take the extract, there is a complex mixture of compounds. And it is very difficult to isolate in its pure form. And due to the high structural diversity, the structural elucidation task is also a complex one. And the main challenge we face as a natural product chemist is that the low concentration of these biologically active compounds, because we need a lot of biomass when we use 2 kilos or 3 kilos, and we end up in less than 500 mg of the compounds. That's one of the biggest tasks that we are facing. Okay, coming to the classes of natural products. The major classes are alkaloids. They are basically nitrogen-containing compounds, and the terpenoids is one of the biggest class. And the very famous anti-cancer drug actually is a terpenoid. And phenolics. Phenolics are the compounds that are having polyhydroxy groups and serve as the best nutraceuticals and antioxidants. And the glycosides. Glycosides is having a glucose moiety and a non-glucose part, and because of the presence of the sugar part, this group of compounds serve as a best drug candidates due to its solubility and bioavailability. So here a brief analytical techniques that we use in natural product discovery, starting with the extraction. Then for separating the compounds, we use a lot of chromatographic techniques. Then the structure identification is done by a lot of spectroscopic tools. And finally, the compounds can be subjected for different biological assays or agrochemical activity or in flavors. We can find a number of applications. And if needed, these compounds can be modified by derivatization or synthesis or other products in order to enhance these activities. So these are the common extraction techniques we follow. Still now, for obtaining a large amount of compound, we are using the conventional methods of the maceration, Soxhlet, and percolation techniques. But these are time-consuming and solvent-intensive techniques. So nowadays, everybody is going green, and more green techniques have been replaced by these replaced the old conventional method. So ultrasound assisted extraction technique, microwave assisted techniques, and the carbon dioxide based supercritical fluid extraction technique, especially for the thermolabile compounds, and pressurized liquid extraction techniques we are using. For separation technique, that means, as I have earlier mentioned, when we take the extract and when we put a TLC of it, we are having a band, not just single spots. As a chemist, we need to, if we want to go for the structural analysis, we need to get the compound in the purest form. Then only our spectra, we say it is free of noise, we can interpret it nicely. So, column chromatography is the best tool. Even though it is an old technique, still, in all chemistry wet labs, you can see researchers and young chemists depending upon column chromatography as one of the tools for the purification of compounds. So in column chromatography actually separates the compounds based upon their differential interactions between the stationary and the mobile phase. Next comes the thin layer chromatography for following up what is happening with the column. And latest, the instrumental techniques like the high performance liquid chromatography and the gas chromatography are also used for separating, identifying, and quantifying the compounds. Flash chromatography is an advanced technique wherein we can increase the speed of the separation in the traditional column chromatography by using pressurized gases. Next comes the main tool for organic chemist, the spectroscopic characterization. It's actually, once we separate the compound and get the compound in its purest form, structural elucidation is like solving a jigsaw puzzle for us chemists. So part by part information we gather from the various spectra. So in the UV visible spectra, we get the conjugation pattern, that is whether the pattern of double bonds and what is the N to pi star transition, pi to pi star transition, all the electronic information we collect from that, and from the infrared spectroscopic techniques we find out the presence of the various functional groups, whether the hydroxyloids, polyphenolics, whether it is a polyphenolic or whether it is carbonyl, like in the case of flavonoid compound. And the master tool is the nuclear magnetic resonance technique. So here in nowadays the NMR spectroscopic technique is so advanced that there are a lot of two-dimensional techniques. In earlier days, we used to depend upon only the proton NMR and the carbon-13 NMR, and we have a lot of two-dimensional advanced techniques like the COSI, HSQC, HMBC, TOC, NOC, and the list goes on. And the mass spectroscopic techniques help us to find out the molecular weight and the fragmentation patterns. And the latest advancements is the hyphenated techniques. So hyphenated techniques in analytical chemistry basically refers to the integration of two or more analytical methods into the single system to harness the strength and each and overcome their individual limitations. So here when the GC and the LC systems helps in the separation, the simultaneous identification will be done by the detectors, the mass spectroscopy, and nowadays we even have the LC hyphenated to the NMR systems. So coming to the extraction and structural compounds from the Artocarpus hirsutus, so using the above techniques, we have isolated a few compounds in its purest form from Artocarpus hirsutus. So Artocarpus hirsutus is commonly known as the wild jack and is an endemic timber yielding trees of the Western Ghats. And this tree has been long valued for its medicinal and utilitarian benefits. And Hortus Malabaricus, it is mentioned as Anjali in the 3rd volume. And these are the following medicinal uses that has been represented in Hortus Malabaricus. The root, bark, leaves, and fruits are described with medicinal properties. Pain and rigidity of the joints, chronic hemorrhage induces diarrhea, excites appetite, fermentation of foodstuffs in the stomach, and pain of hemorrhages. Okay, so coming to the isolation of compounds, preliminary tests have shown that the plant Artocarpus is rich in flavonoids, and the acetone extract have yielded 5 compounds in its pure form. One is a plant steroid and 4 flavonoids. And for the extraction, we have used around 2 kg of air-dried Artocarpus hirsutus bark, and petroleum ether extraction and acetone extraction has been followed. And post-extraction, the residue has been subjected to column chromatographic analysis, and we have isolated the 5 compounds and the polarities at which the compounds have been eluted from the column has been illustrated in this slide. So characterization and even though 5 compounds I have mentioned here, I will be just detailing, I will be showing some of the spectra that have been used for the structure interpretation of one of the prenulated flavonoid, artonin E. So first it was purified by column chromatography, then recrystallized, then found out the melting point first. Then we send the compound for the UV analysis, IR and NMR analysis, and from the UV spectrum we could understand the presence of the flavonoid skeleton. Characteristic bands were seen, and shift reagents also were used, and the dihydroxy system, that is you can see over here, the OH groups in the structure, and this was confirmed. And the higher spectrum, again, the presence of the OH groups and the carbonyl functionality of the flavonoid was confirmed. And from the mass spectra, we could arrive that this compound is having the particular molecular formula. And this is the proton NMR spectrum with which we could get the network of how the hydrogens are arranged. And the expanded scale spectra, with the help of this one, we could pinpoint which hydrogen is attached in the corresponding positions of the flavonoid skeleton. And similarly, next is the C13 NMR spectra. This gave the clear picture of how many carbons are present, where they are present. And this is next another type of carbon 13, where we could differentiate exactly the number of methyl CH3 carbons, CH2 and CH2s, CH. And this is the two-dimensional technique that I was referring before. So here we could find the interactions between the neighboring hydrogens. And this is the HSQC or HSQC spectrum, or the proton C13 interactions where we could find out. So using this spectra, we could exactly find which carbon is attached to which hydrogen. And using this technique, we could find out the long range coupling. Like in this technique, we are finding out the first carbon, second adjacent to it, and the third one. Like 2 to 3 bond interactions we could find out, and finally we arrived at the structure. So artonin refers to a group of prenulated flavonoids. Actually, review of literature has shown that this compound is having anti-cancerous properties, including its ability to induce apoptosis and inhibit cell growth in various cancer cell lines. So these are likewise, we have isolated 5 pure compounds and have clearly explained the structure of the compounds. Actually, the number of chemical compounds yet to discover from this species is more. And this is the first time report of these compounds from Artocarpus hirsutus. So what next can we do? So as I have mentioned in my slides, natural product discovery is often a slow, expensive, and with key challenges including de-replication. That means many times we end up in obtaining the same compound, not novel ones. So de-replication need to be eliminated, that is eliminating non-compounds early and solving complex molecular structures. So advanced technologies like the high throughput screening bioactivity, molecular docking and mode of action studies now enable faster identification of compounds, and tools like the molecular networking helps identify non-compounds, early streamlining resources. And nowadays there are a lot of advanced NMR databases and prediction tools are available. So NMR ShiftDB, this is an online platform for predicting and simulating NMR spectra. Similarly, the natural products magnetic resonance database also, wherein we find out a lot of NMR formats and data exchanging is possible. And advanced structure elucidation tools are now available with the advent of AI and machine learning. So computer-assisted structure elucidation integrates NMR, MS, and computational modeling to solve structures efficiently and accurately. And these are some of the models that are being used nowadays. Sirius, it's a machine language-driven fragmentation pattern analysis with computer-assisted structure elucidation. And similarly, ACD structure elucidator with machine learning. Actually, structural elucidation is a very hectic task for chemists, as in the previous slide, like taxonomic nightmare, the earlier speaker was mentioning. So for an organic chemist, the presence of multiple stereo centers in a compound is a chemist nightmare. So with the help of this type of advanced system, the system is becoming little more easy, and hope seminars and workshops like this will help to unravel the much wide chemical potential of plants. Thank you for the patient here.
The topic is open for discussion. Any questions or queries or comments? Dr. Ramchand? Yeah.
I have one question that, normally when you are extracting, isolating and configuration, one of the most important thing is that if you want to convert it as a drug molecule, there should be a synthetic pathway should be there. Because, it is very difficult, the extraction.
Yes, yes.
Now, the major challenges which you already mentioned that, the configuration, especially RS configuration, chirality of it, especially 2 or 3.
Yes.
Chiral centers are there.
2 or 3 chiral centers, it's going
so
to be
what
difficult.
is currently the method you are using? See, one way is that, the chiral separations are possible now.
Yes.
Then, you can take the NMR spectrum.
Yes, yes,
But then otherwise, just by taking NMR spectrum, you can't see the RS configuration.
Yes, we can't.
It will not be. So, and just by an exchange of one hydrogen to oxygen in the RS configuration, the molecule can be 100% inactive.
Yes.
There is a lot of examples are there. So what is to be done at the earlier stage when you are, developing the structure of the molecule, what you have extracted, and make sure that, it can be, it's a synthesizable molecule.
Yes, yes, yes.
Now I am telling that, probably then this is the time that to use the synthetic biology.
Yes, sure.
Because, the chemical synthesis is, it will become extremely complex.
Yes.
So one can, a chemist can connect with synthetic biology. That means each and every enzyme to be used and to synthesize the molecule.
Okay, thank you.
So you have a method by which identifying this RS configuration when you are...
No, actually, in NMR techniques, we can go for, as you have mentioned, the exchangeable that can be used, and actually the knowledge about the biosynthetic pathway, from that we can get a clue. When the structural elucidation becomes difficult, we have to actually look into, like partial structural elucidation would have been complete, and we have to actually look for the sister compounds or something like that, and in that can give a clue actually about.
My idea was to, like probably all organic chemists now, synthetic organic chemists should also think about synthetic parts. I will tell you hydroxycitric acid.
Yes. Yes.
There is no way it can be synthesized.
Yes. Yeah.
Because just because of one chiral.
Yes, chiral centers are actually, it is very difficult for synthesis, and sometimes what is happening is that it is usually obtained as racemic mixtures, and the resolution is actually difficult. So we have to think more prospects in that way.
Yeah, well...
pathway, yes, yes.
Well, thanking Dr. Renina for her presentation, I invite the next speaker, Dr. Sivakumar Moni, for his presentation on biomolecules from natural resources in pharmaceutical innovation, exploring significance, product development, and regulatory strategies for global health prospects.
Yeah, may I now invite Dr. Anubalan to present a memento to Dr. Renila as a mark of our appreciation. Dr. Sivakumar S.MONI, Associate Professor at the College of Pharmacy and Health Research Center, Jazan University, Saudi Arabia. A renowned expert in vaccine technology and nanomedicine, his research focuses on nanoparticle-based targeted drug delivery and natural product-based therapeutics with notable contributions to breast cancer, liver disease, and rheumatoid arthritis treatment. With over 100 high-impact publications, multiple international patents, and international recognition, including the Jazan University Distinguished Researcher Award, Dr. Sivakumar continues to bridge cutting-edge science with real-world healthcare solutions. We are indeed privileged to have you with us, sir, and we look forward to your insights.
Thank you very much. Good afternoon to everyone. I think this is the very next moment. The time is like that. Anyway, I will try to explain as short as possible. So, my topic is on biomolecules from natural resources. So I am the basically pharmacy person in the formulation scientist and vaccine technologist. Of course, I am interested in natural products also. So what are the possible things to explore? So I have explored in Saudi Arabia, especially in southwestern region of Saudi Arabia. So why we need novel pharmaceuticals? The world is towards striking towards, they develop a lot of research, lot of pharmaceuticals, lot of formulations, day by day it's coming. Since the major task is novel infections and novel diseases are coming out day by day, and as well as, you know, the drug resistance is the major factor for this. So drug resistant, it may be in infectious disease or it may be non-infectious disease like cancers. So we are just now we suffered from COVID. We are thinking COVID is the most danger. Soon multiple antibiotic resistance is going to rule the world, and we are all going to be in trouble due to these resistant factors. So what is translation research? We are doing research work in the laboratory, and we are finding out what are the biomolecules can be useful and how we are translating into the product, which is the most important thing. Then only it becomes a live one, which is I am feeling, because I am basically from pharmacy person. So translation research is more important towards the society development, from the laboratory research to the product development. So as I already told, my area of research work mainly in vaccines technology and nanoparticle technology with cancer targets, targeted delivery systems, and of course natural resources also, and here exploring natural resources. So we explored marine resources, especially seaweeds of Red Sea, and we explored the soil screening methods, desert plants, and even water as a therapeutic agent. Now my study area is a Rijal Alma. It's near to our Jazan where I'm working here. So it's a natural corridor of a UNESCO Natural Heritage Site, where a lot of medicinal valued plants are available by nature, desert plants. Okay, these are some plants, desert plants I explored, like Caroluma retrospeciens, Alum filantarine, Adenium flowers, and Aloe officinalis. Tree aloe, these are commonly available in the rocky regions of Saudi Arabia. So Caroluma retrospeciens is a wonderful desert plant which is grown in the rocky region of and its stem, which has exudate gel, there is a sap is there. The sap is wonderful medicine. Even the local people of Rijal Alma, they are using this sap as excusing that and for the wound healing. It's a wonderful medicine. Even I also tried for that. Okay? So that we want to make as a science over here. So I collected the sap, that means exudate gel, and it's highly viscous. So being a pharmaceuticals, the viscosity grade is much more important to develop any pharmaceuticals. So I studied on the viscosity, and by diluting the various dilution factor, even the viscosity, even the product is highly stable during dilution also. However, there are a lot of biomolecules we could able to find out in GCMS with FTIR spectroscopy, and it shows wonderful antibacterial effect and antifungal effect, especially hospital isolated Candida albicans, against Candida albicans. So it is a wonderful medicine to develop like transdermal patches. Okay. Now, during our research work, we are developing this study because Caroloma retrospecies, the exudate gel was unstable. Even it cannot stable for a long time in the refrigerator condition also. So what I thought, being a formulation scientist, I prepared simple nanocrystals of the natural extracts. It's an injectable nanocrystals, and the crystals shows many wonders. That means the activity is more effective when compared to normal exudate gels. So this is the scanning electron microscopic study of these crystals, and it's more stable also when compared to the normal gel. So developing into nano formulation, which has an advantage, the zeta potential has increased when compared to the normal extract. So the developing into the nano formulation is much more important. The reason here is penetration into the bacterial cell is a great task. Penetration of any drug molecule. Any drug molecule has, any natural extract has antibacterial effect. But how far it is really is going to be useful, that is much more important. There, nano formulation will be succeeding. Now, this is the flower of Caroloma retrospecies. So it's a beautiful flower, and it's also having a wonderful property, more better than the stem gel. So this stem gel, this Caroloma, the flower, when we pack into the polythene bags, it becomes liquefied. So we were wondering how it became liquefied. So I thought it's highly viscous liquid have been developed, and I was studying the various nature, physical nature and chemical nature of the gel, and it shows wonderful property of medicinal property. It shows more better than antibacterial effect than Caroloma stem sap. So here we are planning to develop nano formulation by means of vesicular techniques and as a product development. It's highly promising, and almost 75% efficacy of ciprofloxacin. Almost 75% efficacy of ciprofloxacin. We tried many times, and it shows the unique property. This is the tree aloe, which is growing in the hilly region of Rizal Alma. There we are collecting the gel from directly cutting out the stem of the tree aloe, and the study is under process. I could not be able to discuss here. Aloe officinalis, many people know about the Aloe officinalis, and in desert Aloe officinalis, which has a unique properties, and it is grown in all over. It's near to Al Harub, that is Al Kidmi is a place where the desert region where these plants are grown. And I studied, the study is under process, but I studied mainly flowers, how the flowers, because it was so attractive, and the flower, and it got extracted and getting various chemical analysis by GCLC and FTIR and NMR analysis to get what are the components present in the actual crude extract. So these are some prominent components we could able to find out there. And it's promising to develop nano formulations. Being a nanoscientist, I'm saying, to get a very good product in the market. Next is curcumin. Everyone knows about curcumin from turmeric. So curcumin is a naturally isolated compound, but of course we purchased from Sigma only. So curcumin we developed as a nano gel, injectable nano gel, and those injectable nano gels is becoming wonder, and we are the first person reporting for what you call oxidative stress against ischemic stroke. So it shows it is able to transfer the blood-brain barrier, and it shows the wonder here by means of nanogels. These are some, I want to show these are some nanoparticles have been developed, gel formulation, and its zeta potential is highly unique, highly stable, and its particle size is unique to cross the blood-brain barrier. And of course, it shows a lot of wonderful activity with antioxidant, and all psychomotor tests passed. And it shows modulated, and the rat has been therapeutically cured here. Now, alum fulantine is the plant where it near to our Jazan, there is a place called FIFA region where it is grown, and the people of the local people, they are using for wound healing, and it is also showing wonder. So when you cut down this stem, and it shows a thick viscous fluid, gel is there, and when you study this gel, and it shows very good antibacterial effect, not as a after diluting only, because it's a highly viscous, and it shows that there is a possibility to develop transdermal patches or wound dressing. It can be developed in future. These plants will be more prominent in the pharmaceutical development. So next is Artemisia. Everyone know about it in our country also. And this is a very common plant they used to have in marriages. They used to keep in their head, and what you call, ornamentally they used to do it. But it has a wonderful medicinal property. Okay, so by means of its extracting, we could able to find out lot of biomolecules here, and it shows antibacterial activity. Of course, it shows very good cytotoxic effect, especially against MCF7 breast cancer cells. However, it failed with colon cancer. I don't know why. The reason we are not established. And when you see the wound healing property, the wound healing property also so wonderful here. By modulating the cytokine network, especially IL-6, TNF-alpha, and IL-1 beta, and the wound closure was very prominent by only with the extract we have done, and it shows a wonderful activity. So there are a lot of possibilities. The study is still under the way. Lots of possibilities there to develop novel pharmaceuticals. Now they travel from the plants. Then I went to soil screen, because when I was doing post-graduation, we used to do this kind of work from soil actinomycetes. Okay, so there is a river bed in Rijal Alma. From near to Rijal Alma, we have taken this by digging the soil. Actinomycetes have been isolated, and it has been fermented and fractionized. And after fractionization, lot of fractions, and we studied the biochemical nature of the fractions and the analytical nature also, and it shows wonderful biochemical composition, bioactive composition, and it's highly stable. We tried with thermogravity analysis also. Okay, so unique structures were developed. So interestingly, interestingly, while isolating the actinomyces, while developing the fermentation process, we could able to isolate another bacterial origin, which is of novel gene, which have been isolated, and I got the gene number from a new novel sequence. I got a gene number from NIH, from NCBI. So this can be classified as a novel bacterial origin from the Spigmomonas species. Okay. So this is the gene number, which has a wonderful property. Still, the study is on the way. It has cytotoxicity effect, and it also have a potential antibacterial effect. As I already told, Red Sea is one of the major resources for pharmaceutical agents. So in Red Sea of Jazan, we used to collect the seaweeds at the seashore level, and even at the around 1 kilometer region, we used to travel inside and collect all the seaweeds. And all these plants are identified by Dr. Ramesh, who only identified, and he helped me a lot for the identification. So we studied a lot here. While extracting, we got crystals, and those crystals which has a potent antibacterial effect but failed with the cytotoxicity effect. So we tried to develop a nano formulations from these nanovesicular formulations, and those vesicles have been developed by simple film hydration technique, and these are the structure of nanovesicles. By means of sum and redox analysis, we could able to analyze the character of the vesicles, and it has unique, highly stable zeta potential, and the this suspension which has, the solution which has highly particulate system, and with the particle size are more or less uniform. When I tried with the wound healing property of these nanovesicles, and it is more successful in treating wounds. So it was easily closing the wound site. It was easily closing the wound site by modulating the pro-inflammatory cytokines level, and it was most successful to develop as a pharmaceuticals. Of course, my regular eating habit of these dates, and I want to do something there. So I have isolated that, separated that seeds, and I want to say, see, anything is there or not. There was a wonder. It shows a very good cytotoxic effect against MCF7 breast cancer cells. There are a lot to discuss here, but time is not. As you know, Muria Konji, that is Karupule, and it is grown near to our university site, where I have collected these leaves of the curry leaves, okay? And we studied it, how the characterization varies with the desert in the, of course, it is not the origin of Saudi Arabia. Of course, it might be from the India only, okay? So when you see this, there are many wonders. You can say a lot of biochemical molecules have been, especially epigamin has been, can be isolated from here and can be successful molecules. And when I prepared this as a medicinal oil, and I tried again with the wound healing property, and you can say the cytokine modulation was so fantastic. Cytokine modulation was very. So take Karupule daily, because it shows potent anti-inflammatory characters. So Karupule is more, this way in our traditional, our foods are having these items, because by nature we have to take like that. So those scientists, they developed, and actually it's truth, okay? Much more I can, so interestingly I came to the water as a therapeutic agent. I studied on Zamzam water, which is holy water in Saudi Arabia. And it shows a lot of wonders, you know. it shows a lot of wonders. See, the unique zeta potential is there, and there are many other characters also I study, all are I'm not showing here. And that distribution of zeta potential, particle size are very uniform, very unique in character. And the wound healing property, where I tried with all the wound healing property, this one is the best, I can say. Only with water, no medicine, only with water. I have given only water. And the wound healing is very, 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 very fast. I think the seventh day, the closure starts. The seventh day. It means it has a potent, what I call many active constituents, it is available in Zamzam water, especially minerals, and it shows good medicinal value. Of course, when this is Al-Arida hot spring water, you know, hot spring treatment, balinotherapy is there. So I tried to develop, we want to study for some other formulation. Of course, we are trying now Zamzam water with eye drop, Zamzam water with some other formulation like parenterals. And we are trying, now we also screened the water from the hot spring. And both Zamzam and Al-Arida water, which shows potent bacteriostatic in nature. When you expose to the environment, I exposed to many what I call packaged drinking water. So when I'm not showing there those results, because when I make a paper, a lot of objection came. Why you want to show all the packaged drinking water? So when you expose those things, Zamzam water, not even 1 or 2 bacteria were growing, remaining highly resistant. As well, this Al-Arida water also, which shows highly bacteriostatic in nature, and which also shows unique potential, zeta potential. And we are trying to develop by using this water for novel formulations. It is under the study level. So finally, I want to say, anything extract, anything, whatever we are characterization, it should be come to the market by means of products. In that aspect, nano formulation is the nanoparticle, nano-sized level particles is the most successful, and the world is now towards nano only. And the effect of us is always better than with the normal one. The effect, not only this study, I studied with the cancer drugs. I studied with various other antibiotics also. So nano formulation is more important. The thing here is regulatory affairs which should play in the natural product to maintain the sustainable and to maintain the what I call product standardization and uniformity. That is more important. In natural products, this is a great question. I have got this product, that product, this is how much it is available. Still no standardization is under level only. Okay? So these standard regulatory affairs, regulatory standardization should be followed to maintain the standards. As a last version, I want to say, nature is a marvel. Where the question arises, interestingly, the solution is also from the nature. So we have to save our nature for the future generation. Thank you very much for giving me an opportunity to share about a brief idea about one of my research area. And I really thank the organizing committee, and I also thank Dr. Ramesh, who invited me to give some talk on this, what I have contributed. This acknowledgement, I want to thank my university and the Ministry of Higher Education to sponsoring, because that's more important, sponsoring for our research to develop, to come out with various research findings.
So thank you, Dr. Sivakumar Moni, for keeping the time. And now we are encroaching lunch. I will go for the next presentation.
Thank you.
Thank you, sir.
I think as we are already running behind, we'll go to the next. I invite Dr. C.N. Ramchand for the next lecture. I'm sure for all of us, especially for students, Dr. Ramchand is going to give you an exciting area of how we can utilize our research products into in developing innovative molecules and how to make money out of it. Dr. Ramchand.
May I take a few minutes to honor Dr. Shivamani sir? I request Dr. Anupalan to present a memento to Shivamani sir. We now invite Dr. C.N. Ramchand, CEO of Saskin Life Sciences and a globally respected biotech entrepreneur, educator, and innovator. With over 45 years of leadership in drug discovery, neuroscience, nanotechnology, and translational medicine, Dr. Ramchand has held senior scientific roles at Sun Pharma, Cayman Industries, and leading global research institutions. He has authored over 100 publications, holds more than 50 patents, and developed numerous clinical drug candidates. He is the recipient of prestigious honors, including the Kerala Academy of Sciences Fellowship of Honoris Causa and the Udyog Ratan Award, and the Royal Society INSA Visiting Scientist Award. Founder and CEO of multiple life sciences companies and a mentor to over 30 PhDs, MSc scholars, MDs, Dr. Ramchand continues to make groundbreaking contributions to science, innovation, and industry on a global scale. So, we are honored to have you with us today.
Thank you, Shabaz. Thanks a lot. Thank you, Sam and Anoop and all the team for organizing this wonderful program. We have been hearing quite a lot. I'm never a botanist, so I'm an organic chemist, maths, physics, chemistry like Sam. Then I do not know how he has learned all this fantastic, especially about Hortus Malabaricus or the medicinal plants of Kerala or India. And something amazing. And, last 10 years I've been coming here. And that was the time he has just initiated the process of setting up this. And now you can see how the things have been translated. So one thing now is missing is that research institute. It is Hortus Malabaricus, that HB... Malabaricus Research Institute, finally. So that research institute is missing. I hope that he will set up and something the students can take home. Like, I'm just going to give you a different method how the drugs can be developed from natural product. That's what I'm going to discuss to you. And you have been hearing about all the taxonomical aspects. For example, like a species, genus, or a family, or domain, etc., etc. And I realized that something is very absolutely novel. And finally, one of the speakers was also mentioned about the molecular characterization of various species. Interesting, and I'm sure that probably in the future things are going to change, especially characterization of all these plant species. And so you can really see Hortus Malabaricus. That means the medicinal plants of Malabar or Kerala. Let's say that, medicinal plants of India. Now, in the next few slides, I will explain to you what are the challenges. Let me tell you about the drug discovery process. It's not very simple. You might be knowing that we have about 36 or 35,000 various diseases, 30,000 genes. We have about 2,000 protein targets, identified only few hundred, 200. And basically to treat this 36,000 diseases, we have only 450 plus basic molecules. That is what you have to remember. Only, I am talking about allopathic molecule, only 450. There is something called, Me Too drugs, which I will explain during the course. And altogether about 2000 plus, and there is formulation, millions and millions of formulation. That is like, various, that's very easy to develop. But fundamentally, to develop a molecule is not that simple. India has never developed. You can understand that only 7 countries in the world could do. Now novel biologics are also coming. Now, another thing is that, the rational drug discovery and development has started only last 100 years. Sorry, rational drug discovery has started last 50, 60 years. And the modern drug therapeutics started coming only last 100 years. And before that, everybody was dependent on plants-based therapeutics. With all these things, so the first one of the earliest molecule came in the allopathy is salicylic acid. Salicylic acid is extracted from plant. Then morphine, then, plaxitaxel, then, series of quinine, artemisinin. Now, do you know how many such molecules are approved? This is the first thing you have to understand. So far, out of 450, roughly about 4-5%, the one which I was telling. And I can tell you about 25-30 molecules altogether. Caffeine is another one. These are the ones which is approved. But at the same time, many of these structures are utilized to analog. And analoged about 100 molecules are there. Out of 450, 500 molecules, this is what plant has. So what I want to tell you is that the moment it is analog, synthesized new molecule, it is as complex as any other drug discovery or even more complex. Analoguing. An example, quinine, it is taken from plant, but chloroquine, it is derivatized. Hydroxychloroquine, that is also derivatized. Now, the other two are comes under synthetic. The first one is natural. The advantages are the second chloroquine or hydroxychloroquine, several various advantages, whether it is connected to pharmacokinetics or the toxicity or the efficacy of various things. This is what the bottom line of drug discovery. There is still, we have to go a lot of advancements and going forward to develop drugs for many, many diseases. And the drugs are there, very good drugs are there, inflammation, asthma, allergy, and pain management, all those things. And if you really see cardiovascular disease, you just analyze and see hardly anything is there, cardiovascular disease. Right now, triglyceride can be reduced by fish oil. Other than that, real drugs, we don't know. Cancer, of course, it is coming up. Then forget about all those things. Neurological disease, talking about schizophrenia, depression, mania, manic depression, Alzheimer's disease, or memory dysfunction. There is nothing. The reason is that we do not know the mechanism. Now, this is the background about the drug discovery, biologics discovery, development process, etc. Now, what can be done in this background that, from natural sources, what can be done? This is why I want to introduce something called reverse pharmacology. Straight pharmacology, how it is done. That, for example, if it is a plant-based drug development process, what you have to do is that you have to extract, isolate, separate, what is called bio-guided separation. That means you will be having a functional protein, an enzyme, or a receptor, or a ionic channel, transduction protein, transport protein. If you have an assay, then based on certain empirical understanding, you will screen the molecule, but that's a very, very complex process. Finally, you will get something, and you realize that when you have given to the human for a phase 1 trial, there is no pharmacokinetics. This is a major problem with most of the natural product. Even if there is a good pharmacokinetics you formulate, there is something called cytochrome P450, which controls the metabolism. It's gone. So these are some of the problems associated with when you are developing natural products. Whether it is synthetic also, it is like the synthetic chemistry which one of the speakers has mentioned, so complex, unbelievably, but if you are translating that from natural product to synthetic, even more difficulty is there. Now, what can be done using reverse pharmacology? Reverse pharmacology simply means that, first you test in human. Now the questions will come. Can we test? There are certain conditions in which you can test. For example, if you want to test Ayurvedic products, there is no problems are there. Approved nutraceuticals. Or let's assume there is something called, grandfather product by US FDA. That means anywhere, let's say Karivepila. If you want to do something for Karivepila, you are mentioning about Karivepila use. Then you can do a reverse pharmacology test. The first is that you test in human. And in order to test, you don't have to go to CDSCO, nowhere. You can do under an ethics committee approval, and you formulate that one. If you are using a novel formulation, you have to go for a simple toxicity study. If it is not there, ethics committee will approve and test in human. You can make sure. See, right now, the drugs are called evidence-based. If there is no evidence, if you are telling that molecule is this, you have to give the structure. You have to show that it is passing transcellularly or it is passing in the intestine. It is metabolized or it is excreted, and you have to show where it is going and binding. It cannot go and bind to 10 different receptors. These are all actually FDA is or CDSCO is checking. So a molecule, single molecule can normally go and bind to a single receptor or enzyme. Then you will have to develop that further. Now this is the background. Let's see. Now, traditional use of medicinal plants. So that centuries we have been using. I will come back to that reverse pharmacology approach. Simply what I am telling is that you will have to do a human test, which is possible. There is a second possibility is that you can also do an mRNA expression with these extracts thing. Now, please also remember, when you are going for an allopathic drug, evidence-based drug molecule, you cannot use an extract. There is only one place that you can use extract, is that as per US FDA, botanical drug category. There you can, but well defined. You can't do like our Ayurvedic product. Very interestingly, please remember that our Ayurvedic product, everybody is telling very good, but it is not imported in the US, very limited. The problem is that it contains hundreds of different compounds. Unless it is a defined thing, they will not tell. Take it. US FDA has no issues. You can sell it. But the issue is that, this is sold by distributors. The distributors will ask 5 questions. Do you have a patent? Do you have done the tox studies? Did you do the pharmacokinetic study? Have you done the clinical evaluation? Then you will be able to do, which is not there in Ayurvedic product. Anyway, suppose you think that some of these Ayurvedic products, you want to do reverse pharmacology approach, which you think that hundreds of products are not there, like curcumin or hydroxycitric acid or alpha-ketobospholic acid. You extract that one and you can do a clinical evaluation in 20 to 30 patients, and you can go forward, that which I will be mentioning. Now, I just want to, I have mentioned about this Charaka Samhita and Sushruta Samhita, which has mentioned about various, the natural products. Now, if you really go and see that one, okay, what they have mentioned is that if you see about, let's say, curcumin, maybe hundreds of different applications has been mentioned, hundreds. The same way many of the plants. So a modern scientist's duty is that, take that idea from there. You don't have to go for the 100, which is probably workable one or two things, and go forward. But please remember, you have to go and test it for something which is already not done. If anyone is trying to develop another paracetamol, which will be a failure, because you don't need to. And another, like trying to make, natural product for an infectious disease. Of course, if it is a Clostridium difficile associated diarrhea, those type of diseases, fine. But infectious disease, very good molecules are available and it is very easy to synthesize. But what you have to do is that, for example, metabolic disorders or neurological disease, Alzheimer's disease, nothing is there right now. Reasonable mechanisms are there. For example, traditionally, Bacopa munieri has been mentioned, and try to do that one. that what you have to do is that, test it in humans, see whether it is going to work. And why I'm telling testing, which is already known. But what you have to do is that an appropriate formulation which really goes into the central nervous system. The other one is that it is formulated in such a way that it is not metabolized easily. So these are some of the things and which you will be able to do the reverse pharmacology approach. So you know about the unique resource, Hortus Malabaricus, medicinal plant repository contains over 800 medicinal plant species. I just want to tell you one thing, 800 plant species are here. But it has been, and currently, probably about, 2,000 plus such the metabolites, which has got drug-like activity. It's called drug-like activity. That means it has got some therapeutic activity, has been identified, which I mentioned, only few have come. But it has been reported that, 200,000 to 2 million opportunities or such plant metabolites are there all over the world. That is what we have to explore. Instead of, this is fine. For example, this 800 plants, probably another 1,000 maybe plants might be there in India. All over the world, just get the extracts and see how we can go forward. So education and research hub, a living library for research and biodiversity conservation and eco-wellness integration. That is what Sam is doing. I am sure that within no time he will be introducing a research lab also here, which probably he will be doing this reverse pharmacology approach. So what is the current practice? Extracts are made from plants used in traditional systems like Ayurveda or as a nutraceutical, certain regulatory restrictions. Now, I will also tell you, you have an extremely good opportunity to develop nutraceutical molecule. Nutraceutical molecule is maximum used in the US market, 300 billion. In India, it has only 1% of that, 3 to 4 billion. And other places, Europe, the other place is Japan and Korea. Probably 80% of the nutraceuticals are used. And US, this is going so high, currently 300 billion, which is not small amount, and the statistics show that 84% of the US adult consume some kind of nutraceutical. How they consume, no doctors will write. They go to the shop and buy it. What is the basis? They will check the publication. So the publication is very important. This is the way people buy that one. Of course, that the distributors will advertise that also. So, but efficacy, active compounds and mechanisms are unclear. In case of nutraceuticals, active molecular mechanisms and efficacy must be known. Now, that is the difference. Many of these plant-based products, which is probably might be working, but the mechanism is not. Mechanism means which receptor, which enzyme, or going and inhibiting, and what is the transduction process. But if you are developing it as a nutraceutical, that is like in vitro mechanism, you can establish. But it is very important that some kind of reasonable efficacy has to be shown in human clinical trial. Please remember, if you show a proper, appropriate efficacy in humans, it will become a drug molecule. A very good example is EPA, fish oil, eicosapentaenoic acid, which has become a drug molecule 8 or 9 years, 10 years back by GSK for reducing high levels of triglyceride. Until that time, the lipid and other molecules were there to reduce triglyceride. But after this came, when you have an extremely high levels of triglyceride, fish oil is the one used. And though it's a natural molecule, it has that particular drug became very big. It's about $4 or $5 billion molecule. So, what are the challenges in traditional approaches? No stringent regulatory requirements, then mechanism not well studied, no standardized doses or composition, which you all know. Let's say that Ayurvedic medicine, one of the major problem is that it is taken from, first of all, it's like so many constituents are there. These are all taken from different places. And it is very difficult to decide what is the dosage, and probably if you are talking about the natural product, it will differ. So it is very, very important that especially Ayurvedic product, or if you are developing nutraceutical, the base material has to be highly standardized. That is what people are doing. need for a new approach, fusion of traditional wisdom. That is what we have been discussing. The tremendous traditional wisdom is there. Now, and the modern science. What is the modern science? Modern science, first I told about the reverse pharmacology approach, in which you can do a clinical trial. The second thing is that mRNA expression. That means cell-based assays. So the advantage is that, if you take an extract and if you incubate with the cells, like mammalian cells, what will happen is that, if it is really active, certain mRNA will upregulate or downregulate, because it goes and binds to a particular protein in the transduction process. By the transduction process, some protein will upregulate, downregulate. This will give as a kind of signal, as an mRNA. mRNA expression and microarray technology can be used. You will get what type of mRNA can be there. That particular study is a very complex study, because, when you are doing, because I have done that, it's like, you have 20, 30,000 mRNAs will be there. Probably 500, 600 will upregulate, and it's very important to pick up which is the right one. The reason is that, for example, something activates the glycolysis TCA cycle or, electron transport chain. All that 50, 60 different mRNAs can go up. But that is not, you can't touch with that, because that is something like, housekeeping pathways. So let's say inflammation. If we are getting cyclooxygenase or lipooxygenase or, phospholipase A2, those type of something upregulates or downregulates, immediately you know that, yes, this is the point I have to work. So what I'm telling is that combine reverse pharmacology and mRNA expression, you will have a very quick method to develop a novel molecule, not initially as a novel molecule, take as the extract, then, develop as a nutraceutical, simultaneously make sure what all different diseases you can utilize. Don't go, as I mentioned, which already an existing drug is there. It will not work. Don't try something for pain or, infection, etc. Something which is not there, which you will get hundreds of diseases. Anything connected to CNS, central nervous system disease, nothing is there. Really nothing proven. Schizophrenia is a very good example. Mania, manic depression, or sleep disorder. There is no very good sleep disorder, of course it is there, but many of the other conditions is not there. Pick up that one. Metabolic disorders, though everyone is telling, of course, now allopathic drug has come, which is GLP-1 agonist, which is for diabetes, but it also reduces the weight. Otherwise, metabolic disorders, because there is 63 different kinds of metabolic disorders are there, which really do not have much disease. For example, fatty liver. So you can develop something for that. So a new way, I will quickly go. I know that, the time is running. There is not much time. So I really wanted to discuss many things, but instead of that, I will read out. So a new way, start from non-human use, then validate scientifically. That is what I was mentioning. The validating scientifically has to be in the laboratory, as well as biomarkers in the humans you will be able to do faster and builds on existing knowledge. The traditional way, this is what everyone is doing, isn't it? Like, in the lab, which a couple of people have already mentioned that, you take the extract, isolate the products, then bio-guided, the activity you find out, then go forward. But the problem is that you do everything, maybe 3-4 years, and finally formulating, and when you are doing the clinical trial, no efficacy. The second thing you will find is there is no pharmacokinetics. That means it is not transported. The whole study becomes waste. Instead of that, go the other way, where you can do. Then continue the research. But if you want to develop as a molecule to be filed for an IND in US FDA, then you will have to do everything, but at least you have certain kind of certainty, this is going to work. And reverse approach is the one I was telling, patient to lab, real world needs, inspire research, patient experiences and guide innovation. Now, what are the 3 phases of reverse pharmacology? Clinical observations and traditional records. So what you have to do is that, traditional record from Vaidyas or even from clinical records, when you are doing, a very interesting thing you can see, if you see the clinical reports of Viagra and side effects, Viagra is for PD5. Of course, originally it was developed for something else, that is pulmonary hypertension. Then during clinical trial, that is a very good example of serendipity or, a reverse pharmacology approach. But after the clinical trial, one can see so many different small side effects. And what you have to do is that pick up from that. Every molecule that if you really study the clinical evaluation, all the side effect profile, you will be able to get very good idea how this molecule can be used for something else. Natural products also, you can do that one. Now, let's see that, clinical observation and the traditional records, Terminalia Arjuna, Barkov's cardiac. So, traditionally it has been mentioned as for the cardiac health. Now, cardiac health good, but where it is working, it is not known. It has been mentioned that, it reduces cholesterol. It is also mentioned that it is for gastrointestinal disease. And this particular extract, there is no problem. Anybody can be given and you can study the patient. For example, if it is a cardiac disease, what are the cardiac markers? For example, triglyceride is reducing, HDL, LDL, the ratio is changing. Those type of things you can do and develop the molecule. Experimental validation, mRNA expression, functional protein identification, which I already mentioned, and understand the molecular mechanism. It is very important. So, very early, easily, by doing these three things, which takes probably 1 year. So, normally the time you are losing is for clinical evaluation, IND. In this approach, where you know some molecule, natural product, the time will not be lost. Then focusing unmet medical needs. Choose diseases with no effective modern drugs. Neurological disease, metabolic disease, which is very, very important. Don't work on something which is already there is a drug. It is not going to be successful because many places I go and explain this one. You don't have to do something for infection, food infection. Now, diabetes is a very good example. Don't try to do diabetes because already so many drugs have come. And unless you are showing something, it is far better than metformin or other things, that you will not be able to go into that space. It has to be better than the existing one. And please check that 1,500 trials have been done with natural product, nothing with successful this thing, because that nobody accepted that one. So what I'm telling is that don't go into those type of diseases where there is nothing is there, so you will be able to get up with something. Then you can understand from Kerala's traditional books and healer knowledge. Healer knowledge, what I meant is that, Vaidyas and tremendous, you will be able to get a very good idea from them. Yeah, I have already mentioned some neurological disorders, memory loss, anxiety, sleep problem. These three are there for many, many people. I have sleep problem. Last 2 days I didn't sleep because I was traveling. So you go through kind of, jet lag. And plants are already used traditionally. Can we prove it works scientifically? That is what we have to do. Many of these conditions and metabolic disorders, which I mentioned, obesity, diabetic complications. And the local practitioners use polyherbal mixes, need clinical evidences. So in that polyherbal, see, many times there will be 100 different things will be there. Probably 1 or 2 might be the real working things. Please pick up that one and you will be able to, using reverse pharmacology, you will be able to develop the molecule. Then how a proof of concept design, because see, I'm just telling, because I've been doing this for quite some time. This type of, for example, recently a novel EPA, fish oil formulation we have developed. This Amrita, the proof of concept study is going on, where we have developed a formulation in which the bioavailability is 100%. Normally, fish oil in empty stomach, it doesn't get absorbed. So we have developed something by a formulation, a novel EPA, and the clinical trials are going on, and it is not complex. The complexity comes a novel single entity molecule if you are going for a phase 1 molecule, which India has never ever given an approval. Symptoms improvement and changes in biomarkers. These are the 2 things you need to check when you are doing this proof of concept study. An example I have mentioned, like, Alzheimer's disease, Parkinson's disease, etc. So if it works, next what? So take positive results from the lab, find how it works at cellular level. So you will have to also understand the mechanism, because don't go to the regulator. If you want to go to the regulator, if you want to go as a nutraceutical, that also is required, because the distributors will ask how it is going to work. Only thing is that the stringency at developing a nutraceutical is not that complex. And also nutraceutical, it is quite easy to develop, because US FDA has not kept any kind of bar. It's very easy. As I mentioned, if it is grandfathered, that means traditional use. But then all the problems are brought by the distributors, because they want some uniqueness. And if you can develop some unique product with a patent and clinical evaluation, you can be very successful. But I am telling with my experience, you can check, there is at least 10 different novel nutraceutical products I have developed. We have not introduced in Indian market. It's all in US for a previous company. So an example, ashwagandha. Ashwagandha is one of the top 10 products in the US market. Traditional use is anti-stress and neuroprotective. Active compound is vitaferin, which the structure is given. But if you really see the structure, don't try to synthesize. It is very complex synthesis, because it will become more expensive, and ashwagandha can be easily extracted, but only thing is that purity is required. But somebody can easily synthesize, that would be great. Now, modulates NF-kappa B and HSB, heat shock protein, signaling pathways. That is how it works. Probably with this single molecule, single entity, you already have some kind of proof of concept. You will be able to develop it as a very good molecule, especially for the stress. Enhances neuronal function by upregulating brain-derived neuroprotective factor. Now, one more thing I will tell you, plant metabolized in clinical use as a drug molecule, which I already mentioned, that morphine is one, quinine, digitoxin. This is actually as the drug, approved drugs. Of course, this is the patent. Of course, natural product, you can't have a patent. But these are all ready there. And these are the sources are given, and primary uses are also given. So one is, of course, morphine is even now is a fantastic molecule, and anti-malarial alkaloid, and digitoxin is mainly cardiac health. Now, plant metabolized derived derivatized drugs. But this is, what you do is that, they take the structure and derivatize it. Like as I mentioned, quinine, hydroxyquinine, or quinine, chloroquine, or hydroxychloroquine. This type of molecule, this is derivatized, but the moment you touch a molecule structure, then the complexity increases. But you are sure this is going to work. What you have to do is that, everyone knows that quinine has got a lot of side effects. Cardiac problems and various other problems are there. But a chemist's job is, or a medicinal chemist's job is, improve the structure in such a way that reduce the side effects. So that is what, these are called Me Too drugs. Me Too drugs. And compototacin, then salicylic acid. You all know salicylic acid. What was done 100 years back, acetyl salicylic acid is made. Salicylic acid is naturally original drug, which is derivatized to become acetyl salicylic acid, which is one of the most popular drug even now. Then ingenol is a topical treatment for actinic keratosis. It's a cancer, this thing. Now, all these molecules you have heard, isn't it? One of the most highly studied, curcumin. It is not a drug. And it's a nutraceutical. Everyone is selling. The selling way is that because of in vitro. I don't think anyone has studied so much like curcumin. There is 11,000 plus patents and 110,000 publications are there. Still, it is not a drug. The reason is what? Majorly two reasons, because, very poor pharmacokinetics. Not even 1% is absorbed. The second thing is that I have developed a highly bioavailable curcumin, but the moment it goes inside, it is acted upon by cytochrome P450, and the molecule, before even reaching the target, that its activity is lost. Because even if it is there, you need to have a significant, at least 2-3 hours of pharmacokinetic profile is required. So all these molecules, very well-known molecule, capsaicin, then gingerol, ginger, all these things what you know very well, but it has not reached the status of drug molecule, but doesn't matter. Everyone is making money out of this as nutraceutical molecule, because in nutraceutical molecule, the drug claim is not required. That means structure-activity relationship, or structure which is related to a particular condition, disease. That is not there here. So plant metabolized in modern medicine from nature to approved. So 10 to 25,000 plant metabolized with a drug-like activity, traditional, but I think it is probably over 2 million. This is what the literature says, but when I read, I realize that all over the world, probably such number of diversity is there, molecules. So there is a tremendous opportunity for developing molecule, which I mentioned, 25% derived from drugs from plant compounds and 11% plant metabolized directly used as prescription drugs, which I mentioned in the previous slides. Now, bio-guided evaluation, pathway analysis strategy, use mRNA expression study, enzyme assays, functional protein studies. So, which I mentioned that, use cell-based or cell-based systems in which that see how mRNAs are upregulated, downregulated. You can also study proteomics. How the proteome, the best is to study mRNA expression. From there, derive what protein you have to study and develop an assay. Very quickly, 3 months' time, you will be able to do the whole thing. Then fractionation and isolation, which the most important thing is that once you have the extract, this is working, then you can go and find out what particular, a single molecule, if you are interested to develop this molecule as a drug molecule. If suppose you find something for Alzheimer's disease, definitely you should do. And in the meantime, what you can do is that use the extract, formulate it, develop as a nutraceutical, which takes only 6 months' time, and do all the things. So this is the way you have to go. And 2 possible paths, keep as standardized botanical drug. I forgot to tell about botanical drug. This category is there only in the US FDA. There is currently 3 or 4 such molecules are there, in which extracts can be used. In India, you can't go to Sidasco or DCGI with an extract. You have to have a purified product. But in US, you can have, but it should be a defined extract. You can't have hundreds of products. You are telling 5 products, and these 5 products should be in the ratio always, and you can get an approval. There is 4 or 5 such products are there. The other one is that, they develop new drugs from pure or derivatized form. Pure is fine. You can get comparatively quick approval. If it is derivatized, you will have to do many studies further. Regulatory pathways, botanical drugs, which I mentioned, FDA, or new chemical entities after full studies. Benefits of reverse pharmacology, faster, cheaper traditional drug discovery, uses real patient data from the start, honors and validates traditional knowledge. Future opportunities, make Kerala a hub of evidence-backed plant therapeutics, export high-quality natural products, analogs, botanical drugs, and nutraceuticals. I hope, Sam, you will do this, because when you set up an institute, apart from all these various other studies and plant species understanding, probably this approach will be an excellent way to develop new molecules. Thank you.
Thank you, Dr. Ramchand, for the brilliant exposure of our future. And I'm sure the students are benefited. You have an idea now how you can make money out of it. Instead of, he has given you excellent examples, plenty, not one. So please make use of that. And I think we don't have any question and answer, because this is already running late and 2 o'clock. We break for lunch. And thank you all. And thank you, Dr. Sam and Anup, for giving us this opportunity. And it's an excellent 2 days program. and hope we will have many more like this.
Thank you, Dr. Ramchand, for that insightful and inspiring presentation. We express our sincere appreciation, Dr. C.N. Ramchand, and request Dr. Anup to present a memento on behalf of HMBGRI. I also request our session chairs, Dr. Maya C. Nair and Professor Dr. Edathil Vijayan, to kindly receive mementos from Dr. Anup Balan in recognition of their time and contribution to this session. With that, we conclude the morning session. Lunch is served at the Birdwing Farmhouse restaurant. Please be back by 2:30 p.m. as we have 4 more distinguished speakers awaiting us in the afternoon. Thank you.
Hello. പിന്നെ ഇത് അനൂപേ അപ്പോൾ പിന്നെ എനിക്കിഷ്ടം പോലെ സമയം എടുക്കാമല്ലോ.
Welcome back, everyone. I trust you all enjoyed your lunch and had a good break. Let's get ready to dive into the next set of exciting talks we have lined up for this afternoon. I would like to invite Dr. K.K. Sita Lakshmi, Director of Research, Integrated Rural Technology Center, Mundur, Palakkad, and the former Senior Scientist of Kerala Forest Research Institute, PG, to chair the session. I also invite Dr. C.P. Shaji as the co-chair. Next, I invite Dr. P.E. Rajashekharan to give the lead speech.
Shall we start? Yes. As introduced, I am Dr. Sita Lakshmi. Actually, I came today I'm inspired by Dr. Ramesh, his narration about this place. Want to see it and be among the audience like a regular participant. In between, Anup found me and he picked up me for this position. Really happy about this opportunity. And I think both the speakers are well experienced. They are not only good speakers, but they have managed from this side also. So I think I would not have to use the opportunity of the unpleasant work of the chairperson to control time. So please, Rajan sir, please. I've seen him as a speaker, examiner. He's a regular PhD examiner to our college, Government Victoria College. So welcome, sir, and please.
Dr. P.E. Rajashekharan, retired Principal Scientist at ICAR, Indian Institute of Horticultural Research, Bengaluru, is a renowned expert with over 35 years of experience in biodiversity management, cryopreservation, in vitro conservation, and intellectual property rights. A pioneer in conserving rare, endangered, and threatened medicinal plants, he has established India's first pollen cryobank, recognized in the Limca Book of Records, and developed technologies widely adopted by the seed industry. With over 200 research publications, 2 PhD supervisions, and numerous national and international training programs to his credit, Dr. Rajashekharan has significantly advanced India's horticultural genetic resource conservation. A fellow of both the Indian Society for Plant Genetic Resources and the Indian Association of Angiosperm Taxonomy, his work continues to bridge science, policy, and community-based conservation. Sir, we are eager to hear from you.
Thank you, respected Chair Dr. Sita Lakshmi Madam and the co-chair Dr. Shaji and my dear fellow participants. Good afternoon to all. Yes, I think it is difficult for me to keep you awake after a very good lunch. So my duty is to keep you awake for the next 30 minutes. That is a difficult task, but I will try to do it. Now we are living in a world of artificial intelligence, ChatGPT, etc. And we are moving towards the knowledge society. And here most of the, being the penultimate speaker, now only my friend Murali is left. So it is difficult because already people have spoken everything, nothing is left. And here two people who have worked with Professor Manilal, one is Ramesh, another is Dr. Suresh. They are already here and they have the first-hand information. So I will be concentrating only on bioprospecting and conservation. Rest of the things people already spoke. Because there is no need to take coal to Newcastle. So now I am going to discuss only these things and not going to read all these things, and I will move to the next slide. See, now we are going to move towards the knowledge society. So what is the what is a knowledge society? What are its characteristics? Here you can see on the x-axis if you take the societal transformation, and on the y-axis if you take the economic growth, we moved from the raw materials to the industrial products, information products, and now we are using the knowledge products. And technology, networks, innovation help to achieve this, and agriculture society to industrial society, from information society to the knowledge society. And I feel still we have not moved to the knowledge society, but of course all of you agree with me, we are in the information society. And you see again, if you make it more explicit, this slide is going to help you to understand more about the knowledge society. So we move from the primitive society to the least developed society to the developing society, industrial society, developed society, and now post-industrial. I think Ramesh will agree with me that the period of Van Reed, where in society was in which stage? Huh? Yeah. What he is telling is it was in a developing society stage. I think Murali also will agree with that. Yeah. So now what are the characteristics of a knowledge society? Here you see, we were in the agriculture economy, then industrial economy, and then the knowledge-based economy. Now you can see the, companies like Infosys and other IT industries are, they don't have the physical assets like this. Their entire asset is in the intangible form. And the advantage is there is no need to have the security, because you can see when we move, even in this botanical garden, you can see security guard. But if you have all your assets in the IP format, in the intangible format, there is no need of any security guards to keep that. So you see the characteristics of different societies. Agricultural economy is land, labor, and natural resources. Industrial economy is capital, machinery, and management. And knowledge-based economy, there science and technology play a major role, and innovation and entrepreneurship. So now that is very, very important. And again, how do we fructify knowledge-based industries? As I was telling you, now most of the industries are going towards these knowledge-based industries. Their science, technology, and knowledge-based industries are mostly science and technology based. And you see how it fructify. See, all this are required for the knowledge-based industry. And government is giving tax incentives, then venture, legal system, societal support, etc. And now, all the previous speakers were mentioning about the product development. So you can see, if you go through this funnel, see the screening happens, and finally you get, one or two products if you are very lucky. Dr. Ramchand was clearly mentioning about these things. So now, we always talk about our, glorious past. And these are the inventions or innovations happened in India. I'm not going to the details. So now, coming to the biodiversity, that is our core issue. We have, all the ecological units like alpine, temperate, subtemperate. No country in the world may have all these ecological units, and vegetational zones, biotic province, biomass, all this we have. And we have the, all of you agree with me, we have tremendous biological diversity. We have the 4 hotspots, and one of the hottest hotspot, that is Western Ghats, also in India. And tremendous endemism. You see 33% of plants are endemic. That means it is found only in India. Why don't we take advantage of this endemism? And this also, one of the speaker was mentioning, this I have taken 2013. You see 248 new species as early as in 2013. Every year, the BSI comes out with this kind of data, and they give publicity also. But what we are doing with all these species? So now, in a nutshell, what Hortus Malabaricus is giving to us? The previous speakers already told about the botanical content. 742 plants with 794 illustrations. Then medicinal knowledge of many species, thanks to Itti Achudan and the other 3 were associated with. In fact, when Van Reed was compiling this information, it seems every time 200 people are with him to document this. That is a tremendous, and he was the Dutch governor, and he was having all the power to employ. And the Maharaja of Cochin and Zamorin of Calicut was also helping him. So it was a tremendous work. And you see the cultural contest, then trade and colonialism. See, all this happened after Vasco da Gama in 1498. Vasco da Gama landed in Calicut, and after that, they found the sea route, and lot of other country people came to India, and they have one thing. Their interest is the spice found in India. They don't. They were not bothered about India's condition, or they don't want to improve the Indian conditions. And spices were the attraction, and Dutch were different. Dutch were, not that, they were not entirely involved in the governance. They were giving full freedom to the Maharaja of Cochin and, Zamorin. And Van Reed was, really fascinated by the plant diversity of Western Ghats. And this idea was, in fact, the previous speakers were telling how to help the, Dutch people with the new medicines, because medicines were costly and it was coming from different places. How to help, that was his main idea. That is the reason he, in fact, he approached the Maharaja of Cochin to get the services of Itti Achudan. In fact, I was really surprised because Itti Achudan was, the untouchability was ruling those days. People were not mingling, caste-based system was there in the society, and the lower class were not able to mix with the upper class. But Itti Achyutan was one of the celebrated local healer, and he was helping Van Reed, and that is because of the king only helped Van Reed to get his services. Then the scientific legacy, in fact, that is what this workshop is. Then visual documentation. So this is in short about the Hortus Malabaricus, and this thing I am leaving because already more learned people, because I am only a student, rest of the speakers are all learned people. I am only a student of biology. In fact, what the tech guru, the former CEO of Bill Gates told is, now AI is taking over our life, only 3 jobs will be remaining. Rest of the jobs will go. One is biologist, next is energy expert, third is coding. So I am safe. I think most of you are also safe because all of you are doing botany or biology. And my son and daughter is also safe because they are doing coding. So I am safe. So make your life safe. That is my idea. And this, I'm not going to the details because I already spoke. This also. But these are all the surprising elements of Hortus Malabaricus. In fact, last year, after I got a call from Anup Balan, I was, exploring the Hortus Malabaricus, whatever possible way it was possible. Then, I was thinking what to present before you. This is nothing new because already people spoke. Then, each volume, what it contains. So I have just taken volume 1 and 2 and volume 5 and 6 randomly. There is no, I have not made any choice. I just randomly took. And about Western Ghat also. Again, I'm not going to the details. You can see this, and if any of you want my presentation, that also you can take. I have no issues. But I worked for 2 weeks to come out with this. So another interesting thing, I was searching in the internet, who did PhD in this. So one of the foremost is, as everybody was telling, Dr. C.R. Suresh is here, a lonely person. He was not making any sound. In fact, he should have been the person making all the sound. Instead of that, we are making the sound. So hats off to him. He and Dr. Manilal brought this into the limelight, and give a big hand to Dr. Suresh for his monumental work. I think he is here, and I think, but I was trying to get the soft copy. It is not available, and thanks to UGC and the Shuddh Ganga, now most of the theses are available online, and you can freely download it and you can see. And this second one which I was giving here is, it's from Department of Malayalam, Calicut University. But it's not a good thesis, very badly done. I feel pity about that because they have not understood what is Hortus Malabaricus. Because their idea was something different, but it's not a good thesis. Another interesting thesis I found, this is from outside, that is from the Victoria University, Wellington, and that is also available online. But the language was a little bit, flowery language. It's not in a written in a scientific language. But one chapter is entirely on Hortus Malabaricus. That was very interesting. The colonial legacy, they were dealing in that thesis. Now, coming to the subject proper, my last 40 years I have been working on the conservation of horticultural genetic resources, mainly ex situ conservation. And you can see in this, these are the areas we should do the conservation field gene bank. And you can see, if you see around morning, we had a morning walk, and we found, it is a really marvelous work, and the team, Sam Tando, should will be, congratulated for bringing this alive. And in fact, I was told Dr. Suresh was also helping them in collecting the diversity. So now again, how Hortus Malabaricus will help in the conservation? What are the conservation elements in that? I was just going through. And see, all of you agree with me, it's a historical baseline for species richness. what was the species richness in that period, that is 17th century, when Van Reed and his team was collating this information. Then rediscovery and habitat mapping also we should do it, and I think now Sam Santosh is going to establish the research institute along with this garden, and I think they have tremendous responsibility to dig out what are all there in this Hortus Malabaricus, and facilitates the locational tracking of native and endemic species. This also to be done, and the support for the threat assessment. See, threat assessment is very important. I think all of the botanists will help me, because which are the species get a priority for conservation. For that, IUCN is doing the threat assessment, and we should go for the threat assessment of all these species. And already Shashidharan sir told me in the morning presentation what are the species mentioned in the Hortus Malabaricus coming under the different threat categories. Then preservation of ethnobotanical knowledge. Ramesh was telling in detail about this thing, so I am not going to touch. He is an authority in that, and done very good work on that aspects. Then tool for ecological restoration and promoting conservation awareness. The very purpose of conducting this workshop is, first is creating an awareness for the conservation of the species mentioned in the Hortus Malabaricus. Then, as all of you know, conservation is practiced in two different ways. One is in situ conservation, and all of you agree with me that it is the best form of conservation. See, the concept of conservation is also evolving. So, when I started conservation, they were telling it, you can conserve ex situ everything. Now, the Biodiversity International, which is the agency of CGIAR, they are telling now you should go for near in situ conservation, because conservation ex situ conservation is minus evolution, and minus evolution, what is happening now? Another factor has come, that is climate change, and with the climate change factor, if you germinate the seed taken from a seed bank, not going to survive, because when it was collected, the climate was different, and now it is different. So we have to consider that factor. So we should conserve now in situ only. So we should give more emphasis for the in situ conservation. So as Shashidharan sir already mentioned about the sacred groves, restoration of ecosystem is very important. Then community-led conservation. The people it should be a people movement. Then only conservation will be successful. Then ex situ conservation strategies, I feel, along with the field plants, we should have the seed bank. Botanical garden, they already have, and we should use these resources for through sustainable cultivation. Now, what are the challenges we are facing when you use this Hortus Malabaricus information for the conservation? As the learned taxonomies already told, we have the taxonomies gap, and one species which Dr. Prabhukumar was telling, how the validation is difficult. How difficult is the validation? Because already 350 years over. From where it was collected, the original locality would have been changed, and the species would have evolved. All these factors you have to consider. So one is the taxonomist gap. Another is habitat loss. Habitat loss is a big thing, and very difficult to find in the same habitat. Then limited accessibility, because a lot of changes happened in the landscape. Then funding and resources, as all of you know. Then climate change, which I already mentioned. So as far as the conservation is concerned, I am just summarizing here. So the information is available in botanical data, illustrations, vernacular plant names in different languages, and traditional knowledge. So these are the 4 things we can use it for the conservation of these plant resources mentioned. Then coming to the bioprospecting. See, the issue is the Hortus is containing a lot of ethnobotanical data. This can be used as a lead or clue, as Ramchandra was telling, for developing new molecules, new therapeuticals. But how to use it, how effective it will be, he was telling. Now 25% of the market is with the plant-derived drug only. So there is scope. But how we are going to successful, we don't know. Then phytochemical investigation, using the modern tools. What is the difference between when one is time and now is, we have now well equipped. We have different tools available for exploring the plants, for bioprospecting the plants. Then in vitro and in vivo bioassays, then selecting species for sustainable cultivation, because cultivation is the best way for conservation. You imagine paddy. Paddy will never go extinct. Paddy will never go because it is ped kam amla. You have to fill the belly, you need rice. So, and the rice in India, you know how many rice varieties are? We have 50,000 rice varieties, not one or two. So imagine, so rice is not going to become endangered because daily we are using. Then cross-referencing with modern pharmacopoeias, the pharmacy scientists mentioned, and Ramchand was also mentioning. And I was more interested in the IPR, ethical access and benefit sharing. I'm going to tell more about that. See, those days when he was collecting and when he was documenting, these things were not there. After the CBD came, that is in 1992, everything changed. Till that time, the genetic resource of plants was available to everybody. But CBD, the landscape of genetic resource changed, and now it belongs to the country of origin. If the species is originated in India, we have the full right. If it is originated in some other country, they have the full right. So this thing came into the picture. Then database creation and digital annotation is very important because that can be used for different things. So this is the workflow of bioprospecting. You can see first you have to screen, then cross-check, collect, prepare extracts, isolate, then file IPRs and develop a formulation and commercial application. And I was wondering this, whether, this is again from Ramesh and Manlal's paper. I just compile it. See, this is the, diseases and number of curative plant mentioned in the Hortus. How effectively we can use this? That is one question I am throwing to you. Because young minds will have different ideas. Now, the question I was telling about IP is intellectual property. What IP you can generate from the Hortus Malabaricus? Patent. But patent is given only for a new invention, not for discovery. Discovery and invention is completely different. Then to get a patent using this data is, it will be very difficult, but as Ramchand was telling, there is possibility. For novel drug formulation, extracts and processing methods, then we have to do the herbal anti-diabetic formulation, that is an example. Then trademark for branding the product based on Hortus plants. Then copyright. Then I feel geographical indication, there is a lot of possibilities. Because some of the plants are, you will find only in particular place and with a particular quality. So for those plants, we can apply for GIs. And the GI registry located in Chennai is, they are very flexible. They are giving, whatever we submit, they are giving GIs. Then the traditional knowledge digital library, that is TKDL, started by CSIR, and it is helping us to how to get rid of the, the biopiracy. So the main issue with the main advantage of the Hortus Malabaricus is we have a lot of biopiracy issues that we can solve using this information. Then again, these are the general limitations like taxonomy, which taxonomy is already mentioned. I am not going to. Then conservation, then validation, equity ethics, language is an issue, but Professor Mandlal salt that it is now available in English from 2003 onwards, and 2008 onwards the Malayalam translation is also available. But to my surprise, one of the former director of ISR want a copy of the English copy of this, and then he asked me, Rajshekaran, how I can get a copy of this. And I searched with because it was published by Kerala University, it is out of print, not available. So that is the state of affairs, and I don't think they are interested in printing it again. And that time it was 20,000 for 12 volume. Then these are the application area and the scientific impact, that is indigenous knowledge, bioprospecting, which I already mentioned, then conservation biology, genomics and systematics, the Ritesh already mentioned about that. Then history, ethics and science, education, intellectual property and global scientific culture. So these are the application area and these are the impact which is going to make. Then these are the pathways to utilize Hortus Malabaricus information, that is traditional medicine. Then it's not Ayurveda. I feel, Itti Achudan was practicing traditional medicine. Ayurveda is different, I feel, because Ayurveda in Kerala, Ayurveda is based on Ashtanga Hridaya, written by Vagbada. Those days, the traditional healers they are using their indigenous knowledge, not Ayurveda. Then taxonomy and genetics, this information can be used. Conservation, which I already mentioned. Then you have to digitize cultural tourism, indigenous rights, all this. For all this purpose, we can use the information. So you may ask, what is my credibility in telling all this? So I just show you a glimpse of what work I did last 33 years at IIHR. IIHR, as all of you know, it is one of the ICR Institute, Asia's biggest horticulture institute, 150 scientists working on different aspects of horticulture. And we got the Best Institute Award among the 99 ICR institutes in 2019 and 20. So first thing is the pollen cry bank. In fact, Dr. S.P.S. Khanuja was mentioning about the pollen cry preservation. This, we did for the last 40 years, and now this technology has been transferred to 6 seed companies, and seed companies are using this for the production of hybrid seeds, especially in vegetables. So we moved from conservation to utilization. In fact, late Professor M.S. Swaminathan used to say, conservation without action is only conversation. So we moved to the utilization stage. Then we established a field gene bank. Here, this was established, utilizing the, we got a project from National Medicinal Plan Board, 2.36 lakhs, 10 institutes, 10 centers were involved, and ICR was the lead center, and 32 RET plans, RET medicinal plants were taken and collected the diversity and established this field gene bank. So these are the different views of the gene bank. And every year we used to get a lot of visitors, especially students, and they used to wonder these plants are existing on Earth. See, this is a fully organic, and even the hedge plants are, all are medicinal plants. Then we had another project that is on Maduka insignis. Only 18 trees are left on the earth, and this project was supported by DBT, Department of Biotechnology, Government of India, and using biotechnological tools, we could conserve this plant. And what we did is we developed the protocol for rapid multiplication, and we transferred these plants into their native localities, that is in wild, with the help of the Karnataka Forest Department. Then coming to the publications, this is one of the publications, the book on conservation and utilization of horticulture genetic resources, another on conservation and utilization of threatened medicinal plants. And this is exclusively on the protocols we developed on pollen preservation. And now the second edition is coming. That is again with 55 protocols. I am editing, and I think on Monday it will go to the editors, and this month end it will go online, and total protocols we have more than 100 species. So coming to the end of my presentation, to address the challenges of 21st century, it is essential to integrate the valuable knowledge and wisdom preserved in ancient literature and traditional agriculture with modern science-based technologies, thereby creating synergies for the effective conservation of biodiversity. So thank you all for patient listening.
Thank you, Rajshekhar sir, for the interesting and very informative presentation, and you have made it very short. I think the advantage of the last speaker, having many others covered introduction part. And we have time for a couple of questions. He has saved the time.
Any questions? I don't think, because people are shy about asking questions. Okay, thank you very much.
Thank you, sir, for the interesting and engaging presentation. As a mark of our gratitude, I invite Dr. Anup Balan to present a memento to Dr. P. Rajashekharan.
Shall we move on to the next paper by Dr. Murali Gopal on scope of microbiome research in Hortus Malabaricus. Murali Gopal, sir, please.
Our next speaker, Dr. Murali Gopal, is the head of the Division of Physiology, Biochemistry and Post-Harvest Technology at ICAR-CPCRI, Kasaragod. A microbiologist by training, he has dedicated 3 decades to research on coconut, arecanut, and cocoa with pioneering work in farmer-friendly circular bioeconomy technologies, plant beneficial microbiomes, and microbial safety of value-added products. Dr. Gopal has authored nearly 60 peer-reviewed publications and is the recipient of prestigious recognitions including the ICAR Interdisciplinary Team Award, the Rothamsted International Postdoctoral Fellowship, and the Mahasav Scholarship for Studies in Israel. He also serves as advisor to the Union Public Service Commission and the Food Safety and Standards Authority of India. Sir, we welcome your session.
Many thanks to you for this introduction. At the very outset, I would like to be grateful to Sam Santoshji, Dr. Anup Balan, and my very good friend Anand, I do not know if he's here, to bring me together with my teacher, who was the first speaker of this event, Khanuja sir, and my madam, Archana madam, who is also a microbiologist. She's also my teacher. My pranams to both of you, madam. So I thank Sam for this opportunity. And while I was visiting Linnaeus Hammarby in 2007, that is the home of Carlos Linnaeus in Sweden, unknowing to me, I didn't know anything about Hortus Malabaricus. The 2007 Malayalam version of Hortus Malabaricus, written by K.S. Manilal, was being released in India. In 2003, I think the English version had come out. Totally unknown to me, 2007 till this year, 2025, I am here yesterday or day before yesterday, walking into the gates of Hortus Malabaricus. I was in Linnaeus' place in Sweden in 2007. Carlos Linnaeus, the person who has developed the binomial nomenclature. But I think the whole world should know that everything started here from Kerala with Itti Achudan's knowledge of traditional medicinal plants, which was written by Van Reed, and probably which became later a great motivator for Carlos Linnaeus. This is in his home. A bust of him is kept inside his house. And he wrote Species Plantarum and also developed the binomial nomenclature. You can see in 1700s, the Hortus Malabaricus was written, and 100 years later, it was propelling Carlos Linnaeus to write Species Plantarum. We are one of the nations with rich people of knowledge. Unfortunately, we really recognize them very late. Being a microbiologist in the agriculture system, our main work has been focused on soil microbiology. For agriculture or for any plants to survive, soil is the basis, Mother Earth. Soil does so many things which helps the above ground life to survive. If there is no above ground life, there is no life here. But the actual driver of the soil is the millions and millions of microorganisms that is present. So if you take one spoonful of soil, it has 10 times more microbial population than the population of human being on the earth. There's a huge life in the soil. As somebody said, soil is not just an inert material, it is soul of infinite life. And microbes, insects, there are so many other lives in the soil that drive the soil ecosystem services, because of which we have the life above ground. If these microbes were not there, there is no life anywhere. In terms of the biomass, if you recall, Dr. Khanuja has mentioned, within our body, about a kilo or 1.5 kg of microbial cells are present. Similarly, in soil, if you take 1 hectare area, there are about 200 to 200 kg of microbial biomass present in the top 30 centimeter of the soil. These are invisible, powerful organisms because they sequester huge carbon. They sequester huge amount of nitrogen and phosphorus, which is needed for the plants to grow. So, in other terms, the soil microorganisms that are plentiful in the soil are the resource of nutrients for the plants to grow. How it happens is that we know the soil microbial biomass is the eye of the needle through which all organic debris must go, get decomposed, and then come out as the individual nutrients. If this, again, I reiterate, if these microbes were not there, decomposition of organic matter will not take place, and there will be no availability of nutrients for the plants. So, it is the most powerful invisible organism with which we have to be very focused now. And long years back, if you take a forest system, the leaves and litters and detritus falls, and that becomes the food of the microbes. However, in the arable agriculture soil, we have now gone on to apply inorganic fertilizers, forgetting the organic inputs. And we are not giving the food needed for millions of microbes that is present in the soil. And we are losing them. Just like we are losing so many plants, so many animals, we are losing the microbes also. And they, as I said, we are all in this diversity, biodiversity. Here we have a biodiversity of plants in this beautiful garden of Sam's. And we are all together. We are all connected. Somebody in the morning was trekking Alkananda, if she's here. She was looking at the birds that is present in this garden. So we are all connected. The bees, the flower, the ant, the plants, the sparrow, and the microorganisms. We are all connected. And the moment we start losing one, other, and other, we are no more in this earth. We ourselves are gone. Very interestingly, in the August of this year, in the early weeks of August, IUCN for microbial conservation was established. So this is a very big achievement. Like we are conserving the plants, like we are conserving the animals, now we are started conserving the microorganisms through this IUCN's new movement. So I'm very glad to be here this August to present this particular work. So the scope of microbiome research in Hortus Malabaricus is what I would like to briefly present. Though you are all, many of you are from Kerala, my institute, the Central Plantation Crops Research Institute, is in Kasaragod, northernmost district of Kerala, and it's 110 years old institute. It has a legacy which is really great. We work on coconut, which is the first crop that is written in the Hortus Malabaricus. Areca nut, which is the second crop written in the Hortus Malabaricus. Cocoa is not there, it's a foreign crop. Palmyra is the third crop in the Hortus Malabaricus. So now I feel that, oh, CPCRI, where I am, where I have been working for last 30 years, is greatly working on the three important first crops written down in Hortus Malabaricus. I'm so excited, so delighted. Briefly, I would like to touch upon microbiome. I do not know how many of you know this, how many of you know of this concept called holobiont. The seniors in the front will definitely know. The students, I would like to see if they can learn this. How microbiome influences plant, and a bit of work which that we have done, and what we can do of microbiome in medicinal plants, and what I have in mind of microbiome research for Hortus Malabaricus. Today morning, if you had listened to Ritesh, he was mentioning that there are new types of platforms which helps in sequencing of the nucleic acids. Likewise, for the sequencing of microorganisms, we have several platforms now. And one of the science that is driving the advanced research in microorganisms is the metagenomics. This was coined by Jo Handelsman, a lady who was the who was a scientific advisor in the Obama government. So this particular science has helped us to study the microbiome or the gene that is present in the genetic material of the microbes in large numbers. In millions of microbes can be genetically sequenced in quick time. And this has given rise to the new subject of microbiome, which was coined by Joshua Lederberg in 2001. I can never forget my Guruji here, Sir Khanuja sir. He had taught us all about the basics of molecular biology 40 years back. Joshua Lederberg was one of the very important subject which he used to take. And so the microbiome can be described as some total of genomic contribution made by the diverse microbial communities that inhabit the surface and internal tissues of multicellular organism. If you remember yesterday, he started telling that we are all multitudes. Within us, we have many more times the microbial population than our own cell. So if we move like this, it moves with us. If you move like this, it moves with us. So he had set the stage for me very nicely. So we are all microbes, but I will end in that way. This has again given rise to a new term called holobiont. I think this came up in 2008. So we are not alone now. If I am Murali, I am not Murali. I am having some 10 trillions of microbes in me. So maybe so many of microbes and me together is the holobiont. So what is the holobiont? It's a phenotypic expression, which is some effect of host my genome as well as the complete genome that is present in the microbes, that is present on my or inside my body. And this has become a unit of selection, very radical theory that has come up, and it's being proved now that yes, indeed, from a mother, the microbe is passed on to the child. And that vertical transmission keeps happening. So we are all evolved. If you, as a botanist, if I ask you which are the two important plant organelles that has come from the microorganisms, can anybody say that? Two important organelles in plant that has mitochondria, chloroplast. And what do they do? The two most important function. One is photosynthesizing, production of energy, and another is the energy bank. The mitochondria gives the energy to photosynthesize. Both are of bacterial and archaebacterial origin. So we have evolved together many millions of years back. Similarly, within us also, we have evolved together with the microbes, right from our birth, same way as plant does, as well as the human being. Again, we have very common thing. If you take, this is the rhizosphere of the microbes, and if you take our gut, they are loaded with microorganisms. And microbiome is the second genome for us. Again, if you recall yesterday, we understood by our lead speaker's talk that there are only 3,000, how many genes, sir? 36,000. Yes, 36,000 genes. Unfortunately, they don't reflect the bodily functions which is being performed. So we have other genes coming from the microorganisms within our body, which is, like influencing our bodily functions. So microbiome is also called as the second genome of human being, and it controls human and plant health. I will quickly leave this. Any change in our microbial population in our gut, any change in our normal health is immediately affected on the, felt on the microorganisms, or also the microorganisms cause the, health issues. And it can be, now we say that it can be alleviated if we can restore the normal microflora within the gut particularly. So that's the concept, and we have thought same thing can be followed in agriculture. If we have a plant that is healthy and we know completely what kind of microbiome it has, and if we have same plant that is diseased, and if we can transfer the microbiome, we expect and we hope that the diseased one also becomes healthy, and these are happening research everywhere around the world. Microbiome influencing many of the plants, many of the plant functions. Today I was struck by one of the presenter when he said, I think the first presenter when he said, Professor Manilal's entry into Hortus Malabaricus started by one particular observation that if we rub the left toe with some plant material, the right eye is affected. Imagine you apply something on the toe and it affects the right eye. Same way is now what I think the microorganism is going to affect the plant. If you might have wondered how can a microbe influence the plant's growth, and here are the examples that I would like to say. One, that the flowering phenology of plant is also now understood to be related to the rhizosphere microbiology. So quickly I'll give a small graphics of that. Then selection on soil microbiome reveals reproducible impacts on plant functions. These are very solid group of workers which are full of plant biotechnologists and microbiologists who are working, bioinformaticians who have worked and they have written this paper. So here is the example, like they have worked on Arabidopsis. On the left side is a normal, flowering Arabidopsis. On the right side is a fast flowering Arabidopsis. So they completely profiled the microbiome of the rhizosphere, and they found there is a significant difference in between these two. So what they did is when they applied the quick flowering microbiome to a slow flowering Arabidopsis, and to their surprise, they found that that plant also flowered quickly, which means that there is an way by which the microorganisms are controlling the flowering also. It's very epigenetic. I wish again to sit with Professor Khanuja sir to learn all these basic genetics, molecular genetics. Would you believe if I say microorganisms are also a reason for plant heterogeneity? I don't think any plant scientist will agree to it. But this is the kind of work that is emerging from very good lab in very good publication journals like PNAS. Really, they say that you can induce heterogeneity, that is diversity in plant in terms of genetics by application of microorganisms. So, two quick examples of how microorganisms can influence the plants. I will skip all these things. Yeah, one thing which we wanted to propose a perspective is like we have the seed vault in Norway or someplace in Svalbard. There is a seed vault where in extremely cold conditions, seeds from all plants all over the world are preserved. We thought it's time that we also preserve the microorganism that is associated with each plant to be preserved. It's not easy, but there are works going on to preserve the whole set of microbiome, not individual microbiome. For that, we already have culture collection centers. This is for the whole set of microbiome. So that's the kind of beginning I want to say, and then quickly to what we have done with coconut. We have completely analyzed the microbial association of coconut, and we have with us 512 excellent microorganisms associated with coconut, which we had collected from Kerala, Karnataka, Tamil Nadu, and all over the place where in India where coconut is grown. And again, Professor George Thomas would identify this work. We had started our basic understanding of the microbial genetics with SciGenome. We had a partnership with them, and we completely did a whole genome sequencing of 3 best plant growth promoting rhizobacteria, which we had isolated from coconut, cocoa, and areca nut. We had done very nice work and published it. And we were very happy to see whatever functions which we had already proved, kind of reverse engineering or reverse direction study. We had already proved that our organism was capable of improving the health of coconut palm when it is inoculated in the seedlings. And we knew which all mechanisms were there, and to our very happy surprise, all those mechanisms were found at genetic level after this whole genome sequencing was done. With their help, we had published this paper in 2014. We are also completely profiled the mycorrhiza that is associated with coconut, and we are having about 40 fungal species in our microbiome vault of coconut. Aside this, we also work on recycling of the waste that is generated from palms. Huge quantity of waste is generated, and earlier times it was used for so many purposes. Now we are using it to be used as a manure for soil. So as I said, 2 things our soils are lacking with each passing day. One is the organic carbon, and associated with is the microbial diversity. So we have a technology for converting coconut leaf to vermicompost. This is a beautiful high density multi-species cropping system which we have in our institute. And this system kind of generates huge quantity of waste, and we have developed several methods to convert them to useful soil amendments. One is the vermicompost, another is coir pith compost, then we have biochars, and likewise. Again, today Dr. Ritesh had spoken in the morning. With him there is another gentleman called Dr. Kamlesh Jangid in Agarkar Research Institute. Along with him, we had done the whole microbial study of the conversion of coconut leaf vermicompost to the coconut leaf to the vermicompost using the special earthworm which we have in our institute. And I will leave this. This is the steps. We had extracted the DNA from all the stages of the vermicomposting, including the earthworm gut, and we found that it's full of microorganisms. The vermicompost becomes rich with microorganisms that are helpful for the soil health as well as plant health. very complex output from bioinformatic analysis. But what it says is our vermicompost is rich in metabolites that would help the plant to overcome pathogens, that will help the plant to improve its root growth. You see here there is penicillin, all type of antibiotics present in the vermicompost. Here you see it produces siderophore. If many of you would know that it helps in preventing pathogen growth. And here you see there is indole biosynthesis, which is promoter growth promoting hormone. So all this is present in the vermicompost because of the presence of the microorganisms that is there. So these are the type of work which we have done. And for the farmers, now we have this product which we give to them. One is the vermicompost, another is the coir pith compost, and these are our bio fertilizers for coconut and cocoa. So our work does not stop with the basic studies. We are also going out to the farmer. From soil, now I shift to Nira. Most of you would know that Nira is like we tap from Palmyra, this beautiful kallu, otherwise, if it is, like known for. We tap this. My current director had developed a very clever method of keeping the Nira unfermented. So you see the box here, he has developed a simple box filled with ice. And this box is fitted to the inflorescence from which we collect the Nira. You see the color of the Nira. Ordinarily, if you go to a toddy shop or something, it will be whitish in color. But this is the pure Nira, brown in color, and it has totally different properties of what that is available in the market, the fresh toddy or whatever we say. This we have called it as Kalparasa. And again, with SciGenome, we had done complete metagenome analysis. That is the type of microorganisms this Nira has. And we really found that the Nira is rich in probiotic bacteria and probiotic fungi. That is probably yeast, like Saccharomyces, like Hanseníospora. So these are all extremely, extremely good microorganisms that is present in our Nira. So very healthy drink for us from our own Kera. So slowly moving away from direct, like agricultural research and this thing, we have now found that the microorganisms present in the Nira can be used for many purposes. And one of the things that we have found recently is to produce pure cellulose polymer from the microorganism, native microorganism that we have isolated from the Nira as well as coconut water. And we are converting the coconut water, which is waste in many coconut, small-scale coconut industries like coconut oil producing agencies. The waste coconut water can be converted to a very high-quality cellulose. So we have now, first time, kind of made use of the microorganisms that is present from the coconut plant. And this is not Acetobacter xylinum, which is commonly used for produce Natadi cocoa, which is also bacterial cellulose. This is a different native, first time native bacteria, Comagati bacteria intermediates, that we are using to convert coconut water waste into very high quality cellulose, pure cellulose. And this has excellent application in food industry, in agriculture industry, and pharma industry. So we are working more on it, and we believe this could be the first good product coming out of our lab, which is not directly for the farmers, but more of an industrial application. So how I translate all what I know in microbiology for the Hortus Malabaricus garden here is that we can also do a complete microbial study of important plants which can be identified, because as I already told, they influence the plant growth in many ways. They also influence the metabolite that is produced by the plants, and we can use several technologies to achieve this. I will skip this. or maybe I'll just say that there are several bioactive compounds that has been isolated from the microorganism that is present inside the plants. So bioactive phytometabolites produced by microbes in the plants. So I'm sure each medicinal plant that is present in HM is a rich source of microorganisms, endophytic microorganisms, and if we do the bioprospecting, we may get very good, useful metabolites. The CCMB in Bangalore is very focusedly working on neem endophyte as well as neem epiphyte, and they have now a big project of producing all important metabolites that is produced by the neem using this fusarium. One is the like melanin pigment, which they are started producing using the fusarium that is present inside the neem plant. So you can now imagine that we need not restrict only up to the plant. We can go next step as a research scope for Hortus Malabaricus. We can find out if it is rich in endophytes, and we can find out if these endophytes can help us in production of some of the important bioactive materials. So melanin is one, and CCMB is already working on production of azadiractin and so many other things just using the microorganisms. So it looks very odd that we are leaving the plant out of the equation and using the microorganisms that are associated with the plants for producing the metabolites. Tulsi, our most holy plant. If you go to the sacred grove here, Tulsi is there in front of all the deities, Vishnu and Shiva and this thing. This has been worked in Belgium. Belgium people have worked the complete microbial profile of the Tulsi plant, and they are now trying to see how it can be used for different kind of metabolite production. In China, they are completely analyzed the ginseng rhizosphere microbiome, huge potential now. A new science that is there, that is if you combine those who do tissue culture, there they are now finding that if you combine the plant with some microorganisms, some particular metabolites are produced in large quantity. So this is called biotization, and this is an exciting area which can be tried here in HM. Fermentation. So medicinal plants can be allowed to ferment so that their pharmacological effects improves. I think one of the classic example was from Sir's work, where they have improved the effect of antibiotics, sir, if I remember, using some Taxol. So anti-cancer drug using some plant input. So that's a classic example, and we know that golden milk, the bioavailability of the property of milk, when you add curcumin in it, improves. So those are enhancers. In same way, we can ferment the medicinal plant. Right across is, I think, there is Ayurveda hospital, Ayurveda college. So I think there can be a good scope of doing fermentation of medicinal plants and see whether that fermented plant can improve the pharmacological properties. That's one scope which I want to say. Overall, if I am given the opportunity for working on microbiome research in HM, my short-term goal will be to profile the endophytic microbiome of target plants. So if you say that these are the plants we want to study, we can straight away, very easily, using simple microbial lab facilities, we can do this. Medium-term goal, I think we should try to relate if the endophyte has some metabolite characterization, and more importantly, at ecological level, we would like to see, because of conversion of some forest land to the HM garden, what kind of changes has taken place in the soil microbial diversity. And as Ramchand sir had told, ultimately there has to be some economic value, so we can think of some products that can be developed. A long-term goal, product expansion, and I wish we can have a microbiome vault for the horticulture Malabaricus garden. So if I want to just summarize my presentation of the association of microorganism with bigger organism, I will go to a small mythology. Krishna always has the habit of eating soil, mud. So Yashoda ji will get angry and open your mouth. So he will say, Amma, I did not eat any mannu. And but still she knows that he has eaten. I think all of us in our childhood would have eaten soil, I'm sure. So when she asks him to open his mouth, he opens his mouth, and what does she see? The whole world. So if I bring back to you that soil is a soul of infinite life, it has millions and millions of microorganisms. Microorganisms define us. So she sees the whole world. So I say, soil is the soul of infinite life. Soil is our cosmos. Soil is our mother. So inside the soil is everything, and that we eat in the childhood days. This is a mythological thing. A more recent one, if anybody reads the comics, English comics, there is this comic called, what is this name? Snoopy? Peanuts. Charles Schulz is the cartoonist. So he has, just before, I think he passed away a few years back, he wrote, this is the dog, Snowy, I think so, and this is the peanut. I'm not remembering the name. Snoopy. Snoopy says, you are so dirty to him, but he says, no, I'm not dirty, I'm microbial. So remember, we are all microbial. These two are very fantastic examples, which I think I borrowed after going through the HM garden, seeing that how they have integrated the modern with the old, with the religion. And yes, thank you so much for your patience. Thank you very much.
Thank you, Dr. Murali.
Thank you, madam.
For introducing this microbiome to us and the work at CPCRI and around, Bangalore and all that, on these new lines.
Yes, madam. Thank you so much for your...
Can I ask you time for two questions? I think we are completing with this, about 9 papers, lead papers on today, with an introduction of INAUGURAL. So I think a couple of questions we can allow. Be quick.
I think we will leave, madam. We'll go for yeah. Anand has a question. Anand, you have worked with me. No questions from you. Yeah, please.
Sir, you were mentioning about the importance of microbial life with reference to Arabidopsis, right? So will it be a synergistic system to photoperiodism, or it will be a totally independent system as its own? What do you feel?
Once again, will it be synergistic to photoperiodism, or
will it be a system by its own without reference to photoperiodism?
See, there is a whisper, which I'll borrow the word from my teacher. Yesterday he was telling, it whispers, plant whispers. So there is some whisper going on between the plant and the microbiome that is associated with the plant. And during that whisper, probably the microbiome, through epigenetic mode of action, alters the, genetic function of the plant. So whether it directly influences the photoperiodism, I may have to read that paper more thoroughly. I just didn't read it completely. But maybe it is some other factors. I do not know. We will have to see. But sir, you can help me? Yeah, that Guruji has come.
Part during the day and night, it shows some of the things which are overlapping and some of the things which are very distinct in plants. And out of those distinct things which day and night are there, they will be acting as signals for these microbes to take up their job. And that is where they are helping. So, most of the time we are interested in the anabolic part, photosynthesis. But then to balance that, respiration is important. And perhaps that is the reason even students had answered that plastids and mitochondria came from microbes. So that's the relationship which works in such association. So that's what I can understand.
Okay then, if you finish, thank you. And I think we can wind up this section. And I'd like to recall that I met Professor Manilal sir as my MSc examiner for the first time, for the previous as well as for final. Thank you.
Thank you very much, sir, for the informative presentation. May I now invite Dr. Anup Balan to present a memento to Dr. Murali Gopal as a token of our appreciation. I also request our session chair, Dr. K.K. Sita Lakshmi, to kindly receive memento from Dr. Anup Balan in recognition of her time and contribution to this session. Dr. Maya C. Nair. We have now come to an end of all the technical presentations. We'll be moving straight into the valedictory function next to conclude this insightful two-day journey, and we'll enjoy the tea break right after that. We are honored to welcome our chief guest, Dr. Sanjeev Kumar, Assistant Director in Charge, National Ayurveda Research Institute for Panchakarma, Cheruthuruthi, Thrissur. Sir, we invite you to share your reflections. Before moving on to the chief guest speech, I invite Dr. Anup P. Balan for the welcome address.
Respected chief guest, Dr. Sanjeev Kumar, eminent speakers, distinguished delegates, dear students and friends, good afternoon to all. So we are moving on to the conclusion of our two-day international workshop on the research potential of Hortus Malabaricus. Today we have Dr. Sanjeev Kumar as our chief guest in the valedictory function. He is the head of National Ayurveda Research Institute for Panchakarma, an institute under Ministry of Ayush. It's our neighbor institute in Cheruthuruthi. So as you know, Hortus Malabaricus is all about the medicinal plants of Malabar region. So we have got an apt person to deliver the valedictory address. He's an Ayurvedic expert. So we have got an eminent person having an Ayurvedic background. So I extend my warm welcome to Dr. Sanjeev Kumar to deliver the valedictory address. I also extend my warm welcome to our eminent speakers who have shared their deep insights and enriched our knowledge over these 2 days. I welcome all the delegates and students come over here from different parts of the state, even from neighboring states. We are grateful to you for your presence and active participation during the last 2 days. Once again, I welcome all of you to this voluntary function. Thank you.
Thank you, Dr. Anup. Respected dignitaries, esteemed scholars, students, distinguished speakers across India, abroad, ladies and gentlemen, a very good evening to all of you. After coming here, this is first time I have come to know that in the vicinity of Cheruthuruthi, such a beautiful place it is here. I would have missed it. I would have missed it if I had not been invited by the organizers. So at the outset, I would thank the organizers for inviting me and to have interaction with such eminent personalities. It is a great honor, rather I would say I am truly overwhelmed be here among the august audience. For last 2 days, you must have discussed, explored the treasure of medicinal plant, which was documented 3 centuries ago, during 17th century. And surprising to me still it is, lively and full of life. Everybody knows that this Hortus Malabaricus was documented during 17th century under the guidance of, sorry if I cannot pronounce the pronunciation of that name, Hendrik van Retd. So the then Dutch governor of Cochin, I was going through the literature before coming here. She hired 25, the scholars, the other supporting staff to document the medicinal plant. And it is the happiest moment for me. One of them was, I won't say one or various would be there, the local herbal healers. They could tell him that this is the therapeutic uses of this particular plant. That is why they could be able to document it. And later on, it was translated in English as well as Malayalam. Earlier it was documented in Latin. Again, I would say that the great emeritus Professor K.S. Manilalji, who was in the, I forgot the university name, Calicut University. So he devoted more than 35 years to translate this Latin literature into English and Malayalam. I have just come to know that before 2 years, if I'm not wrong, 2024 or 23, he left the body heavenly. So he devoted more than 35 years. The best part of this Hortus Malabaricus is that it was treatise on medicine plant, but after 3 centuries, still we are discussing on these plants. We are finding something new. We want to research on these plants so that we can serve the society at large. My dear friends, I won't take much time because I have come to know that you have preponed the program because eminent speakers might have come from different part of India, might be going back. So before leaving this place, I would like to mention or leave with you 3 things. We should value our heritage. Value our heritage doesn't mean that we should only protect the medicine plant physically from destruction. Along with that, the traditional knowledge, wisdom, as well as the cultural significance should also be preserved with that. Second one I would like to mention here, we should validate through research. So whenever the traditional wisdom, knowledge, and we integrate with the modern science, that definitely something will come out which would be beneficial for the society and community. And the fourth one, which is the most important thing I would like to mention here, is that dissemination, for which we are here to disseminate the outcomes, the observations we bring out through the research. So the further students, the scholars can study it further research it, and after researching it, these can be benefited to the society. So these heritage or medicine plants, which the potentials they are having to benefit the society. That is why whatever observations we made, we should share among the young generations. Otherwise, these things would remain in the archives, or these would be locked in the books. So there would be no other benefit out of it. So we should keep it alive in the people's mind and work. So with these words, I thank again the organizers, as well as I congratulate the speakers for enriching us with their wisdom, knowledge, and obviously the participants for their dedications. For last 2 days you have been attending this workshop. So I wish you all success in your future endeavor. Last but not least, I would like to say that the seed you have sown today will bring more fruitful avenues in future. Thank you.
Thank you very much, Dr. Sanjeev Kumar, for your inspiring words and for gracing this occasion with your presence. I now invite Dr. Anup Balan to present a memento to Dr. Sanjeev Kumar as a token of her gratitude. Before we proceed to the vote of thanks, we would like to hear from our delegates. We now open the floor for our delegates to share a few words about the workshop. Your feedback is greatly appreciated.
Hello, my name is Dr. Uma Chandran. So that was a very nice experience, and actually that took us back to our heritage. Thank you so much.
Good evening, everyone. Respected experts and my dear friends. My name is Sharanya. I'm a research scholar from Department of Botany, SD College, Alappuzha. So, last 2 days were truly inspiring. For me, I'm just a 7-month-old researcher working in both taxonomy and molecular phylogeny. So, getting to know about the research potentials of Hortus Malabaricus was an exceptional experience to me. And saying about the sessions, I really have to thank the master brain behind this, because how beautifully you have curated all the sessions. From today's session, in the first session was carried out by Shashidharan sir. He was giving a bigger picture of the plants mentioned in Hortus Malabaricus while emphasizing each and every wildlife sanctuaries and national park. And he ended the session by saying a controversy related to Symplococcus. And then Prabhu sir took that point, that is a single species mentioned in the Hortus Malabaricus was taken, and he explained us how he dealt with that. And I was really excited to see the kind of observation he has put on that particular impatience, like a single question mark, the kind of observation he has given to that thing. I wish that on my journey, I wish to develop into something like that. And then Sir Chaudhary sir was explaining how to do that. So Prabhu sir explained how he did that work, and Chaudhary sir were explaining that how to do that from the basics of DNA to the most advanced molecular techniques. And with that, I wish to say that yesterday Suman sir was explaining from the DNA basics. Really like, what to say, it was really a enriching experience, sir. I cannot forget to mention you also. So Chaudhary sir, you also explained about the molecular markers, and that was such a great experience. Then Rajsekharan sir, coming to the conservation part, he also explained the relevance of the conservation part. Then all the experts, I can't remember all the name, but I want to thank each one of you for getting to know the different areas of this plant. So usually everyone say that plant biology or botany are going to extinct, and events like this are actually fueling my passion and making me travel more. And thank you so much, each one of you, for sharing your wisdom, sharing your, I know each one of you talked about your work, 30 years or 20 years of your work in half an hour. And thank you so much, sir. And this was great opportunity for, and Anup Balan sir, Sam sir, thank you so much for giving us such a wonderful opportunity. And once again, I know thank you is a simple word, but I don't know, I am not unable to find a word for that. And thank you so much. And each one of you, I was getting an opportunity to networking also, getting to know different people working in different fields. So each one of you, thank you so much.
Dear speakers, you can also share your feedback about this workshop.
Hello, good evening all. I don't know how to start with, but first, how I came to know about the workshop. So of course, Dr. Prabhu, whenever I'm in a kind of taxonomic problem, I have one God only. So whom I know, I consult him. So one day suddenly he called me, okay, there's a workshop, would you like to just speak? So I actually never been to this place before, and I had some engagement, but still, since God is telling, of course I cannot deny. So I accepted, and once I visited here, and then today, honestly, I should confess that the value of Hortus Malabaricus during these 2 days, what I came to know, I never knew this much important work it is, and kind of things were deciphered during this workshop. It was amazing. So thanks to Prabhu and to the organizers to inviting me here. And of course, Dr. Anup Balan, who kept me in loop all the times, very much updated with like what I have to do, like the schedule, with everything. He's very perfect. So thank you, Dr. Anup Balan. And I should again confess that whenever I come for a talk to Kerala, I'm a little bit afraid. But I know the audience would be all learned. So I have to prepare very well. But after coming here, of course, it was a wonderful experience. Good you didn't ask me many questions, but I hope you enjoyed my talk. And many of them I already know before, many students in the faculties. And whenever you are arranging a workshop or seminar, we call that as the backbone of the workshop is the food you provide. So it was very nicely arranged. So again, thanks to the organizers for arranging wonderful food of my choice. And thanks to everyone, and thanks to a different part touched by other speakers, like Prabhu, as I spoken, the way he spoken on the morphological part. So that gives me insights also, what more I can explore using this genomic data. And thanks to everyone for this.
In fact, one day I was getting a call from Anup Balan asking me whether it is possible for me to give a presentation here in the Hortus Malabaricus garden. In fact, I was not knowing much about this, only through Kumar. Kumar earlier told me there is a wonderful place where all plants of Hortus Malabaricus is getting established, and it is it is not like any other garden. You should come and see. In fact, I was looking for an opportunity to visit this garden. So Rogi Ichichadam Bale Vaidyan Kalpichadam Bale Bale workshop. And after the telephonic call from, and I happen to be the chairman for Anup Balan's PhD Viva, and since then I was in touch with him, and I used to see his social media post. He used to give a wonderful post in Facebook about his explorations, his presentations. So I used to see fire in him, and he was able to take that fire to the next level and join this garden as a scientist in charge. And I wish him all the best in all his efforts. And I feel he is not a typical taxonomist, because a typical taxonomist, they go for exploration and find some new species, and mostly the taxonomists in Kerala, they used to report in either in Malayalam Manorama or in Madhrubhumi. That is not much science involved. So science involved, in fact, I was really surprised with the kind of, in fact, 2-3 presentation, I was really impressed in this workshop. First one was Dr. Kumar's. Second was, in fact, the best one was from Dr. Shashidharan sir. And I always used to wonder from his first presentation to today's presentation, he always, making the best. He never used to compromise on the quality of the presentation. The photographs, the way he presents things is outstanding. So he was given the wonderful start, taken over by Dr. Kumar, and the zenith was Irdesh Chowdhury. In fact, I know his guru is also, is one person moved from taxonomies to the molecular biology, and he always used to publish excellent papers, and he used to share all his papers with me, and I used to wonder how he can do such a wonderful work. So now again coming to the experience here, 2 days till now we are in some, I was feeling we are in some other planet, taken care of all the aspects very nicely. The entire team of the Hortus Malabaricus, I salute you from my bottom of my heart. Give a big hand to all of them. They, wonderful. Everybody, I am not, telling one person or 2 person. The entire team sitting here and, working in the canteen and the field staff, everybody. In fact, when I was walking, I have a problem in walking, and 2-3 people are coming, sir, do you need help? So that is the kind of people here. And as Sharanya was telling, the person who has thought of conducting this workshop, Sam Sandosh, I feel it's a dream for him. In fact, I was asking Kumar, because he was my contact person, what is his vision. So his vision is
I think the great vision Dr. Professor Mandlal sir was having, and Mandlal sir he was my teacher. So I used to feel, happy that, I had opportunity to listen him, his classes, and his Shishya, Dr. V.V. Shivarajan was our taxonomy teacher, and he used to take his class to the, some other levels. So I could reach to this level only because of such great personalities of our teachers. I used to feel that, I'm blessed, had such a wonderful, and the Department of Botany in Calcutta University was one of the best. Even now it is one of the very best department, and we used to have excellent teachers. So now coming back to this Botanic Garden, morning we had a walk through the garden, and I was wondering, the kind of vision Santosh is having, we should salute him also. And I feel what is lacking here is the research part, and while by joining of Anup Balan, now the real thing is going to happen, and I think in next 5 years we can expect some wonders from this garden, and I give all the best to Anup and team of people here, and I would like to thank from my bottom of heart all the people here who made our stay, our food, and a wonderful workshop experience. And I think all the students will agree with me. For them it is food for thoughts. You take cue from this, develop your interest in the subject, be passionate in your subject. And I am so happy that most of the students, I know the students from Victoria, then Sharanya, then so many others who have taken interest to come here and participate in the workshop. And you are the torch bearers. You have to take this subject to the next level. And as I was telling in my talk, the botanists or the biologists need not worry. Their job is not to be taken away by the artificial intelligence. So you should be happy that you are not going to become jobless. Your job will be you can do better jobs, but that is not a solace. We should do our best. And again, thanking all of you for listening my talk. Thank you.
Thank you for your valuable suggestions and reflections. They will certainly help us in shaping future programs. Now I would like to invite Ms. Minu, Head of Human Resources, HMBGRI, to deliver the vote of thanks.
Good evening, everyone. As we come to the close of the international workshop on the research potential of Hortus Malabaricus, it is my honor and privilege to deliver the vote of thanks on behalf of the organizing committee at HMBGRI. First, we express our gratitude to our chief guest of the valedictory function, Dr. Sanjeev Kumar, for gracing this occasion and sharing his valuable insights. We sincerely thank our keynote speakers, session chairs, delegates, faculty members, resource persons, and invited experts for sharing their valuable knowledge and perspectives across various disciplines. To the researchers and students, both on-site and online, thank you for your active participation. Special thanks to the scientific committee, logistics and hospitality team, and documentation and publication team for their careful planning and excellent execution. A big thanks to our technical support team, including the sound and AV crew, media and photography team, and live streaming coordinators who worked behind the scenes to ensure a seamless experience for all. We also extend our heartfelt thanks to the support staff for taking care of every details from comfort to safety. Special thanks to our communication and publicity team for effective outreach, and to our printing and designing team for the beautiful brochures, banners, and certificates. Sincere thanks to Dr. Anup Balan for his outstanding effort in initiating, coordinating, and leading this impactful workshop. Your dedication and seamless execution made it a great success. Heartfelt thanks to Mr. Sam Santosh for his visionary leadership in establishing HMBGRI and for making this event possible. His initiative and efforts in bringing together such valuable delegates are truly commendable. Finally, we thank every single individual, named or unnamed, who contributed to this workshop in any capacity. This event was a collective achievement, and we are truly humbled by the teamwork, passion, and purpose shown by each of you. Thank you all once again, and wishing you safe travels and continued success in all your endeavors. Thank you.
Tea with refreshments have been arranged downstairs, and I request all the participants to collect their certificates for participation from the registration desk downstairs. Thank you. May I request all the speakers to stay back so that we could have a group photo?